All right, guys. Today we're going to talk a little bit, or a lot of bit, about inspecting electrical systems. I think I'm standing in the right place. Hollis will let me know if I'm not. This is a guide to good electrical inspections. It's just kind of a plan of attack that I've come up with over the years to help me be proficient in my electrical inspections. This doesn't mean you have to follow my rules. It's just kind of an idea to give you some pointers on how you can kind of simplify your inspections where you're not running all over the place. This is my contact information. If you'd like to photograph that or write it down, I'm going to offer a water heater chart later in the presentation, and if anyone wants it, contact me and I'll send it to you in a PDF form. I don't have it printed out here, but it's a pretty good little reference chart if anyone wants it. Or I always tell class members when I do a class, if you have questions or a month from now you're on an inspection, if you got my contact, if you want to ask me a question, send me a picture. I always try to get back to you. So if you got that, has everybody got that wants it? Okay, we're going to move on. Okay, here's the introduction of what we're trying to do today. And it's basically, I'm not going to read it all to you. You can read it. Can everybody see that okay back there in the back? Okay. It's just basically to develop a logical procedure for your electrical inspections. Now, each component of a home inspection, you kind of need to have a procedure for how you do the whole thing. A lot of guys will start upstairs in the house or outside. A lot of guys like to go in the attic first before they walk a roof to see if there's a broken rafter they're going to fall through or something like that. It's just everybody here are home inspectors, and you've got a procedure that you do, I'm sure. But this is just kind of focus on a procedure for electrical inspections, and to try to put that into place. It makes you more time efficient, and it kind of eliminates mistakes. If you'll follow a repetitive plan, that'll help you with your inspections. Okay, we're going to start. We're doing our inspection now, so we're going to, like I say, this is just kind of the procedure I use, so you can use this and modify it how you like. All right, start outside. Of course, you pull up to the house, and I generally would do, and a lot of times you'll get to the property before the client or the agent shows up, so you've got some time. So I'm sure you guys run into that too. A lot of times you'll start your inspection sometimes before anybody gets there. So you're outside and you've got access to do what you need to do. So you're outside, you're looking at your service supply. First thing you got to look at and determine, is it overhead or is it underground? You know, that's something we usually note in our reports to describe the system. So you look for that first. Okay, if it's overhead, take a good look at your conductors, your riser, everything associated with that overhead service. Is it secured properly? Does the riser look okay? You guys ever get on the roof and look at the drip loop and see the cracked insulation in the wires where it's old and it's been there for a long time? That's a reportable issue. Even like if it's overhead, the triplex going back out to the pole to the transformer, look at that. Even though that doesn't belong to the client, that is a safety issue. If it's, and the utility company needs to be brought in to replace that damaged triplex. So look, I generally look all the way back to the transformer. Even though that's utility owned, I want to see everything that's going on that I can see back there. If it's going through a bunch of trees, you know, some utilities have easement rights where they can clear the foliage around the triplex, and others, I'm told, in different, that's the way they do it in my part of the country, but some will leave that up to the responsibility of the homeowner to keep that cleared away from the triplex. So look at that. Okay, you want to locate and inspect the enclosure and the meter and the meter base. Find where that is. And we'll talk about looking at meter bases here in a minute. You want to know, kind of get your bearings on where that comes into the house. You want to identify any visible grounding electrode, ground rods, and the GEC, grounding electrode conductor. Now, We're going to talk a little bit more about this later as far as describing the grounding system on a residential service or any service. In reality, we can't confirm that that grounding electrode system is correct. It's subgrade. Unless you got a backhoe and a shovel, you're not going to be able to really tell me that ground, you see the top of a ground rod, but it may be that deep. You know, you can't confirm that it's proper. So just note in your report what you see. Don't put a blank statement in there. If you saw a ground rod and a clamp and a GEC going up to the meter base or the service equipment, don't say it's all good, because you don't know it's good. You just say what was visible was a grounding electrode conductor, tell where it lands. A lot of them go into the meter base, some go into the service equipment, and you did or did not see a visible ground rod. I don't dig and look for them. If I don't see it, and most of them around where I am, if the house has been there very long, additional grading over time, erosion, whatever, they get covered up. You're not going to see them. So what did I do? Okay. Okay, identify the location of the service disconnect. That's the first means of disconnecting power coming to the building. You want to know where that is. That's your service equipment. So you want to find it and note where that location is. Okay, while you're outside, you want to inspect all exterior receptacles, any wiring outside, outlets, light fixtures, anything on the exterior of the home. Look at all that while you're doing your exterior inspection. Condition of those, exterior receptacles, confirm GFCI protection. You know what you're looking for there, but just look at all that while you're doing your preliminary outside electrical inspection. Okay, and you want to look at any HVAC disconnects, any sub-panel disconnect. If there's a pool, there's going to be probably a sub-panel disconnect out at the pool room or somewhere on the exterior buildings, anything like that. You want to identify all of them, note the location of those, and inspect them. You want to open them up and look inside of them. Any exposed wiring, defective conduit, you guys know, you see a lot of that. There's a lot of homeowner electrical installations that we run across where it may be a PVC, sometimes it's a water pipe they use for conduit, white PVC running across the ground out to the garage. Anything like that you want to pick up and note and make notes about, and confirm that it's safe. Safety is the primary issue here. Okay, like I say, I like to start out at the street, at the pole. This is the utility transformer. And we'll try this. I'm not getting my clicker here. Okay. We'll get back to that. That's my little pointer. But the one on the left here is a utility transformer for a single phase service, typically residential. You know it's single phase because you see the one can. That's one transformer. The one on the right is that's for a commercial building. I think that's actually a church. That's three phase. You've got three transformers. One drop, you can see not a triplex, 4 wires, it's a quadruplex coming off down to the bottom. That's going to the service equipment, and that's a three phase. That's just kind of an FYI. If you do like commercial, which I'm sure some of you guys do, you're going to see a lot of three phase setups. So you can drive down the street and go by a place and you look out on the pole and you'll know, you don't even have to slow down, you know if it's three phase or single phase by the transformer. Now, that being said, some of the newer, bigger transformers, they put all of the three windings in one great big can on a three phase, but it's going to be pretty good size. But typically what you'll see is the three transformers. So that's where you start your look out there at the pole. What you can see, I use binoculars. I'll look at the tap connectors on the secondary and primary side of those transformers, make sure they look okay. They get weathered and damaged over time as well. So take a look at that. You want to look at your service drop. This is for an overhead feed. That's the riser and the weather head, the drip loops. I'm gonna try this again. I don't know why that's not working, but okay. Still don't have a laser pointer. We'll get to that. The drip loops, you want to have that loop. That's to drop any moisture off of those conductors. Sometimes you'll see them where they don't have that loop, and it'll go straight down into the weather head. That's not a correct installation. So you want that loop in there. You want to look at your conduit straps. Make sure that riser is securely connected to the building by conduit straps. And you can see the little porcelain anchor for the messenger wire that's tied into the side of the home. That's an important thing. While we're looking at this, if you didn't know this already, the messenger wire is the steel cable that's bare that the two other conductors are wrapped around. That is your neutral feed to the house. It serves two purposes. It's a support wire called a messenger wire, and it is the neutral to that house. So if that is compromised, damaged, or anything, you've got a problem, open neutral to the house, and that happens. Squirrels love to chew on those things. They'll gnaw them in two sometimes. I've got another presentation I've got with a house that actually happened, and it had some dire circumstances. So, yes, sir, we've got a question.
Back to transformers, would you look on the ground underneath and on the transformer?
Guys, please.
Can you use the mic? That's okay. Well, I'll repeat what you say. If is that okay? I'll repeat his question. Yes, sir.
On a transformer, especially an older one, would you observe the ground and look for black staining, maybe a leaking PCB?
He's asking on an older transformer, would you observe around the ground under the transformer? I think you're saying looking for any leak of PCBs. The older transformers had that. They're oil filled now. They've gotten away from the PCBs. Yeah, I mean, if something was obvious, I would note it. I don't know that I've ever run across that. You may have. I have not. But any staining or any obvious deterioration to the transformer, yeah, I'd report that to the utility company. Thank you. That's a good question. Okay. I just said this. Look closely at the connections, the drip loop, riser and conductor condition, because you're going to see a lot of damage on these. You know, these wires, some of them, these houses, these triplex feeds and so on and so forth, service entrance conductors, have been out in that weather 50 years sometimes, you know, some of these older homes. And the utility companies, they don't have a electric police that goes around and inspects and tells you your triplex doesn't look good. That's up to you. I mean, now, if they're conscientious enough in doing their job and they see it, they should report it back to their supervisor and get it fixed. But most of the time, they don't. They're doing other things. They don't care. See that very often. You guys see that sometimes when you get on the roof? Very common. And it's just an old conductor that UV deterioration over the years has gotten to it, and it's cracked and that insulation's coming off. I've seen it actually completely fall off in 1 and 2 inch sections, and it's just bare. So look for that. You see that old riser next to it. It's kind of like me. It's old, crusty, and rusty. That doesn't mean its structural integrity's gone, but it's been there a while. That gives you an indication it's old. Okay, what do you see with this one that gets your attention? See the messenger wire I was talking about? That's your support to hold the conductors to that riser. It's broken. That little strap on that bottom goes around that porcelain loop, and it's broken. So that one has got some good slack in it, but all the tension is on the conductors itself. And sometimes that's not a good indication, but I've seen them pulled just very tight. And then that's putting the pressure on the butt connectors where the utility connects the point of attachment to the residential. And you sure don't want that pulling apart. Understand that none of these wires in this picture right here are overcurrent protected. There's nothing on them to limit the amount of current that can happen if they short to one another. Have you ever seen in a storm where a tree breaks a triplex to a house, the wires fall on the ground and they're dancing and arcing, and they'll do that till something burns up. There's nothing to protect that. So that's a very important part of the inspection, to look at this stuff, because if they do short out, they're just gonna, they're live. Unlimited amount of current can be, till, you know, they could blow a transformer up eventually. That'll shut it down, but there's no overcurrent protection on those wires. Okay, there's one to look at. Now this one was one actually that I did on an inspection a few years ago. I got on the roof, I'm looking at all my shingles and whatever you look for on the roof, and I go over to where the triplex is coming into the riser, and I see this. Then I look down, I remember my truck's parked directly under this. So I ease back down my ladder and move my truck, because it's windy, and you can see where that has arced over time. It's a wonder that it hadn't burned in two, but that hot conductor is shorting out and arcing against that neutral, and eventually it's going to burn up. So we were able to contact the utility company on this particular inspection, and like I said, I found this when I first got there. Before I left, they were out there, let me finish my inspection. They were going to pull the new triplex from the pole to the house and replace that. But that could have been a very catastrophic situation there. And it was, like I say, I was pulled up right near the house. This was going to fall down and short out right almost at the front door or the side door. So look at this stuff when you're on the roof. Is a good place to look at it. Just be careful when you're getting around that stuff, because we'll show in a minute, a lot of those butt connectors are not insulated. And that's another thing we're going to look at, like right here. You can see the connectors from the service drop to the service entrance conductors at that weatherhead. And you can see where they're deteriorated. There's a little bit of something left on there. A lot of the old ones, they use friction tape. Just wrapped them with tape. Well, that's going to last, you know, a finite amount of time, and it's going to deteriorate. They've got all kind of connectors now. Some of the newer plastic ones, we'll show a slide of it here in a minute, are also problematic. That's these right here. That's a newer, but see the one on the top? Over time, the sun, UV damage, and that thing pops open. Well, when its brother right next to it pops open and they touch, we're going to have some fireworks, because that's line to line short, unprotected, like I talked about. So really look at those connectors at your service drop. That's very important. Those things should not be, if in a proper installation, you know, they should be pulled apart. Those wires are pretty stiff. You can separate them, get some distance between them, but this was kind of a sloppy job, probably an older job, but that's a newer type and the utility company puts those on. That's their responsibility, at least in my jurisdiction. They're responsible for that splice and the insulation on those connectors. So if you're in a house and you see those connectors and they're bare or the insulation is deteriorated, get with the utility company or have the owner, buyer. You can do it, or typically you put it in your report and tell them utility company needs attention to this, and they'll come back out and they'll rewrap them, re-splice them if necessary, and they'll take care of it. Okay,
Mike, we got a question from the remote audience. He's wanting to know, what would that do to the breaker panel? What would that do to the breaker panel?
If they short out?
Yeah.
Nothing. Well, it could backfeed a breaker panel because it's a dead short, but the problem is going to be at that point of contact. That's where the boom's going to be, right there, and it's going to blow something open. So the breaker panel service equipment is downstream of that. So this is an upstream fault. So it's the problem's going to be right there. Okay. Service lateral. That's a term you need to understand and learn. I read guys' reports sometimes, and I've seen them put in a report the overhead service lateral had some damage. Well, if it's a service lateral, it's underground. Service laterals are not overhead. Lateral means underground. It's buried, comes up into the bottom of the meter base. This is something that you guys have probably seen, probably not this severe, but if you look closely, always look up under those when they come up, that conduit comes up out of the ground, and look at the attachment of that conduit to that box. A lot of times you'll see them pull out, and sometimes if you don't get under there and look, it'll just be a little bit of separation. This one, didn't have to get on your knees to look at this one. This one was pretty severe. Now, when this happens, at least in the utilities around where I am, I've installed several of these, and the way it works, I would supply the trench, dig the trench, put the conduit in the trench, put a pull string or rope in the conduit, and the utility pulls in the conductors. That's their job. Different from the overhead, where you put the conductors out of the riser, and then they put the triplex down and attach to it. I'm about to unwire myself here. So in a service lateral, they pull those wires into that conduit and make the termination to the line side of the meter base. So when something like this happens, you've got to get them involved. We've got to de-energize that to make the repair. So the utility company is going to come in. They're not going to fix it. They're going to come in and disconnect power, and if they need to pull, if the conductors are damaged, they'll redo that. But it's the homeowner's responsibility to pay the private electrician to make the repairs. He's got to fix that, get the conduit. What happened here is those trenches, when you put that conduit in that trench, is supposed to have a certain amount of gravel to secure that conduit, because particularly in new construction, you know how the ground will settle around the perimeter of the home, around the footing. That's what happened here. They had a big void evidently in this trench, and that conduit over time, weight on it, pulled that down. Now my question was, that goes down and makes a 90 going back out to the transformer. That's got to be putting some stress on those wires, because that's a pretty big drop. And when it goes down at 90, it's pulling on those wires. How it didn't pull them out, I don't know. They must have some slack in there from somewhere that it was able to take up. But that was a pretty severe drop. That's an indication you can see where some slippage has gone on that riser coming out of the ground up into that meter base on that conduit clamp. You can see, sometimes you'll see streaks. Now, what you're seeing now a lot, and it's a good addition that they're doing, is a expansion fitting on the service lateral risers. And it's a PVC part that goes in, and it allows some movement in that conduit without affecting the conductors. And that's most utility companies are starting to require that now, because to eliminate this problem. You guys see that in the field much? Every now and then? You do? Yeah. Okay. Talk about electric meters a little bit. The meters are property and provided by the utility. The meter base enclosure that it plugs into is provided by the homeowner. The installing electrician puts that in. You have to get with your utility companies. In my jurisdiction, where I've done some work, mostly they'll tell you what type. They use a certain brand of meter, Millbank or Midwest or somebody, Landis and whatever that other name is. And you have to put that type enclosure in so their meter will fit in that socket. So you find that out first, or the electrician does, and they put it in. But what's kind of unique about this is if there's a problem in that meter base, loose wire, burned up wire, anything, bad lug, loose connection, that's the responsibility of the homeowner. They have to get that fixed privately. Now you have to get the utility involved to pull the meter so they can safely work on it and make the repairs and put it back. But even though it's yours, You're not allowed to open it up and look in it. They put a seal on it. That's to keep people from tampering with their electricity and bypassing the meter. You can jump around the meter. So that's why they keep you out of it. A lot of people, I kind of have a problem with that. You know, I'm buying for it. I bought it. I'm paying for it. I'm maintaining it, but you won't let me look at it. I mean, they will, but you're going to get a permit and get them to come out and pull the seal off while they stand there if you want to look at it, and pay them $100 and say, okay, I've seen it, and seal it back up. So just keep that in mind, that the enclosure, anything that goes on in there is the responsibility of the homeowner. The meter itself belongs to utility. They plug that into your meter base once you install it. Okay, we got different styles. One too many of meters and meter bases. This is a typical line load feed through electric meter up there at the right, and that plugs in to a socket, that meter socket. It's got 4 stabs, 2 line stabs, 2 load stabs, and it just plugs in. I think I may have a picture. I can't remember if I have in this slide of a meter base without the meter in it. I may not have it in here, but it's just, it plugs in. It's got male stabs on the meter that go into the, kind of like a circuit breaker plugs in. And these, when you pull that meter out, that kills power. That opens the circuit to the house. So if someone, a criminal wanted to, and he was electrical savvy and he wanted to cut off power to your house, he cuts the seal off and pops that meter out and cuts the power off. So that's a typical feed-through electric meter. This is a CT meter, current transformer meter. See how small the little meter is, and the little small 1-inch conduit or 3/4 going down to that meter? This is a CT, and what it is, I'll show another picture one in a minute. If you unplug that meter, that does not disconnect power to the house. All that is a step down. The CT, the current transformer, steps the voltage down. It reads the amperage going through the conductors. Like right here, these are CT current transformers. Well, sorry for the dark picture, but see the 200 marked on this one there, and the wires are going through it. Those are current transformers, and those are measuring the amount of current going through each line, each conductor. Then the small wires go down, tap off of that and go down this conduit on the right, and that goes to the meter. It steps that voltage down. It's usually used on larger 400 amp and larger services. So that's not a unplug and disconnect type meter. You'll see it on large houses sometimes. This is that same service. This is actually a commercial, but that's the CT meter, or the CT meter on the right, that's measuring and metering the amount of electricity used in that building. The big conduit on the left, that's actually the service entrance conductor going into the building to the service equipment. So you're going to see that sometimes, like I say, this is commercial, but you'll see it sometimes in residential. Now, in your home inspection, there's some information you can get off the meter. You're not going to have to, I mean, you don't need to be an authority on electric meters, but knowing kind of how to identify them, and we'll show some of the information that you can get on electric meter. Kind of give you a clue what's going on. If you look on this one, this is a CT meter, current transformer meter, which has the smaller conductors that step down to the meter. If you look, I don't know how well you guys can see it, but it's at the bottom right above where it says Middle Tennessee Electric, we've got a Form 9S, 8S. That's a style for a 3-phase installation. Then it says CL20. CL stands for continuous load. Well, obviously this big building is going to have a continuous load of more than 20 amps. That's a CL20, continuous load of 20 amps. That's an indication that's a step down meter. Now we'll show, and it has the voltage range 120 to 277 volt, 4 wire. That tells you it's a 3-phase meter. So you can get some information off the meter just by looking at it. If you're maybe you're doing a light commercial, you don't know if it's a 3-phase, single phase, it's got an underground transformer, you couldn't see the cans like we talked about earlier. You can get some of that information off the meter by knowing what to look at. That looks like a standard 200 amp, like you would see the box itself is about the size of what you see of a 200 amp on a residential, but that's actually a CT meter for a 2000 amp service. So you would think 2,000 amps, you're going to see this thing as big as a sub-zero refrigerator. Well, that's why a CT meter, it doesn't have all that current going through that. It steps it down to meter it, but all that current's going in that, like I showed that conduit earlier. And that's just a technique they use to, if it was a plug-in meter like we talked about earlier, for a 2,000 amp service, it would cover this stage. It'd have to be that big, the enclosure would, to handle all that. Now, this is a CL320. You can't read that well, I apologize for that, but some of you guys familiar with electric meters, have you understood this before? Did you ever question why a 400 amp service had a CL320 meter? They say, okay, continuous load, 320 amps, but we've got a 400 amp service. My little brain at first says, something doesn't seem right here. But remember, that's continuous load. We'll explain that here a little bit in a minute. We're going to look at, this is what you see most of the time. It's a CL200, continuous load 200. The information tells us 240 volt, 3-wire, form 2S. That's a single phase. Standard, this is what you're going to see most of the time on 100 amp, 200 amp, 225 amp services. You guys see many 225 amp services? We see some, they're not real common, but I mean, they're not a unicorn, but now a 250 amp residential service is a unicorn. I'll show a slide of one later, I think, in here. But typically we'll see 200 and 100 amp services or a 400, but 225s are around. And this meter, even though it's continuous load, 200 amp, it can be put on a 250 amp service. And I'll explain why here next, I think. Okay, the CL on there designates the continuous load. Continuous loads are rated at 80% of the maximum load rating of whatever it's on. So getting back to the 400 amp service, the maximum load rating of a 400 amp service is 400 amps. The continuous load on that service is 80% of that. That's why a CL320 is suitable for a 400 amp service. You're not going to be at continuous load all the time. So it's rated for that. A CL200 is rated for continuous load of 200 amps. So you bump that up, going the reciprocal 1.25%, then you've got 250 amps that it's capable of handling. Now, a lot of times you'll see, you can put a 225 amp service. Sometimes you'll see them on a 320, CL320, but it's suitable for the CL200. Okay, and the local utility generally will tell you, when you get your service release, they'll tell you what size meter base they want when you tell them what size service it is. That can vary depending on jurisdictions. Okay, we'll talk about grounding the system a little bit. I mentioned this earlier, confirmation of a proper grounding electrode system is impossible in most situations for a home inspector, or even for, I do some code inspections. Even if I'm not there if I'm going to a final and everything's covered up, I can't tell you the U for ground is connected unless it's in an accessible part. They can actually connect them underground in some situations. I can't tell you if the ground rod is 8 feet in the ground. Most of the time, we'll talk a little bit about grounding. The second ground rod is usually common to eliminate the test for the 25 ohm ground to resistance. So just be careful in your reporting not to tell someone that you looked at the grounding system and everything is great. Now, in our standard of practice of ASHI in most states, we're supposed to inspect the grounding of the, well, you can do some of it, but you can't look at the whole grounding electrode system. You just can't do it. So keep that in mind. Only report what you can see. I had a blank when I'm retired now as far as doing home inspections, but I would have a blank statement that I would modify from time to time, but I always said that I saw the grounding electrode conductor. Typically you see that going to the, in my jurisdiction, they always would land in the meter base. That's what the utility company wanted there. Or you could see it in the service equipment. So I would mention that I saw that. Now, if I did see a ground rod, even the top of it, I'd modify my report and say, and I also saw the top of the ground rod 2 inches out of the ground with a proper acorn clamp or whatever, but I cannot confirm that it's 8 feet in the ground. And side note, safety. I've had guys in class, they say that when they see that, they'll grab that grounding electrode conductor and give it a good yank to make sure it's good and tight. Don't do that. If there's a problem with the neutral going to that house, like I was talking about, the squirrel chewed through that, that neutral current is going to use that path of that grounding electrode conductor to get back to the source. It's going to take any path it can. And if you pull that loose, you're in series with whatever load is on that, and you're going to die right there holding the ground. And we say grounds are there for our protection. Grounds can kill you. Don't pull on that. And even if it is intact and you're not going to get electrocuted, you pull it loose, you got to fix it. You know, don't be that invasive. Do a visual. If it looks like the connection has got some damage, corrosion, note that. Have somebody tighten it up or come and look at it, but don't be pulling on those. Okay, we've got different types of grounding electrodes. The original were the metal water pipes. That's the older homes. We had typically a galvanized pipe going out to the street, and that's what they would ground the system on. Driven rods. That's what we see mostly now. U for grounds, concrete encased electrodes. That's the building foundation steel, the rebar. They've added that as if it's there, you're supposed to, and accessible, you're supposed to tie that into the grounding electrode system. Ground rings and plates, those are not used that often. I don't think I've ever seen one. I'm sure sometimes they're used, but typically we're going to see ground rods, U for grounds, and metal water pipes. Now, like I said, at one time, the metal water pipes were the normal grounding electrode system. Older homes, sometimes they may have 2 lights in the house and maybe 1 receptacle, and that was the 30 amp service or 60 amp service, and the water pipe was the ground reference. Over time, when first PVC came out, PEC and all like that, plastic took over the water supply system, so we don't have that opportunity to use that anymore. If it is in like an older home, let's say an older home has been updated to PECs, and the old galvanized pipe is still in the ground and it's still coming into the basement or something. If it's still there, you're supposed to tie it in. Tied into the electrode system. It's supposed to still be connected. But if it's replaced, then that's not there, and you rely on the other grounding electrodes. For water pipes to be, yes. Got a question.
Is the grounding of the water pipe different if you have a well?
Grounding the water pipe, is the grounding the water pipe different if you have a well?
I'm thinking about you potentially energizing the pump.
If it's, you still ground it, you still tie to it, yes, sir. All right, I had to have a little lubrication there, guys. Water pipes have to be in contact with the ground at least 10 feet to be considered a grounding electroconductor. Grounding electrode, I'm sorry. The 78 National Electric Code was the first to require that a water pipe be supplemented by a second electrode. That's when that first started. Now, I think I've got this in the slide. If I don't, I'll get back. Okay, yeah, I've got it here. The ground rod should be at least 8 feet in contact with the soil. So sometimes you'll see a ground rod that is visible. Maybe it's sticking up 2 feet. You ever see that where they're a foot or 2 feet? Well, now, if it's an 8-foot rod, it can't be 8 feet in the ground. They do make a 10-foot ground rod. So there again, you don't know how far it's down there. So be careful of what you call out on that. Typically, they're driven down to the ground and you won't see them. If the rod resistance to the ground is more than 25 ohms, a second electrode is required. That's been in the code for a while. Now, that test, if you're going to test the ground resistance of a single rod, it's expensive. You have to have specialized equipment to do it. Nobody does it. Electrician's not going to pay for all that. He's going to drive a second rod at least 6 feet away from the original and tie them together with a bonding jumper, and that's going to, the code says if it's one rod, you have to prove that it has less than 25 ohms resistance to ground. If it does not, then you can drive a second rod and you don't have to have a test. It still may not be less than 25 ohms, but nobody cares if you got that second rod. So that's the simple, you're going to take the simple, least expensive route, you're going to drive that second rod. Or you're going to have a driven rod and the U for ground. That's the second electrode. So but all that has to be tied together. We've got a graphic coming up here showing that. Now the rods can be driven vertically at a 45-degree or in rocky soils where I live. You can dig a trench 30 inches deep and lay it horizontal in that trench. Then again, unless you're there before they cover that up, you don't know if that's done properly or not. But that's the 3 methods of driven rods. Okay, sometimes they're cut short. A lot of times they're cut short. You don't know if they are or not. That's where I live. That's the old UT theme fight song, Rocky Top, but that's where we got our name. There's rocks all over Tennessee, a lot of limestone. So it's difficult to put the ground rod 8 feet vertically a lot of times. I was in Florida one time on vacation and watching a guy, and I think I was sitting by the pool, and they were putting in a service at a condo down there near the beach. He gets the 8-foot ground rod, jabs it in the ground, about 2 feet goes in when he does that, and hits it twice with a hammer, and it's down. I thought, man, you guys got it made here. All this sand, digging is easy, you know. We don't ever get to do that, but yeah, and it may have gone out of sight. It's in the ocean, you know, who knows where the water table's so low. They got a good grounding system down there because the water table is so low.
All right, so Mike, we got a question from the remote audience.
Okay.
I think this is following up on this about needing to, if there's a UFER, you don't need a second.
That is the second.
That is the second.
Yeah, you don't need a second driven rod, no.
So if you have a UFER, you don't need a driven rod at all.
Yeah, yes. Yeah, you got to have 2. You got to have a supplemental rod.
Okay.
Yeah. Yeah. Okay. The concrete encased electrode is the UFER. That's named after I can't remember his name. I won't say George, but that doesn't sound right. Who? James? UFER? Anyway, it's a UFER. They have to be 20 feet in length. It doesn't have to be, they can be tied together with steel ties. It doesn't, some people think that 20 feet has to be one piece. It's generally going to be in the footing. You're not going to see it unless if it's accessible, they bring it up. Do you ever see the inside a garage or something where they got the little box and it's got a cover and you can visually see that connection to the UFER? That's a visual point for inspection. The first one's required 20 feet of number 4 copper run in the foundation, in the footing. Most of the time now, since they got the rebar, hopefully they got rebar in the footing. Where I live, they didn't used to do that, and we've got some wonderful settlement on some of our older homes where they just poured concrete in the trench, no rebar. So you know what happened to that house after a few years. But that's, Mark will talk about structural conditions on stuff like that later. It was not mandatory to use that system initially. What the code tells you now, like if the water pipe's there, you have to tie it into it, even though that's not the standalone. If it's there, you tie it into the system. If the UFER's there and accessible, you tie it into the system along with the driven rods or whatever type electrode you have.
All right, so Mike, we've got 3 more guesses: Henry, Herbert, and Herbert.
Herbert, I believe that's right. Herbert is right.
All right.
That sounds right to me, Herbert UFER. Okay. Right here, I'm going to give a shout out to Code Check, Douglas Hanson and Skip Walker for providing me with these, letting me use their illustrations in my presentation. These are great illustrations that they offer that you can, I guess you can purchase from them if you want to, and you can put them in your report, but they give some good illustrations. This is showing a grounding electrode system. This is more likely a industrial or a commercial building, but it just shows all the options where you can tie. This is the UFER. Wish my pointer was working. I don't know what I've done to that, but anyway.
Point at your screen. See
I'm
if it comes up.
Point at screen?
No, at the computer. See if it comes up there. Okay.
No.
It was working.
Yeah, it was. I may have.
He's got a laser over here. He's got a laser.
Okay. Thank you, Sean. This is the, yeah. Changing laser pointers, guys. Hang on just a second. There we go. All right. Thank you, Sean. Now I have to learn how to operate this one. Gotcha. Okay. Can you guys see that? What about the remote guys? Do they have enough? Can they see that? Okay. This is the UFER connection right here. This is a water pipe. See how it's all tied together. This is a service equipment panel going out to building steel. This is a steel column. That's tied into the system if it's a steel building. The rebar in the footing. See how that's tied in with the steel ties and that stubbed up for accessibility. This is a driven rod. Water pipe here, 10 feet in the earth. And this has answered the question about the UFER. A single rod with a resistance less than 25 ohms must be supplemented by another electrode. Okay. So that kind of shows all the options that you can have with, and it even shows a ground ring over here to the left, which I'm not, that's just a conductor that runs around in the earth so many feet. I don't even know the details on that because I've never seen one. Okay.
Mike, somebody's asking about a clarification on T5. What was that T5 on that slide?
T5.
Size per T5?
Oh, the size of the grounding electrode conductor? Size per T5. That's a table he's got in the code check books that I don't have with this slide. It's a reference. If you have the code check books, you go to table 5 and it shows the various size requirements for grounding electrode conductors for the various size services. Typically on a 200 amp service, you're going to see a number 6. In my jurisdiction where I do work, the utility company says, regardless of the size of the service, until you get up to big services, 200 and smaller, they want a number 4. So that's their call. The code says 6 for 200, but the utility says 4. Okay, and these are the grounding electrode conductors, GECs, that are going out to these two parts of the grounding electrode system. All these shorter wires are called bonding jumpers, which are tying all these together. But the grounding electrode conductor must land, it's continuous back to the service equipment or the meter base, wherever it's terminated. Talk a little bit about gas piping. Okay, metal gas pipes are not allowed to be used as grounding electrode conductors. They can't be part of that system, but they have to be bonded. There's a little bit difference in using it in the grounding electrode system and bonding. It's bonding on the load side in the home. You'll see a steel gas pipe. Sometimes you'll see them, typically they'll be bonded at the gas water heater. And we'll talk a little bit about CSST bonding too. You guys are familiar with that, where that can make you dizzy and all the requirements that they're arguing about and butting heads on that. We'll talk about that in a minute. So they were first prohibited in 1990 as far as being grounding electrode conductors. So we look back, you'll see there's no gas pipes included in this grounding electrode system because they're prohibited to be included in the grounding electrode system. Grounding electrode system is a specific system, and it's different from bonding downstream. Keep that in mind. GEC, grounding electrode conductor. It connects the system neutral, which is the grounded service conductor, to the grounding electrode system. We'll go back and look. It connects. The service neutral is going to be in here at your service panel, and it lands there. These are two grounding electrode conductors. They're tied to the service neutral and tied to the grounding electrode system. That's what a GEC is. There's 3 locations that are allowed for the termination of the GEC. Like I mentioned earlier, my jurisdiction requires it to be in the meter base. A lot of places it's service equipment. But the code says you can put it at any of these 3 conditions, positions. The utility will usually tell you where they want it. You have to go by their rule. They're the boss, really. They don't have to, they've got their own rules, and you have to comply with them or you won't get your service release. So one place, and you won't see this very often, but at the load end of the service drop, sometimes you'll see a wire that's connected to that neutral up there, and it may run down the side of the house and then go into the ground. I've seen a few. You ever seen that? It's not real common. Usually on older homes, you would see that sometimes. They drop it down from there. Typically, what we're going to see is in the meter base right here or in service equipment. Any of those 3 are acceptable for the termination of the grounding electrode conductor. We're going to talk a little bit about bonding. This is the definition of bonding. Connected to establish electrical continuity and conductivity. Okay, what does that mean? It's tying things.
Hello, everyone. Hey, I'm the crack man. I've been around here for probably like 10 years or so at this venue. Thank you all for listening to my probably boring diatribe by this time. But anyway, my name is Alec. I inject cracks and poured concrete foundation walls. Also, I do some cinder block work as far as sealing them up, some cosmetic work on the outside as well. And then also, what I haven't told people about is the water line penetrations, whether it's water or sewer line. I do a lot of those as well. Life of structure warranty against it ever leaking again. And it's also transferable. And I do the work myself, so nothing is farmed out to other entities. And it's the injection process, mostly urethane resin. I will do epoxy if necessary, but most of the time it's not necessary. Then I also do carbon fiber straps for structural issues when they come up, but that's very rare. Just so everybody in this room knows, about 95% of the cracks are non-structural in nature. So, you know, you don't have to be oversold or worried about them being a structural issue and needing carbon fiber. Even though I do it, it's very rare because it's just not necessary. So anyway, I've been in business since 2005 and rarely ever have to go back on a leaking crack just because the process really does work. Anybody have any questions?
It connects the system neutral, which is the grounded service conductor, to the grounding electrode system. That's the definition of the GEC. There's 3 locations that's permitted to make this connection. That's at the load end of the service drop, right there, at the meter enclosure, right here, and or it's the service equipment. Any of those 3 are acceptable. Okay, we're going to talk about bonding now. That's a main bonding jumper I've got circled there that's tying that neutral bar to the metal enclosure. That can be installed or removed depending on the application of that panel, that load center. And this is the definition of bonding: connected to or to establish electrical continuity and conductivity. Means tying conductive parts together, basically, is what bonding is. Main bonding jumpers, different types for different manufacturers. It can be a screw, a strap like I showed earlier. This is a square D Snyder square D panel with the bonding screw, the green screw right there. That's the bonding jumper for that type panel. Now, something that can be confusing, this one doesn't show it. Some of the square D panels, the rivet or screw that ties that plate to that bar, for some reason they like to make them blue. You ever see those? And it's easy to confuse. You'll see that blue screw and you'll think it's that green screw. And at first glance, you know, if it fades a little bit, it looks green. So some people think it's the bonding jumper and it's not. So at least in this one, it's silver, so you can distinguish between them. But you'll see some of those square Ds where that screw, that lower screw is blue, which is confusing. Here again is an Eaton main bonding jumper, tying that elevated neutral bar, which is not touching the can, to the can. If that was a sub panel, you would remove that for the neutral bar. This is a service equipment panel in this photograph. CSST bonding, we're going to talk a little bit about that. The National Electric Code does not directly address bonding CSST. The IRC and the International Fuel Gas Code do. NEC just basically uses their verbiage then that any gas appliances to be bonded through the equipment grounding conductor for that particular appliance, like a gas furnace, so on and so forth. So let's say you've got a gas water heater with it's no electricity on it. It doesn't have a equipment grounding conductor. So that's where you want to bond that gas pipe, and then you're going to have to bond the CSST per IRC and IFGC requirements. I'm not going to read those requirements to you. You can download the detailed bulletin. There's been a lot of controversy and argument about this. The manufacturers of CSST have come out with, Track Pipe has come out with their version called Counter-Strike. I think that's theirs. And it's got the black, it's not the yellow coated CSST, it's got the black coating on the tubing. That has bonding provisions in that coating. So those manufacturers say that you do not have to do additional downstream bonding of that product. You do the yellow. Now, up until the 2015 and older editions did not recognize that provision. They said all CSST should be bonded. So that's where some of the controversy comes in. Do you do the additional bonding on the black or not? I always recommended it. I didn't get over the top, but that way you know it's bonded. Sometimes those guys, when they install it, they cut the sheathing back or the coating back too far. I've seen them clamp it at the wrong places. So you can do your own study on that. I don't know if I don't think that link is still active, but you can Google and find out the requirements from the International Fuel Gas Code and the IRC on CSST bonding. Equipment grounding. All the metal equipment in the electrical system that are considered to be non-current carrying, obviously you don't want your metal junction boxes, your load center enclosures or anything like that to be carrying current. Those are metal parts of the electrical system that are non-current carrying intentionally. Should be connected together via the equipment grounding conductors. That's bonding them together. The equipment grounding conductors actually serve two purposes. They bond the metal equipment from panel to panel or metal box to metal box, and they provide a ground fault path back to clear a fault to trip a breaker or open a fuse. So they're dual function, the equipment grounding conductors are. They actually serve as bonding conductors. Okay, they're typically wires, but metal raceways can be used. Sometimes you'll see a 3-wire feed to a sub panel, and you'll say, well, that's supposed to have 4 because it's got to have the equipment ground separate from the neutral. If it's metal conduit and installed properly, that can serve as the equipment grounding conductor. It doesn't have to be a wire. It can be the metal conduit. And I mentioned the purpose of the equipment grounding conductor. And the connection of all the metal components, like I said earlier, that's kind of the more basic definition. It's where they're all connected together, they're bonded. Now, grounding and bonding gets confused. Are they grounded? They're grounded if it's continued out to ground, but they can all be tied together, and then the last link is not going to anything grounded. So they're just going to be at whatever potential is applied to them, and they're all going to be the same because they're all tied together. So if you bond a bunch of metal cans together, take a hot 120 volt wire and stick it to that can, and there's no path to ground, they're bonded at 120 volts. Does that make sense? I mean, they're all tied together, so they're going to be whatever. So the grounding is the other link to that chain to take it to ground to clear a fault. I did actually see a situation, I don't have it in this presentation, of a detached garage that everything in there had metal conduit, metal boxes, metal fluorescent fixtures tied to this metal building, metal siding and everything. It was all bonded, but they never ran a ground. And actually a hot wire got loose in one of the fluorescent fixtures, touched the fixture, and it energized everything in that building, including the siding, at 118 volts. I've got a picture in another slide. I've taken a reading from that siding to the neutral, which was elevated in the sub panel. It wasn't bonded, and got 118 volts. It actually, when my client got there, it was kind of an embarrassment. The panel door was open on that panel, and it was raised up, didn't have a dead front cover, and I'm talking to him and introducing myself, and I said, well, this shouldn't be open. I touched it. He said, that shock you? I said, it did, but don't worry, I'm an electrician, it can't hurt me. I'm trained in this stuff. So anyway, we did a little checking, and that's what had happened there.
So Mike, we got a question from the remote audience about the, if you could clarify where the CSST bonding, where does that conductor actually go to?
Where the conductor actually, where it goes back to the, should go back to the service panel.
Should go to the ground bus in the panel?
Yes, ground bus and the service equipment.
From where? From the point of entry?
All right, you bond the CSST at the first downstream Well, they've changed that rule. They used to say you bonded at the first connection of CSS2 to the rigid gas pipe. You can bond, now you can bond the rigid gas pipe anywhere in the system. They've changed that in the bulletin. So, and then you take that with a number 6, copper, and take that back to the grounding bus and the service equipment.
All right, thanks.
I do see them sometimes where they carry them to a sub panel if that's more convenient, and as long as they bond it, I don't really care. But I think that rule has changed, and there's still some gray area in that, but as long as it's bonded, I'm personally good with it. Bonding that rigid pipe, you don't tie it to the tubing itself. You can tie it to the clamp where the tubing connects to the rigid pipe. But I've seen them where they put the clamp on they peel back some of the yellow coating and clamp the tubing. And that tubing is pretty fragile. You don't want to put that clamp on there and cinch down on it. So it goes on the rigid pipe. Yes, sir.
I've seen where they take it and tie it to the water service, which is the ground, which goes back to the panel. And I'm just curious, does
Well,
that
that's tied
work?
to the grounding electrode system, so that's bonding it as well. Yeah, I mean, like I say, if they bond it, I'm happy to see it. See so much it's not. I'm gonna clarify something I said earlier. We got a question from I think remote, and I think I incorrectly answered that. I think the question was if you're grounding the system to the UFER, do you need that additional rod? The requirement for rod is if it's a driven rod, you have to supplement that with a second rod. So if there's no driven rod, if I'm not mistaken, you can tie to that UFER, and that can be your grounding electrode. That makes sense? I think that was the question. I think I said that you had to supplement it. It's better if you supplement it, and in my area, and the reason I answered that way, they always have a driven rod and the UFER ground. That's just the way everybody does it. But I think if the UFER is proper, you don't have to drive a rod, because the code says driven rods have to be supplemented by a second rod. It doesn't say a UFER does. Okay. Moving on. Service equipment. That's the first means of disconnect of electrical power to a building. Wherever you first can turn that power off, that's the service equipment. It can be a fuse switch, a fuse block, or a circuit breaker. It doesn't have to be a full panel. It can be a fusible switch with a knife switch. That's your service equipment. Anything downstream of that's a sub panel. Sometimes you'll see a home or a building that'll have a fuse disconnect switch outside, and then it goes to the load center inside or somewhere else, and with a main breaker maybe, and people will think they call that the main panel. Main panel is not really a term that's used in NEC. Service equipment. Service equipment is where you cut that power off upstream. Okay, you can have a maximum of 6 breakers or switches can be used to turn the main power off for disconnecting means in service equipment. Now, I guess you guys are on all different codes like we are. Virginia, I think we talked about that last night. Are they on the 2020 or 2017, or anybody know? Well, we're not talking codes here, but anyway, starting with the 2020, the services shall have only 1 disconnect per enclosure or panel board. So that's changed a little bit from what it used to be. I'll show a slide here. The 2 to 6 disconnects are still allowed in separate enclosures. That's under the 2020 rule. This is an older service equipment panel. There's the meter next to it, and it's got 4 2-pole breakers in there. You can see it's a main lug panel, no main breaker, but they can kill all the power to that home by flipping those 4 breakers. That was compliant. That's the 6 switch rule. Of course, it's 4. It's less. They could have as many as 6. So that was compliant up until the 2020. I'm in Tennessee. We haven't adopted we're still on the 2017, but we do have an amendment in our 2017. Well, I'll mention amendments in a minute, which really jumped ahead to the 2020 in Tennessee, even on the 2017, where you could have this 6-throw rule. They put an amendment in and said 1 disconnect for any service 225 amp and less. So That's just a local amendment for Tennessee that they put in. On that subject, yes, sir.
Hey, Mike, does the panel cover count as one of those throws?
Does the panel cover?
Opening the panel count as one of the 6?
No.
Okay.
You talking about the door itself?
Yep,
No.
yep.
No, it's got to disconnect. It's got to be a
Breaker or
a
something?
switch. Yeah, it's got to kill power. No.
Thank you.
Amendments. I'm gonna just touch on this briefly. Be careful. I don't know. I think some states, and maybe in Virginia, you're not, home inspectors can't mention codes or whatever. Some states they can't, some they can't. It's better if you don't. I'm code certified, but I'm even careful because when I was doing inspections, I could drive a radius of 15 miles and be in 5 different jurisdictions. And they all had different rules. So if I'm working in the morning in this jurisdiction, I call something out, it could be compliant in the other. So you got to know where your feet are if you're going to call something out. And not only that, if you say, okay, this jurisdiction's on the 2017, this one's on the 2020, I can take those books. Now you got to know what the local amendments. They can adopt a code cycle and say, this is our code cycle, and then they don't tell you that they've got all these little caveats out here, but, those are amendments, and they can change that. And it can, believe me, it can make you look like an idiot if you don't know that amendment. And they don't share them with you. You have to do the research and find them. So if you're going to do any code references, just be careful. Probably best not to. Okay, I said that even in the 2020, when they changed it to remove the 6 switch disconnect rule, you can still have 2 to 6 if they're in separate enclosures, which this is. You see there's 2 main breakers. This is a 400 amp service, 2 200 amp mains. You can have as many as 6 of those still if they're in separate enclosures, which these are. That one is not. All those 6 are in one enclosure. That's what they did away with in 2020. Most of the time you're going to see main breakers. Sub panels. They're distribution panels or load centers that are downstream of the service equipment. The conductors going to a sub panel are called feeders. The conductors going to service equipment are called service entrance conductors. That's stipulation, keep in mind. Feeders to sub panels. They should have 4 conductors for a 240, 120 volt system, 2 hots, a neutral, and an equipment ground conductor. Now, there was an exception to allow a 3-wire feed to detached buildings like detached garages up until 2008 that allowed a 3-wire feed. And what they would do at that sub panel at the detached garage, they'd treat it just like you would a main panel. They bond the neutral there and drive a ground rod. Ground rod is required, disconnect required. 2008, they said all detached buildings will have the 4-wire feed, separate the grounds and neutrals. The restriction to the old 3-wire feed is it could have no other conductive paths back to the main building. That could be a chain link fence that's tied from the garage to the house. That's a conductive path. Telephone wires, water line, anything like that. If it had that, you couldn't use, even back then, couldn't use a 3-wire feed. So you're going to see that a lot in older applications. You're also going to see in the same building 3-wire feeds to sub panels. You guys see that all the time, don't you? Where there's 2 hots and neutral going to a sub panel in an old house, no equipment ground. That was never allowed. It was done. It was pretty common, but it was not compliant ever, because that makes that neutral carry that fault current, or the neutral, and is carrying fault current in the case of a short or anything, which is giving it double duty, which it's supposed to be independent, and the equipment ground is supposed to be independent for carrying fault current. So that was never allowed with an uninsulated neutral. You see that? They'd use the old SE cable and run from the main panel to a sub panel because that was a cheaper wire, and they're using that uninsulated neutral as uninsulated conductor as their neutral. That was never compliant. Okay, we know that the neutrals and equipment grounds cannot be connected in the sub panels, and it's often violated. Use terms isolated, separated. Sometimes that confuses people, like in a service equipment panel, and maybe you've got two neutral bars, one running down one side of the panel, one down the other. Some people think that all the equipment grounds have to go on one side and neutrals on the other. If it's in a service equipment and they're bonded, they can be side by side. They can be on the same terminal. So people say, well, they weren't separated. They were on the same bar. That's not what that means. It means in sub panels, they're electrically separated, not physically separated. So in a service equipment, you don't want two under the same screw, but they can be on the same bar. So you understand that. Okay. Here's a bonded neutral in a detached garage sub panel. This was compliant prior to 2008. I say it was compliant. There's a couple of things that's wrong here, but as far as the bonding, you see this, they're bonding this isolated bar to this physically attached grounding bar. So they're bonded together. This is the grounding electroconductor going to a ground rod at this separate building, which is required. It does have a main disconnect. This is back-fed breaker. But what do you see wrong with that? That breaker does not have anything holding it in the panel. It doesn't have a retainer. If you backfeed a breaker to a panel, which you can, it has to be physically attached to the panel with a lot of them have a screw that go in a tapped hole into the panel. Some of them have a little retainer kit that you can get. And what that does, all right, these are your hot feeder wires coming to this sub panel from the house. We're going to say it's coming from a 50 amp breaker at the house. Back feeding this circuit breaker, which is feeding the bus to energize them for branch circuits. If you pull this breaker out, turn it off, pull it out in your hand, it's hot because it's fed from upstream. It's back fed. So the rule is to have something to hold that breaker in place, bolt it in, some kind of retainer clip to hold it in. That's the rule for a back-fed breaker. And you'll see that a lot where they don't have that.
So Mike,
Okay.
Is that true of the solar array being backfed also?
Yes, if it's feeding the overcurrent device, it should be secured to the panel because it's going to get, it's the same way. It's going to be energized if you pull it out. That we're talking about backfeeding the breaker? Yeah, absolutely. Because typically in a branch circuit, like let's say this is a branch circuit breaker, if you turn that off and take it out of the panel, it's de-energized because it was getting its power from that bus. But the other one is getting its power from the lugs, and it's feeding the bus. So it's hot on or off because it's fed from upstream. Okay, here's a detached garage. Violation, do you see it? Well, I see a couple things I don't like in this, but yeah. He mentioned the equipment ground rod, equipment ground wire is almost touching that lug. That's going to short something out. Well, we see a knockout here that hadn't got a cover. What else we got? The one I'm looking for, and this one, there is no back-fed breaker. This is a main lug breaker, so there's no disconnect at this detached garage, which is required. It does have looks like it's got a grounding electroconductor going to a ground rod, which is correct. But what else do you see? What's that? Telephone wires. That's another conductive path going back to the house. So that violated that old 2008 rule. You can't have any other conductive paths, even if this had the proper main breaker and so on and so forth, and the wire wasn't almost touching the lug and all that stuff. It had a telephone wire come out there. So that negates that provision to have a 3-wire feed. It's a parallel path. You don't want a parallel path. Okay, here's a bare wire used for a neutral feeder. This is a little sub panel. That's probably an SE cable. Got the 2 hot wires feeding the lug and the bare neutral. So that's, there's no equipment ground, and that bare wire is carrying all the neutral current on the bare wire. That's an energized wire. I mean, that's a current carrying wire. You don't want that. Okay.
Mike, there's still some confusion about this, separating the bonds and the grounds and the grounds and the neutrals in the sub panel.
Mm-hmm.
There's an awful lot of conversation going on over here.
Okay.
Maybe you can just.
Okay. Some confusion on the separating the grounds and the neutrals in a sub panel. If it's a sub panel, they have to be electrically separated. They're not bonded together. So let's say you've got a insulated neutral bar that's not touching the enclosure. That's where your neutrals go. Then you've got a ground bar that is either with a bonding strap, or some ground bars are tapped into the metal enclosure. That's where your equipment grounds go. That's separating them electrically. Now, when I was talking about earlier, service equipment in a main panel where they are bonded together, they can be on the same terminal strip because they're tied together electrically. And that confuses a lot of guys. They say, well, they're supposed to be separated. All the equipment grounds, let's say you got that same panel and you've got a ground bar on one side and a insulated neutral bar on the other side. And you see some of the equipment grounding conductors terminated on that floating neutral bar. Well, it's bonded, so they're still okay. They're not physically separated. But you cannot put the neutrals on the ground bar unless there's a jumper, because you can't, the rule says a neutral cannot use the enclosure for continuity back to the neutral feeder. Let's say the neutral feeder is going to the main lug. Neutral feeder is coming in right there. All right, this is a good example. You can't lay neutrals on this bar and count on this metal to get back to where this is bonded. There's the bonding screws right there. So you can't use that. You can use the metal enclosure for continuity of equipment grounds, but not the neutral. That's getting into a lot of details, but maybe that'll clear that up for some people. But what do you see with this panel? What jumps out at you, other than it obviously has been relocated because there's been some extension with the wire nuts? That's not a problem. People think you can't make connections in a load center. You can, as long as you don't occupy too much of the gutter space. There's nothing wrong with splices in a panel like that. Does anything jump out at you? One at a time. He's saying, is the red wire connected to the neutral bar? It is, and that's misidentified. In this case, it actually was being used as a neutral. Why it had red tape on it, I don't know, but it shouldn't. That's one thing. The big thing I want you to look at is, okay, this is a main lug panel, right? You don't see a...
It's 10:20.
Over
Okay.
there. See a main breaker up there, main lug. How many feeder wires are coming in? What's missing? It's a sub panel. Doesn't have that fourth wire. There's no equipment ground now. It's also got a bonding jumper, got the bonding screw. It's a square D panel. It's bonded. This is being treated as a service panel. It's wired as a service panel. This is actually a panel that I added a circuit to last week, and I thought that would be a good picture to show the class of a violation. This was not a real big deal. I mean, it's not correct, but this nipple's going straight out the back of this is on the exterior wall, that's going straight to the main disconnect, which is on the exterior of the home. That's a short distance. That's not going to have the implications of one way downstream where you got all these things you can touch and get shocked. But it's still not right. So that's what if you see a panel, of course, like I showed earlier, you could have a main lug service equipment if it only had 6 disconnects and be compliant, but you see this one's got much more than 6, so it's not a service equipment, or shouldn't be. It's a sub panel with 3 wire feeds. So if you see a main lug panel with 3 wires feeding it, check that out, because it's a sub panel if it's got all these breakers in it. And it should not be bonded. They should be separated in this panel, and a 4th wire should have come in. Now, as I mentioned earlier, someone would say, okay, maybe that nipple is the equipment grounding conductor. That's PVC. So no, I looked at that. I thought, well, maybe it's metal, but it's not. So it was, so anyway, that was just a observation. And this was the same panel. This was fun to work on, guys. I could take the cover off, but I couldn't get it out of that hole. So I had to drop it down behind the wall, insert my breaker in my wire, which was another trick. When I first looked at the job, this was a friend of mine owns a little restaurant, and this is a gift shop. And she said, do you want to do this? I said, I'm gonna look at it, but see this thin cedar paneling there? That was the original wall. When I glanced at it, I said, well, I can pop those off, get my Romex connector into the bottom of that panel and make everything compliant. So I go back to do it and I take the cover off. Then I pop a couple of those cedar planks out. It's got 3/4 inch plywood behind that. I still can't get to my knockout. I didn't carry a drill or a saw. I couldn't get a saw in there anyway. So, you know, a big screwdriver and a hammer, that makes a decent chisel. It's not sharp. So I had to chisel that out to get I could have been the bad guy and got my Romex up through the knockout without a clamp. But then I'm sitting here telling you guys to call that out if you see that. So I thought, I got to put that clamp in there. So I got it in there. So anyway, that's a violation. That doesn't have the clearance requirements, working space requirements. It was a pain trying to get those screws back in, because up here in the top corners, you couldn't see them. You reach up there, had to use a stubby screwdriver because the walls are that far apart. So anyway, you'll see panels in crazy places. And we had a question at the break. A fellow back here was talking about seeing having a inspection, and the main service panel was in the crawl space. You know, that doesn't give working clearance either. So I've seen them in older houses where they were in a kitchen, and then have you ever opened the kitchen cabinets and moved the dishes to get to the old fuse panel breaker? That's not really accessible. Okay, missing enclosure bond. This is an HVAC sub panel. Okay, you see the bar at the top. Now this doesn't have any neutrals in it. This is just for HVAC circuits. So it doesn't have a neutral. It's got 2 hots and an equipment ground feeding this panel. Well, this little panel we were talking about earlier, supplying the bonding jumper with these panels where you have to buy them separately. You see the bar at the top where the equipment grounding conductors are landed? That's insulated. Yeah. So, is this enclosure bonded? No, it's floating. If a hot wire gets against this metal enclosure, that enclosure is going to have 120 volts on it, like the one that shocked me when I told them I was trained and it didn't hurt. So that's where that bonding jumper was to go in there. Like I say, I've got a problem with a lot of these manufacturers selling these, and then you got to go back and buy the little bonding screw separately. Some of them will supply them, a lot of them don't. That's an add-on. So you'll see that, look at HVAC equipment very closely. They violate this a lot. They don't know about that. They wire the stuff up. They see the terminal. They know that's where their grounds go, but they don't know about the bond. So look at those. I would say when I was doing inspection, probably 50% of these remote disconnects for HVAC equipment were not bonded. I'm not exaggerating. Probably at least 1 out of 2 would not have a bond.
Hey, Mike, we're still struggling over here.
Okay.
All right. So
All right.
we've got it real simple.
Okay.
Yes or no? All sub panels should have a 4-wire feed.
Yes, by modern standards. But as I mentioned in the detached building, up until 2008,
But I don't
they did
know
not.
where your
And
mom
all the
is
code says about that
on
now.
thing, 'cause it says
Existing applications
But y'all know that
are
home
still
is.
allowed. They're not going to make you go out and pull a wire to your 1972 house detached garage. But do all sub panels require, did you say 4-wire? No, 4-conductor. Don't get that confused. It can be a conduit for the equipment ground. Okay?
So we have a correction here. This is very active over here, by the way.
Okay.
So that doesn't apply to a 240 HVAC panel.
No. Well, a 240 HVAC panel doesn't need a neutral. So that's 3-wire. Okay. Okay, I see what you're saying. Do all sub panels, no, they don't. Right.
15 people in this conversation.
Right. If it's got 120 volt circuits on it, yes, it does. But like a
They're here.
HVAC
Home is here.
conductor is super.
I think we got it now.
Okay. What you'll
Where's
see
your mom in the car?
too,
I'm coming.
sometimes Charlie homeowner has got this panel out here and he's got some space in there. Well, he wants to put a receptacle out there. So he pops a single pole receptacle in this panel.
Either way, I don't care.
Will it work? Yeah. It's going to use that equipment ground for the neutral. See it all the time. And, you know, you get arguments. You can't tell me it's wrong. The light came on. It came on in the bulb, but it didn't come on in your head. There's 2 different lights here. So, yeah, it'll work, but it's not correct. Okay, here's an example of the separate buildings. Thanks again to Code Check for this illustration. Here's the service equipment at the house on the left. Got its grounding electrode system, ground rod there. Separate building is the sub panel over here. Each building or structure containing more than 1 branch circuit has its own grounding electrode system. Now you could run 1 branch circuit out there to that, but if you put a little sub panel out there and you can feed stuff out there, then you got to have a grounding electrode system. This is the one that required 4 wires now, but you could do it with 3 wires prior to 2008. Okay, we're going to talk about some different panel board load centers. Okay, look at the one on the left. That's a little main lug sub panel. Does it look pretty standard, what you guys will see sometimes for sub panels? Just a visual. Pretty typical looking, right? Okay, I'm going to touch a little bit on another class right here, but if you were going to describe that in your report, you're doing a visual on it, what would you say? Describe it. Somebody tell me what you'd say. What's the voltage? I mean, you're not going to know what the amperage is. What's the voltage on that? 240, 120? Everybody agree that's what that's going to be? Okay. We'll throw this at you. That's not a 240, 120 volt sub panel. That's a 208, 120 volt sub panel. Now, not going to get too involved in the 208s, but they're out there, and unless you, and I'm not telling you that you should do this, I'm saying if you want to learn and be trained properly to safely test, does anybody in here read voltage on your electrical inspection? Some of you do, yeah, that's good. Because it will tell you things that you didn't know. If you're just looking at this and you're not measuring voltage and you put in your report even for a service equipment, okay, you're describing the voltage, 120 volt, 240 to this house. You don't know that unless you put a meter on it, because a lot of, particularly condos in urban areas, I don't know about this part of the country, are running 208 services. They've taken 2 legs off a 3-phase service, which is a single-phase service, and it provides 208 on the line-to-line side and 120 to the lower voltage side. Yeah, Bob.
You just mentioned it. We'll see it a lot in Leisure World. I think everybody here is familiar with Leisure World in the apartment complexes. The dead giveaway is you'll see cables going through the panel that don't stop. And you'll see either a splice or you'll see 2 out of 3 cables being tapped, and then 2 cables go straight through.
Where are they going to, another unit?
One above it.
Yeah.
So they're alternating which pair they pick off each floor.
Yeah, they're distributing the load. They've got a 3-phase probably in a mechanical room somewhere, and then apartment number 1 gets 2 legs. They get A and B phase. Apartment above it may get B and C phase. That distributes the load, and it's more economical for the utility company. But if you're describing in your report the voltage, you don't know by just looking at it. One like this is actually a 208, 120 on the left. And just looking at that, you wouldn't know that without putting the meter on.
Yeah, because sometimes we'll get complaints saying, the stove doesn't get hot, the hot water takes forever, and it's because we're running 208 instead of 240.
Correct. 208 is not going to produce as quickly it's not going to heat water as fast, not going to preheat oven as fast. It's lower voltage. It's going to work, and you'll see. I think I've got a graphic here in a minute showing a water heater that dual voltage rated, 208 or 240. I'll show that in just a minute. We'll talk about that. The one on the right, that's a 250 amp service. This is a residence, 3-phase, 250 amp. That's a very unique, that's what they call a high leg delta, which is, we're not going to go into the technical support of that, but a high leg delta can, very unusual in residential. This guy is kind of a high-end older home built in the 60s in Nashville. He was an senior electrical engineer with Nashville Electric Service. So being an engineer, he had to have the most unique, he designed his service, and this is old. It's old 250 amp fuses. Had a 7-ton heat pump. You ever seen a 7-ton heat pump in a residence? I neither, but it's 3-phase. It's a commercial heat pump. So kind of overkill, but you'll see some stuff like this. And this is an example of a service equipment, knife switch. That's the service equipment. Got the big knife switch disconnect, fusible. So anything downstream of that's a sub panel. It goes over in a cable tray over to some breaker panels with main breakers. So some people would confuse that main breaker over there being the service equipment. This is the service equipment. First means a disconnect. Okay, here's another picture. This is actually that little sub panel that I was talking about earlier. I'm putting a meter on it. I said 208, voltage varies, but that's actually reading line to line, 205 volts. If I read one of those lines to the neutral or the ground bus, it's going to get the 120. Of course, that's going to be a little bit under, probably 118 or something because of why? In 3-phase, when you take 2 legs of a 3-phase, well, let's go back to a 240, 120. That's a split phase system. The one leg to neutral or ground is going to be half of the line-to-line voltage. When you take 2 legs of a 3-phase, it's divided by it's the square root of 3, 1.372. So if you divide, anybody got your phone calculator, you can check me on this, divide 208 by 1.372 and you get 120. That's the way that works. It comes off a 3-phase system. 3-phase system, each phase is 120 degrees, getting into trigonometry here. They're 120 degrees out of phase from one another. And then a split phase, 120, 240, they're 180. They're directly and they're in phase at the same time. So it's just different systems, but that's the math that computes it. The one on the left is a 3-phase, this is a commercial, 3-phase sub-panel, main lug sub-panel, feeding those from the bottom. You see the 3, that's a kind of a dark picture, but you see the 3 hot conductors, the neutral, and the equipment ground over there somewhere. I think it's on the right coming in. That one does have metal conduit on it, but I think it does have, I can't, yeah, it's right. It's right there. It does have a 4th conductor. So just being able to look at some of this stuff, I mean, that's a visual. You couldn't look at this one and tell what the voltage is. You can't look at any of them and tell what the voltage is, but you can tell if they're 3-phase or single phase. And anybody do commercial inspections, light commercial in here? Well, you see some 3-phase when you do that. Okay, different load centers. This is the new Leviton. You guys seen any of those? They're expensive. I've written a little thing, pros and cons on them. I'm not real fond of them. Nothing really wrong with the equipment itself. It's the design. The bonding in those can be really confusing, and I've seen most of them are done wrong because of the way the panels are bonded. They've got a little Z-shaped strap that you put in, and it can be mixed up. I'm not going to go in detail on that, but in the break or something, you want some information, I can send you a little, or email me, and I can send you a little thing that kind of describes some of the problems with those Leviton panels. I'm not going to pick on them today, though. That's that same 3-phase service. You can see the 2 sub-panels downstream. The first one that comes through is also a 3-phase, and then the second one over is a single phase. Three feeds up there. See them paralleled up. Those lugs are probably not rated for 2 wires. This was kind of a hot mess. Yeah, if they're rated for 2 wires, and some of them, and it's hard to see sometimes, confirm, it'll be stamped on the lug, tell you the size and the number of conductors you can put on it. May have a picture one later. I don't remember if I do in this slide or not. Okay. You want to continue with a planned procedure. We're getting back kind of to the topic of having a routine of your home inspection. So what you need to do, you can do your lighting and receptacles as you do your interior inspection, as you go room to room. I mean, I'm not going to go in the house and I'm going to go through the whole house and do my electrical. Then I'm going to go back through the whole house, start opening windows, go back through the whole house, start running water. You know, you're going to do it on a room-to-room basis. But you can do the lights and receptacles as you're progressing through the home. We have kind of a procedure. You start upstairs and work your way down, or start bottom, go up. Bottom up. Yeah. Okay. It's good to have, and MAC-ASHI could probably confirm this. He does a lot of expert witness testimony and stuff. And I've heard Scott Patterson even say at times, if you go to testify or something and the attorney is questioning you, that's going to be a question. What's your procedure? You know, how do you do, you know, are you repetitive? What's your plan of attack? And if you're kind of, well, I don't know, it just depends on the house. Sometimes I'll start in the living room. Sometimes I'll start on the roof, or just how I feel that day. That ain't going to go over too well in court. You need to be kind of organized. Show organization. So thankfully, I've never been to court, don't want to go. Okay, here's what we just talked about. Some will start at the top and work down, different methods. Just whatever works for you is good. Just be repetitive and have a routine where you can, that eliminates mistakes. You know, you don't want to lock up the house if you're the only one there, and you can't get back in it, or the realtor left it locked and she's driving down the road, and then you remember you didn't turn the stove off. Been there, done that. quick call, turn around, come back, got to go back in for a minute. You can forget things, so kind of have a routine. Or you ever left water running, get a phone call or go, I've heard guys talking, I haven't done that, but overflowing bathtubs or whatever, sinks. Okay, confirm light switch operation at the top and bottom of the stairways. You're supposed to be able to operate that from either end, three-way switches. Confirm the location and operation of smoke detectors. I'm not going to get into, there's a lot, we could have a whole subject on smoke detector types, how to test them, so on like that, but just confirm that they're there. The operation, they tell me if you push the test button, that's not really testing them. That's just testing the audible sound. You do the smoke test to properly test them. I personally pushed the button and I moved on, but. Okay, receptacles and other outlet. Yes, sir. Yeah. Got it? Okay.
Quickie, before we go off that smoke detector page, if you're in a house with an alarm, don't test the smoke detectors. You will have, at least in Montgomery County, you will be visited by the men in red jackets, and they will not be happy.
Yeah. It notifies the monitoring service to. Yeah.
Yep. In Montgomery County, I don't know about the rest of the state, but in Montgomery County, if a fire alarm sounds, it cannot be disabled. It must be dispatched. So even if you know the code and hit off, they will still come.
So if you push the test button on a smoke detector, it's gonna notify the monitoring.
If it's connected.
Yeah.
And so if you see, if you see two smoke detectors side by side, don't test them.
Right.
I speak from experience on that one.
Yeah.
Yeah. And I tell people that if you set it off, it's not going to set off the whole building. It's going to set off one floor up, one floor down, and your floor.
Yeah.
Yeah. Yeah. And
Good
you don't.
point.
And you don't know. So that's again why I have a disclaimer. I notice where they are,
Yeah.
but I don't test them. Because most of the time I'm going to tell you to replace them anyway.
Right. Yeah. Good point. Okay. All receptacles are outlets, but not all outlets are receptacles. When you're writing your report, try to, if you're talking about a receptacle, a wall receptacle, call it a receptacle. Now, that being said, if you call it an outlet, most homeowners are going to know what you're talking about. It is an outlet, but specifically it's a receptacle. These are can lights. Let's say this light fixture right here, there's a ceiling box up there. That box is an outlet for that light. It's a place where it's getting source of electricity. By definition, that's an outlet. So just try to be, ceiling boxes for smoke detectors are outlets. Disconnect HVAC equipment. I didn't spell that right, did I? HVAC are outlets. Junction box for a hardwired dishwasher. It's supplying electrical power, that's an outlet. Not just a junction box for splices, but if it's hardwired and it's supplying that dishwasher, that's an outlet. Light switches are called devices. They're not, I wouldn't get into too much detail of that, but light switches are actually devices. And some of the requirements in code for AFC arc fault protection, and it had to rewrite when they first came out, they said all outlets in such and such rooms have to be arc fault protected. Well, that got into confusion. They say, okay, light switches aren't outlets, so they don't have to be. Well, they changed it, I think in the 2017, all outlets and devices. They specified that. Yeah. If they're in certain rooms, yes. Yeah.
What's the certain room?
It's 210.12. You can look it up, depending on which code you want to look in. It's pretty much everything in the house now is arc fault. Pretty much everything except bathroom.
What was that question? Just a reminder, use the mic.
Oh.
Thanks.
He was asking if it's a receptacle for a light, does it have to be arc fault protected? And if it's in one of the required rooms, yes, it does. And like I say, pretty much everything in the house now, it requires arc fault protection except bathrooms and garages. Pretty much everything else does require it. Now, something that confuses people, I've asked this before and say, okay, question, do all receptacles in the kitchen have to be ground fault protected or arc fault protected? Most people say ground fault, arc fault. All receptacles in the kitchen have to be arc fault protected, but they do not have to be ground fault protected. If they serve the countertop, they do. If they're within 6 feet of the sink, they do. But if it's on a wall in a kitchen and it's not in that realm, it doesn't have to be ground fault protected, but it has to be arc fault protected. That kind of confuses a lot of people. There we go back to code. We're going to get away from that. Okay, checking 3-way and 4-way switches. This is just a diagram of different configurations of 3-way switches. The two wires between, I'll mention this just because for reference, the two wires between the two, this is a switch box, this is a switch box. These are called traveler wires. They go from switch to switch. This is the line coming into the switch. This is the load coming off the switch going out to the light. This is the neutral. There's several different ways these can be wired up. We're not going to get into details on that, but I'm showing this to kind of give you a preliminary to what's coming up. All right, this is a 4-way switch, same type deal. If you've got two switches that turn off a light from 2 different locations, those are 2 3-way switches. If you've got 3 or more, there's got to be a 4-way switch in between those 3 ways. And you can put any number of 4 ways in the middle that you want to. If you want to turn this light off from 25 different locations, you're going to have a 3-way on each end and 3 4-ways in the middle. And they'll all turn them on and off. If you want to be that stupid to have 25 lights to turn off 25 switches. But that's what 4-ways are. You won't know by looking at them, doing your inspection if it's a 4-way, but you'll know that there's a 4-way in the system somewhere if there's 3 or more places to operate that light. You can tell a 3-way or a 4-way by looking at the toggle. They won't have on and off on it. You ever notice that? Because they can be on in the down position or up. So they don't designate on and off on 3-way and 4-way switches. So if you're wondering, just want to glance, you can look at that toggle. If it doesn't have on and off, it's a 3-way or a 4-way switch. Okay, here's something that you need to remember. I call it the 3-flip method. This will confirm correct wiring or multi-switch operation. I put this in my presentations because I was doing a lot of, during the start of the boom back a few years ago, construction was just going crazy. I mean, everybody was just covered up. I was finding a lot of new construction where the 3-way switches were wired improperly. They would cross one of those traveler wires with either the hot or load. What happens when you do that is you may come into a room and flip the switch on, the lights go on. You go to the other end of the room and flip that switch, the lights go off. You think everything's working, everything's perfect. Make that 3rd flip, go back to this first one or one of the others. It should operate it again. If it doesn't, those wires are crossed. See it real often. I was seeing it a lot in new construction. And it's not unsafe, it just doesn't operate properly. And a lot of guys were crossing those wires up and mixing them up. So you operate your first switch first. That should change the light status. Do the second one, change the light status, whether on or off, doesn't matter. And do that 3rd one. And if it doesn't change it, it's wrong, point blank. So just remember that. And it's easy. You flip it on at the bottom of the stairs, you go up the hallway in the bedroom stuff and you flip it off. If you don't remember when you come back down, do that one again. Because, a high percentage of them are wrong. They really are. Okay, we're going to talk a little bit about lighting systems.
Sorry.
Yeah, we got a question.
Is this on? Yeah. Is there a simple solution for that, or does that 3-way system need to be rewired?
Okay, good question. He said, is there a simple solution for that? It's very simple. You just, you have to find in whichever switch they're crossed and cross them back. Yeah.
The homeowner's fixing a tape on the switch. So they just tape one switch, you know, in position.
He said the homeowner tapes one switch. He was just making a comment, and yeah. Okay, we're going to talk a little bit about lighting and lighting systems. We got incandescent lighting's pretty much going away. You know, it's I'm kind of stockpiling some incandescent lamps because I use a lot of them in some of my presentations, and that you can't do with LEDs. So I'm keeping them, trying not to break them. I went to Inspection World and had to take some bulbs and getting them from Nashville, Tennessee to Las Vegas without breaking them, with them throwing the luggage around and everything. I had them padded up like with pillows around them to keep them, but they made them out there. So, because I thought if they break, I'm not going to be able to find any incandescent bulbs in Las Vegas because I'm not going to go looking for them in the first place. And there goes my presentation. So anyway, I got them out there. All right, we got fluorescent lights. Still seeing some of them. Most of those, or a lot of those, are going to LED now. You can retrofit those existing lights and put the LEDs in them. Automated systems. Siri, turn the lights on. Alexa, you know, low voltage systems. Okay, the LED technology. It's a good thing in that they draw a whole lot less current than incandescents. They don't produce the heat. They're energy efficient, and even fluorescents were more efficient than incandescents. Incandescents are little heaters. They got a heating element in them. You know how the bulb can get. But with the development of LED, the load demand is less. Now the 2023 NEC, we're going to talk codes again just for reference. They now allow this. This was a proposal that came in. I was very much against it. Didn't do any good because the building lobby dictates what codes are in, unfortunately, a lot of times. They're going to now allow number 16 gauge wire and 10 amp circuits for lighting circuits. 10 amp circuit breaker, number 16 wire. That's fine if it's for LED lights. But Uncle Charlie's going to come over. He's going to tie a receptacle to that circuit. And he's going to plug in a compressor or something. 10 amps, number 16 gauge wire. His niece is going to call Uncle Charlie back and say, that's tripping my breaker. Well, we don't need that 10 amp breaker. Let's put a 30 in there. 16 gauge wire. So I can see it causing problems down the road. You guys, we're all out in the field and you see all kind of, I call it brother-in-law wiring. It's everywhere. You know, I'm not going to hire a professional. My brother-in-law, he can wire it. So you see a lot of brother-in-law wiring. You're going to see a lot with that, and I'm scared it's going to be a problem. I'm surprised it passed, but it did. So you're going to, when you go in 2023, you're going to, it's right now, since 10 amp circuit breakers, they're out there, but they're not plentiful. They probably cost more than the 20. And 16 gauge NM cable, they're going to start making that till it gets where the supply is big. It's going to probably cost more than a 14, I'm guessing, in the early stages, till it gets, the market gets saturated. But that's what's coming. Okay, automated systems. There's that person is holding the thing that we all panic. I used to panic when I left home and didn't find my wallet. Now I'm looking for my phone. You know, got to have that phone for everything. They can be operated with timers, photoelectric, automatic controls. The wireless technology is coming around. Smartphones can turn your lights and other things on. You can even, with those Leviton panels, they've got a wireless hub that goes in one of the breaker slots, and you can operate, you can monitor your panel if you want to pay the extra for the wireless hub, which is expensive. you can de-energize a breaker you can be in Florida and turn off a breaker in Canada. You can't turn it back on, but you can turn it off with your phone with wireless technology. I don't really see any great benefit in that. If I'm in Florida, I'm not going to worry about my panel in Canada. You know, I said, I think I'll turn the refrigerator off, but you can't turn it back on. Or you can just ask Alexa, Siri to do it for you. You know, we've got those systems now, the smart technology where you talk to something and it does it. Alexa, turn off the lights. Alexa, get me a beer. I haven't made that work yet. Low voltage system. They're popular for outdoor landscape lighting. Typical like the Malibu lighting, they generally have a transformer that drops the voltage from 120 down to 12 volts, most of them. Some of the indoor under cabinet lights are low voltage. That does require a transformer somewhere in the system to step down the voltage. Conductors, connectors, and ampacities. We're going to talk about some of that. This is a picture of a box inside of a switch. You got the switch pulled out. Got a lot going on in that box. It's almost that box is probably pretty overfilled if you can get the switch back in there. But different types of connectors, and we'll go over some of those. If you see that and it's got aluminum service conductors, that requires a 250 MCM. I see a few 225s, and a lot of them most of them around my parts are using the stranded aluminum for service because of cost. That's what you want to see is a 250. On a 200 amp aluminum, you're going to see a 4 aught. So the MCM, another confusion, I like to call them KC, KC mills. That's kilo circular mills, 1,000 circular mills. It always confused me why some were designated on the conductor and said MCM, because I'm thinking metric and I'm thinking M is mega. That's not what that means. I had to look it up and clarify that to myself. The M is a Roman numeral for 1,000. So that's kind of confusing. So it's interchangeable. A 250 KCM is the same as a 250 MCM. So that's all you probably want to know about that. Insulation types. The different types of insulation determine the temperature ratings, installation locations, and affect the ampacity of different conductor insulations. They're all different types. We're most familiar with THWN, THHN. That's typically what's in an NM cable and what we're seeing, but there are different types, have different ampacity ratings based on the insulation. And different ones are used in different ambient temperatures and very high temperatures. You can go with a higher rated insulation. Wiring on a old electric stove had this higher capacity insulation on the wires going in behind that oven and so on and so forth. Okay. The conductor material, typically we see aluminum and copper. That's the primary, that's what we're going to see. You're not going to see, gold is the best of those, but you're not going to see many houses wired in gold unless it's probably out in Beverly Hills. Maybe somebody, or one of those engineers wanted to be specific and have but you're not going to see that. Copper and aluminum is what we see. And when we're talking about the aluminum, skull and crossbones pop up everywhere when somebody says something about aluminum wire. The stranded aluminum that we see in service feeders and appliances, that never was a problem. It was the solid aluminum back prior to 1972, I think, with that earlier alloy that had the issues. Now, I'm being told that the aluminum manufacturers are trying to make a push for a comeback on aluminum with the newer alloys. And some guys on the West Coast are telling me they're seeing copper-clad aluminum in new construction now, reducing costs. I hope it doesn't. I hope the solid stays with copper, but they're going to go with whatever affects the pocketbook. Okay, this is just a reference chart. This is from National Electric Code showing this is table dot 310.15B16, which is the table used for conductor ampacities. These columns up here are showing different type of insulation, the rating of those insulations, all different types of insulations, and you come down, you've got this type wire with this type of insulation. This is the column you use for the ampacity and the wire size over here. We're not going to go into much detail on that. We could spend a day just figuring this out, but that's the ampacity chart if you wanted to reference it, 310.15B16 in the National Electric Code. And you don't have to have a code book. You can Google this and pull it up online. Terminal connections, they have designated ratings for terminal. You could have a wire that's rated for 90 degrees and it connects to a circuit breaker lug that's rated for 75 degrees. You have to use that lower temperature rating to determine your ampacity for that. You're not going to get into a lot of that as home inspectors. You're not going to really care about that. But that's just some information, knowing that there's a whole lot of variables out there in conductor ampacities affected by different things such as ambient temperature, things other than just the load on the wire, ambient temperature, insulation, so on and so forth. So that's typically what's rated on the circuit breaker, 75 degrees centigrade. Okay, wire side and overcurrent protection for HVAC equipment. We're going to spend a little time on this because this is something that gets confusing, because that ampacity chart I showed you a minute ago kind of goes out the window when you're sizing conductors for HVAC equipment. There's an article in the National Electric Code, I think it's 440, that addresses HVAC and refrigeration equipment, and they allow different ampacities for those appliances. Few terms you need to know. You look at the data plate on the condenser to determine, that's where you get your information for the wire size and the circuit breaker for that heat pump, condenser, whatever. That's where your information comes from. So these are the things you want to look for. MCA is a minimum circuit amps. That's going to have a designation on that data plate telling you what the minimum circuit amps for that appliance is. You're going to have the maximum overcurrent protection, MOP. Some of them even put a minimum, not many, but every time you'll see a data plate that'll have minimum and maximum, and usually they're the same. Why they put it on there when they're the same, but they do. I may have a picture of one, I'm not sure. Okay, full load amps. That's another designation that we'll talk about in a minute. And running load amps. That's the rated load amps. All these are abbreviations on the data plate that give you information that you can. Locked rotor amps, you're not going to care about that. Okay, here's one. I don't know how well you can see it. We'll try to use our pointer and go to minimum circuit amps. On this one is right here, and it says the minimum circuit amps of this unit is 19.5. So that's going to tell us right there what wire size we can use. So everybody agree on number 12 is the smallest wire we can use on that, 20 amp, rated for 20 amps. Okay, we're going to use number 12. You could go bigger, but minimum number 12. Now, our minds on our branch circuits, we're saying number 12, 20 amp breaker, right? On a branch circuit. That's kind of how we're wired. Well, it gets different when you go to HVAC equipment. And we look down here and it says maximum fuse. Boy, I'm going wild with this thing. Maximum fuse, 30 amp. So we can put a number 12 wire and protect it with a 30 amp circuit breaker for this appliance. Can't do that for your wall receptacles or your lights, but you can for this condensing unit. The manufacturer determines that. And you can use that for that's your reference in your inspection. That confuses a lot of people. How can you do a number? And it could be bigger than that. They determine, sometimes you'll see a number 12 on a 35. Got another example here. This is okay, we've got here's one that's got minimum and maximum. Minimum fuse 60, maximum fuse 60. Why they do that, I don't know. Okay, minimum circuit ampacity, 36 amps. Okay, we'll go back to that chart. What can we use on 36 amps? Number 8. Yeah. 10's good up to 30. We're gonna go to a number 8. Okay, we've got a number 8 wire. Then we say we're gonna protect it with a 60 amp circuit breaker. All right, number 8 on that chart, I mean, typically is rated for 40 amps. So we've exceeded that by 20 amps, but that's okay because what it's for is the startup inrush current they call that those compressors require to, when they first start up, for just a split second, they draw a lot of current. And if you size that with the smaller breaker, it's going to trip on startup. Then when it runs, it levels out, and it's going to run at less than the 36 amps. That unit's probably going to run at 28, 29 amps, something like that. So it's the wire's good, but the breaker is upsized to prevent tripping on the startup. Everybody pretty much understand how to read these. If you've been inspecting a while, you know that that's what you look for in the field. Electricians I had trouble with that when I first got in home inspecting because I was always wired to, number 20, 12, and so on and so forth, but understand what it is. Okay, this is what, I can show you kind of what this means. The running load amp for the compressor, this is how they compute it. It's added to the full load amp of the fan motor. The condensing unit's got a little fan motor too, or the condensing fan, and the compressor. That's the 2 draws on that unit. So going back to that, let's see, 27.6 and 1.4. That's this one. If you look down here, they've got the compressor motor, 27.6. OD, that's the condensing fan motor, full load 1.4. Go the other way. You add those together and you come up with 29. Well, we talked about continuous loads earlier. HVAC units are continuous loads. Anything that can run or will run at times for 3 hours or more is considered a continuous load. So you add those together to 29 and then you multiply it by 125%, 29 times 1.25, and that comes out pretty doggone close to what they said. They said 36. So that's basically how they compute that. You probably didn't care about that, but that's just the information, how they do it. And it's compliant with the provisions in the National Electric Code. Okay, we're going to talk about water heaters a little bit. They're also continuous load. 120 gallon and smaller storage water units are considered to be continuous load appliances. The data plates on the water heater gives us information, but they don't give us as much specific information as the HVAC people do. You have to kind of calculate that yourself. They give you the wattage and voltage rating. And the overcurrent protection wire side are calculated from that calculation. Now, there's a lot of different water heaters. I mean, standard, you're probably going to see more 50-gallon, 4,500 watt electric water heaters than anything else, but there's a lot of different ones out there. Of course, tankless, we're not talking about them. We're talking about storage type water heaters. Here's a data plate on a water heater. Now, we talked about the 208 volts earlier. This one is dual rated, and we talked about the efficiency, not the efficiency, but the wattage capacity of an appliance at that lower voltage. Here's the 208. Now, if you've got a 208 volt supply to this water heater, this is the wattage output of those elements. If it's 240 volts, then it's a 4,500. Now, that's if it comes from the factory with the elements rated for 240 volts. You downrate those if it's 208. You can buy 208 rated, voltage rated elements to put in that heater if you want to do it, but nobody's going to do it. Particularly, you'll see them mostly in commercial, but not in residential. So when you use that, to get the current draw of the water heater, you divide the voltage into the wattage. So if you divide, I know this one off the top of my head without calculating, but if you divide 240 into 4,500, you're going to get 18.75. That's the amps draw. You say, okay, now why can't I use a number 12 wire, because it's under 20, on that water heater? Because it's a continuous load and you have to rate it at 125%. Now you multiply that 18.75 by 1.25 and it comes up to 23 and some change. So you got to bump it up. You can't use that number 12, you go to number 10 because you're over 20 amps, okay? And this is, I've made a chart. If you guys want that chart, send me an email, I'll send it to you, and it breaks it all down. You can pull charts up on the internet. I've never seen one that was totally complete or totally accurate. This water heater at 240 volts, you can protect that with a 25 amp breaker or a 30 amp breaker and be compliant, because the code also says that your overcurrent device can be rated for 1.5 times, 150%. So you can upsize to a 30 or you can have a 25. And you probably see it in the field sometimes. You say, okay, I just did this house. It had the same water heater. They had a 25 amp breaker. Go to this house, they got a 30. Which one's right? They're both correct. They're both compliant. But now you get into other water heaters. This is the chart. And there's a whole bunch, and you're not going to be able to see it well on this, but if you want it, I'll send it to you in a PDF. You got the wattage on the left. We've got the different voltages. There are even storage type 120 volt water heaters, 208, 240, and this breaks down the wire size and the overcurrent protection in each of these applications. So if you want that, send me an email and I'll send it to you. It's a good reference. We're not going to detail that. We'd spend a lot of time on that, and we've got to move on. But anyway, like I said, if you want that, I'll send it to you. Okay, I think I've talked about that, and that comes with that chart, and it explains kind of how to use the chart and the references in the National Electric Code that make this compliant. AFC and GFCI protection. A lot to talk about there. How should we test these? Do you go in the house and start popping arc fault breakers and go checking? Probably shouldn't. I live on the wild side. I'll check more than, unless somebody's in there writing their thesis for their master's degree and I cut off their computer. I don't want to do that. But particularly in a vacant house, I'm gonna test them. You should test them at the device. I've got testers that will trip the arc fault remotely, but it's best to test, and manufacturers, even GFCIs, test them at the device, whether it be the receptacle or the breaker, and then you're gonna walk a lot more, and then go see if it cut everything off. Okay. These weren't required in the older homes. I always recommend GFCI protection in certain areas in older homes. That's a good safety upgrade. It's not a requirement. They were grandfathered in when they were built. Even arc fault in some situations, can be good protection, additional protection. Some of the newer requirements: dual function breakers and receptacles. Dual function breaker and receptacle has both technologies built into that one unit, both arc fault and ground fault protection. Don't confuse that with a combination arc fault circuit breaker. The first generation arc faults were branch feeder types. They would only detect parallel faults, arcs between the hot and the neutral. Then they said, well, most failures are series faults, loose connections on the hot wire or the neutral wire, and it arcs between it. So they came up with what they call the combination arc fault technology, which detects both series arcs and parallel arcs. That came out I think they came out in 2005 or 8 code, but anyway, 8, I believe. So when they started having more requirements in rooms that require both arc fault and ground fault protection, they came up with this one that you can get it all in this one unit. You guys probably see a lot of those in new homes. They've got the dual function that has both protection built in that breaker, cheapest way to go. But they couldn't call them common, your logic says it combines arc fault and ground fault, so we're gonna call them combination. Well, that term was already used specifically for those arc faults. So they call them dual function or dual rated circuit breakers that have both protections. Y'all seeing those? Okay, I think I got a couple pictures of them. And then the timeline requirement references, that's, you can pull those up various places and find the requirements. Early ground faults went back to, earliest ones were swimming pools. And then it evolved over the years, kitchens or bathrooms, exteriors, kitchen counters, and gone on, and arc fault has progressed the same way. Okay, here's a receptacle on the left. That's a AFCI arc fault receptacle. You can buy them. Dual function, arc fault, ground fault receptacle in the middle. Like I say, that's the dual function. And if you look, it's kind of fuzzy focus, but right there it says arc fault, ground fault. It's got both technologies built in that one unit. That takes care of most of your kitchen circuits, a lot of, laundries, so on and so forth, that require both those protections. Then you got a 2-pole arc fault circuit breaker that they've come out with. The multi-wire branch circuits with a shared neutral would trip these arc fault breakers because the early ones had additional GFCI protection built into them, not at the 5 milliamp threshold, but at a 30 amp, and they would trip when the neutral was shared because it would see an imbalance between those two hot conductors and that neutral, one carrying more load than the other, and it would trip the ground fault functioning of it. So they came up with these 2 poles where they did away with that detection of that shared neutral, and you can actually run multi-wire circuits off this 2-pole AFCI breaker. That was I think that's a Siemens. I think they were maybe the first one out, but pretty much all of them have them now. So you'll see some of those sometimes where they're going to use multi-wire circuits on an arc fault breaker. Another thanks to CodeCheck for these graphics. This one on the left is a ground fault receptacle. It's upside down, but if you look at the top, see it's a WR. That's something to look for on your exterior receptacles in newer codes. They not only have to be ground fault protected, they have to be weather resistant. That makes you pay a little bit more for that. They cost about $10 more than the standard, the one that goes in your bathroom. And the TR at the bottom, that's tamper resistant. We all know what those are, the little plastic things that are aggravating to plug your tester in that make you mad. But
I'm seeing a lot of water resistant in bathrooms.
I'm sorry?
I'm seeing a lot of water resistant in bathrooms now too.
Well, it's not water resistant, it's weather resistant is what that stands for, but, and you could put it in the bathroom, but it's not required.
Yep. I'm also seeing alarmed GFIs.
Alarm GFI?
Yep, on sump pumps and
Well, they
other
have an
places.
audible alarm, yeah.
Audible
Yeah,
alarm.
that's pretty much the latest. Most of them have that audible alarm. My hearing frequency at that high pitch, I can't hardly hear them, but my wife would always tell me when my watch was beeping in church, I couldn't hear it. But now the one in the middle is what we call a dead front GFCI. You'll see them sometimes. It looks like a receptacle. It fits in a box just like a receptacle. It's got the test and reset buttons on it. That can protect downstream receptacles, whatever. Sometimes you'll see those that'll protect a whirlpool tub, and they like to hide those. Sometimes they'll put them in the master closet behind all the clothes, and that's where you reset the whirlpool in the master bathroom. Yes, sir.
Yeah, my question to you is, I've noticed in a lot of the new codes, all the sump pumps, most sump pumps are French drain sump pumps, and they're also exterior step wells going up from a basement, and they want all of that on GFCI. My question to you is, which seems to be a problem, that most people don't know how to reset it. They don't know when it trips off, and you can actually flood a basement. Once the water level exceeds the hydrostatic pressure underneath the gravel of the slab, et cetera, you will get, when it fulfills the French drain,
Right,
which is the perimeter drain, eventually you're going to flood a basement.
yeah.
So why are they doing this GFCI on sump pumps?
It's for safety because it's a shock hazard, whoever's working on them. But now, like what Bob mentioned, a minute ago, the audible ones, and what I would recommend, the best setup on that is either have it on an audible breaker or one of these dead fronts up in the house where you're going to hear it. When it trips, it's going to give you that audible sound, and you don't have to be in the crawl space with that pump or basement to hear it. So you can protect a regular outlet with ground fault protection upstream, where you're going to get an alarm. And most of the sump pumps now, I mean, they should have a alarm system on them too. When that float switch comes up so high and it doesn't, you know.
A lot of them don't. A lot of them don't.
They should.
And a lot of times you have sump pumps with a backup pump inside the sump crock.
Yeah. So, but of course, that alarm system needs to be independent of the GFCI, because you don't want to kill power to your alarm.
Should be tied to the doorbell of the house.
Right, right.
Thanks.
Yeah, good point.
Water sirens. Install water sirens.
Yeah. Okay, and that's a regular GFCI circuit breaker on the right with the test button. Different manufacturers have different colors for their test buttons. Some people try to do a color code that they mean nothing. They don't think that a blue means this or a yellow means that or a white means this. Okay, best practice is locate the downstream, the GFCI device, whatever the master, before you go tripping. You go into a house and you go to the exterior and you take your little tester with the shunt button on it and you plug into the receptacle out on the side of the house. Boom, power goes off. Then you go in the garage and he's got a 17,000-pound gun safe in front of that reset receptacle. And you've just cut it off. So I've learned the hard way. Try to do a little survey and try to find what's feeding those exterior receptacles. Typically it'll be in the garage, one of those. Well, the bathroom, you can't do that anymore, but they used to. Yeah, yeah. So if you can go find some of your GFCIs, manually trip them, then walk outside and see if that killed that circuit. That's a whole lot better than, like I say, doing the Easter egg hunt. You ever done that? Spend an hour trying to find it to reset the stupid thing? That's a real pain. Okay, testing and measuring procedures. We talked a little bit about that earlier. It's not required in any form or fashion. I'm not telling you it is. I'm telling you, if you learn, get trained safely to do this and learn to do it, it will greatly enhance what you will find in home inspections. You can find loose neutrals when you, I've got a whole nother class I talk about testing. If you're reading, go to the main panel, and it takes 30 seconds. I take a meter and I'll read on the main lugs coming into the service panel, line to line. I know what my voltage is. If it's in the operating parameters, sometimes it's not. Then I'll read each line to neutral. That's got to be fairly balanced. If it's not, then we've probably got a problem with the neutral. We're going to do some more investigation. Not as home inspectors, we're going to have an electrician come out. Open or loose neutral is a very serious problem. Had a friend home inspector send me a text the other day, and they had taken my class and they had started doing some testing, and he said, we got to this house and we read 119 volts. I mean, we read 248 volts line to line, and then we read one line and it was 118 to neutral, and the other one was 130. Is this a problem? Oh, Lord, yes. You got a loose neutral somewhere. And then when a loose neutral happens, it's like you have gremlins in the house. Some lights will go real bright on that leg that's hot, got the 130 volts on it. You turn on a stove and that puts some of the things through the conductors in series. Those go dim and these go bright. And depending on what you got on, they go up and down. So that can be a serious condition. So if you measure the voltage and see any anomalies in that, report it. Yes, Sean?
Hey, Mike, I just wanted to make a good important clarification to guys inspecting in Maryland. The standards of practice require us to describe the amperage and voltage in our reports.
You can't what?
We have to describe amperage and voltage in our reports. One way of doing that is to measure amperage and voltage and put those numbers in your reports. A lot of us don't do that. Make sure you're describing that somehow in your report, saying you didn't measure it, saying it's likely, whatever you want to say. It has to be described in your report.
Correct. My state requirements, Tennessee, say the same thing. The old ASHI standards said that you had to describe the voltage, but they changed it in 2014, I think. You don't anymore. But how can you describe the voltage without measuring it? You really can't. You can write, the voltage looked really nice today. It was some of the prettiest voltage I've ever seen. You described it in a stupid way, but if you take that reading, like I say, it takes 30 seconds. And I've had guys argue with me, other guys that teach classes said, you shouldn't teach these guys that. You shouldn't tell them that. I said, I'm not telling them they have to do it. I'm telling them if they want to do it, learn to do it safely. It's really no more dangerous than plugging this little thing that you paid $7 worth and you're depending your life, it's not going to explode in your hand when you plug it into a receptacle. It's really no more unsafe. You're going to take the cover off that panel. That's the most dangerous part of your electrical inspection is removing the dead cover and putting it back on. That's where you're going to get hurt. Taking the probes and reading the voltage and reading current. That's clamp on ammeter. That's an easy thing. But you know that's up to you individually if you choose if you want to do that.
So Mike, we got somebody in the remote audience asking you to elaborate on upgrade requirements when you someone adds circuits or remodeling has been done. Is the requirements for upgrades of AFCIs and GFCIs?
Okay. Upgrading circuits for AFCI. If you replace a receptacle in any part of the house, let's say you got an old receptacle and the tension's loose in it, and you replace it, and it's in a bedroom or any place where arc fault protection is required, you're supposed to supply arc fault protection. Now, who's going to do that? Replacing one receptacle, but that's what the code says. If you move if anything is moved, if a circuit is extended or moved more than 6 feet from the original, then you have to provide arc, like say a service panel or a sub panel is moved. If it's moved more than 6 feet, or any circuit is extended more than 6 feet, then you have to provide arc fault protection for that. If it's in the same place, if you're replacing a sub panel with a newer sub panel and you don't move it, and it was not under that code, you do not have to add arc fault protection. So, and those 210.12 is the reference to read the specifics if they want to go into detail and read that. But you are required to upgrade if you add circuits. Anything you add, additional circuits, you have to meet modern requirements, or if you move them. I'm sorry?
If you add on more than a certain percentage of the existing house, they make you upgrade to the existing building.
Okay, that would be for the whole house. But if you got a 1972 house and you're going to add a circuit, you have that circuit. If it's in one of those, it has to be arc fault protected or ground fault protected. That circuit does. You don't have to do the whole house, but that one does.
At least in Montgomery County and most of Maryland, if you add a circuit, technically a permit is required.
Right.
And most, that's where we get into basement remodels. Because basement remodels, even if the rough-in is there, you still need a permit for the plumbing. You still need a permit for the electrical. That's where most of the basement remodels fall apart. In Montgomery County, if you add more than 6 inches of wire, technically you need a permit.
That's considered new work.
That's considered new work. Just so you know, in Montgomery County, a homeowner can do their own electric. They have to take a 12-question open book test. They then can pull permits. So I have no sympathy for people who don't pull permits.
Mike, we got some more
Okay.
there's more conversation than question. And I think what he's getting at is this notion of, we can't expect people to bring an old house up to the current requirements.
Correct.
But I think that some people actually do kind of pick on GFIs and AFIs specifically that aren't up to the current, like a kitchens or that when it wasn't required when the house was
Sure.
built. What are your thoughts?
You're talking about, as home inspectors, our recommendations, and I would always suggest that you recommend upgrading ground fault protection. I mean, I've got another presentation. I've got a picture of a curling iron laying next to a sink, and it's plugged into a regular outlet. Sink's full of water. And do you say, okay, this was not required by code, it was grandfathered in? I'm gonna say, yeah, you need a receptacle, ground fault protection there. Because, I mean, safety trumps code. Now, rebuilding a house, you got limits on it, but around sinks, exterior, people have died, plugging these things into these and dropping a hairdryer into a sink or a bathtub or something like that. Well, he didn't have to do it because it wasn't code, but bless his heart, rest in peace, I recommend them. You don't have to do it, but I recommend them. Okay, 3 light testers and circuit analyzers. And you guys use the circuit analyzers, those are good devices. Use the Sure Test. I use the Tasco. I preferred it, and I've used, Douglas Hanson recommended that to me years ago. He thought it was a little bit more intuitive than the Sure Test, but they're both good, and they can lead you out down when you first get it, you plug them in and they'll tell you voltage drop, and that can send you down a whole highway you don't want to go down, because there's going to be voltage drop everywhere and it'll drive you crazy. So unless it's really bad, don't get into that, but they can tell you things that the 3 light testers will not.
One comment on the circuit analyzers. Some of them have an AFCI tester.
Yeah.
Do not use it. Because one company's AFCI tester will not test another company's breaker. Oftentimes, you'll either blow up the circuit analyzer or at least smoke it.
Yeah, that goes back to what I said earlier. Always test those at the device.
At the device,
Use the test button on the device itself. That's a good point.
Just as a note, use a pen to trip them. I've had more than one GFI try to take off the end of my finger.
Yeah, they'll blow out.
Yep. So
They will.
Use a stick, a pen, something. Use the GFCI tester as a button tester.
Right.
Because as I said, I've had the end of my finger scorched more than once.
Oh yeah. They're man-made devices and they will fail. Okay, another testing procedure. We're not going to go into detail on this. Many of you guys use IR, thermal linear. That's a great tool. If you haven't got the training, get the training. Steve over here will. Steve is right, isn't it? I did remember a name. All right. Get the training. They offer a great CRT training course. I took a level 1 course back when I was with Forward years ago. We had industrial, we did the thermal imaging. I got level 1 certified, and the CRT course is a whole lot better for these applications than a level 1. We had to cover flat roofs and all that stuff, and we were electricians and didn't care about that, but and this is specific for home inspectors. So get the training, learn how to use them. If you're going to use them for electrical, keep in mind that they are useless unless the circuit is loaded to a certain degree. A circuit that doesn't have any load on it could have loose connections all through it, and if it's not being used at the time you're scanning, it's going to be cool. It's not going to show an anomaly. So just keep that in mind. I do specific electrical inspections where I'll load circuits and do my thermal imaging, but you don't have time to do that in a home inspection. And if you go to a panel and you got your IR camera out and you're looking and you put it on one of these new panels and the arc fault circuit breakers light up your screen, don't panic. They're warmer, and dimmer switches. They're designed, they've got circuitry built into them. They're operate warmer than the other circuit breakers. So learn to use them right. Use references, and he can tell you more about that. So I'm not going to steal his thunder. He'll tell you how to use those things, but they're great tools. Non-contact testers have pros and cons. They will lie to you in a heartbeat. They will tell you different things. They're not completely, they don't tell every situation. They can be fooled. We'll talk about bootleg rounds in a minute, and they'll fool the little 3-light tester, but if you use one of the circuit analyzers and understand how to use it, you can detect that with a circuit analyzer most times. Okay, standards and codes and standards of practice. We all follow a standard of practice. Use whichever one is your license. If you're in a licensed state, that's the one that's predominant. You have to use it. And we talked about citing codes. Code questions and discussions are going to come up whether you want to talk about them or not. Homeowner's going to, is that code? I don't know. Call the code inspector, or if you know, tell them, but be careful with that. Just try not to get too deep in codes. All right, electrical codes in the U.S. are covered by the National Electric Code and the ICC. Most places it's the National Electric Code. I think there's a few jurisdictions. I'm thinking Virginia has some jurisdictions that uses the ICC, which basically just took the NEC and put it in their own words. So those are the two primary adopted codes. And they have this, one doesn't vary from the other. The NEC is a lot more specific, a lot harder to read. When I took a code certification exam, you're allowed both books, and I could find open book tests. I could find the answers quicker really in the IRC than I could in the National Electric Code. It's more plain written. There's not as much additional verbiage in it, but those are the two. We talked about local amendments that can deviate depending on local jurisdictions. And if you're going to cite them, like I said earlier, know what version is in the jurisdiction and any amendments that are in force. Okay, we're going to talk about reporting safety concerns. Warning, this house has supplied with electricity, evacuate immediately. Just put that in your report and you're covered. Just tell them, get the crap out of there. We've got electricity and we're going to get hurt. You do want to report any safety measures, any issues. Talk a little bit about this. I'm guilty. I'm getting better in my old age. I worked in a Ford Motor Company glass plant for 30 years where I was an electrician. Safety glasses were required. Hated those things, but they were, a glass plant especially, flying broken glass everywhere, you want to wear them. But in electrical, when you do your panel inspection, get you a good pair of safety glasses and put those guys on when you open that panel. If something arcs, copper explodes and it flies out and it goes in your eyes, it's going to ruin a good quality of your life. So wear at least safety glasses. I recommend tight fitting gloves. Just edges of panels will cut you. That sheet metal's sharp. It does provide a little bit of insulation, not going to keep you from getting electrocuted, but you're not going to get as bad a shock through leather gloves as you will in bare hands. And don't wear jewelry. You should remove metallic watch bands and stuff like that. That was a requirement at Ford in our industrial. You didn't wear your rings. And of course, we were mostly in 480 volt panels. So you would remove that. You get written up if you didn't. Wear proper clothing. Don't wear the John Travolta polyester shirts because they tend to melt and burn on your skin if something arcs against you. Ladder safety. Be careful with your ladders. If you use like the metal extension ladders, watch it around that overhead triplex. Don't be talking to somebody and have your ladder extended out 24 feet and go bumping into those bare connectors I showed you earlier, because that's going to ruin your day. This is the one in that detached garage where I got shocked, but it didn't hurt me because I was trained. Verify that they're not energized. You can do that. The little non-contact voltage sticks will lie to you both ways too. They'll give false positive, false negatives. You can, if you stick that up there and it's beeping, and if you got your meter, you can verify it with that. Sometimes they will give a false from an inductive force that makes them go off. But before you go grabbing, and always use the back of the hand to the panel board. If you grab it and it's energized, your muscles are going to contract. You can't let go of it. Back of the hand is just going to make you say bad words and throw down your flashlight or something. So do that. And never leave a panel unattended, because a lot of times you have clients and the little kid's running around. He's going to go get a coat hanger out of the closet, and while you're running water and you got your panel open, he's going to stick it in that panel. So never leave it unattended. If you're looking in the panel, if you got to go somewhere else, cover it back up. Okay, panel inspection measures. We already said that. Look at the on and off position of all the breakers before you take that panel off, because a lot of times you'll trip one and you don't know. And then you look in there, maybe a couple were intentionally turned off, and then one clicks off. Now you got 3 or 4 off, and you don't remember which ones are supposed to be off and which ones you turned off. So I just pop a picture of it, and then I take my cover off. Ensure proper clearance and working space around the panel. Not supposed to have a bunch of junk under it, stacked in front of it. Should be accessible. Most of the time they're not. A lot of times people like to, you ever gone in and you can't find the dadgum panel and they've hung a picture over the panel board, behind doors and stuff. Any open knockouts, missing clamps and grommets, loose conduit, just obvious stuff that you're looking for, and the proper support of the panel.
Hey, Mike.
Yes.
Hey, would you consider the panel in the kitchen with the countertop in front of it, that countertop being a hazard for clearance?
Yeah. You sure would. It should be clear to the floor. Yeah. And you're not supposed to have any plumbing or anything under there, any other systems below that panel in that envelope. Verify the proper circuit legend. The panel should be labeled what they go to. Now, code requires that, and a lot of guys, and I have a problem, you go in there and say lights and plug, lights and plug, lights and plug. That doesn't tell you, okay, where are they? But that'd be your call on that. Okay, removing the panel cover can be hazardous. Look at the screws. If you see sheet metal screws in there, that's wrong. You can, if you want to, say, I'm not going to take those out because I don't want to short something out. A lot of guys will do that. I'm going to take them out, and I carry standard panel screws in my truck, and I don't even write, I just replace them. It's easier than writing it up. The pointed screws should never be used. Okay, we're going to get into this. We're going short on time. I kind of wanted to really cover this. This is a method I use, and I recommend. I call it the macro-micro inspection method. And the macro view is just kind of general observation. You open your panel, you're kind of taking a general view of everything. Anything that jumps out at you, open knockouts, clutter, paint overspray, anything like that. You kind of look at that in your macro view. Any foreign materials, water damage, rust, anything like that. Then you go to the micro view. Now I always tell people, I've got some friends that's, staying busy, still doing inspections. Say, are you staying busy? Yep. Doing 3 a day. And I say, you ain't doing them right, in my opinion. You can't. Because the electrical inspection is going to take a little while if you do it right. If you really do it right and use this micro method, now that's in detail. You're going to look at every wire termination in that panel. Neutrals, equipment grounds, circuit breakers, look at every one of them individually. Don't just do a general view. Look for heat anomalies, discoloration. You're going to look at the proper wire size for the circuit breaker. Verify that. Condition of the enclosure in the bus bars, discoloring, arcing, pitting in the bus bar. It takes a while to do all this micro inspection. You know, I'll spend anywhere from 10 to 20 minutes in a panel. I'm gonna take my time, I'm gonna look it over real closely. Now, some little sub panel that's got 3 breakers in it, and I'm not talking about that. I'm talking about a 40 space panel that's loaded up. You're looking for double or multi taps on neutral bars or breakers, proper bonding. You got a lot to check off in here. Is it a sub panel or a service equipment? So you got to spend some time there. So here's an example. This is a macro view of a panel. Does anything jump out at you on this one? This is a,
Double tap on the third left.
okay. I think that's a neutral, but I see what you're talking about on the left. Yeah. Okay. Again, this is a sub panel, 3-wire feed. But this is the macro view. You're not going to see everything up close. You're just kind of looking, and kind of generally just looking at that first glance, it doesn't look too bad, you know. But then you start zooming in on it. Okay, this is a micro view. Like I said, this is a sub panel. What's going on here? Neutral's bonded. There's one call out. The neutrals and equipment grounds, they're physically separated. We talked about this earlier. Are they separated? Physically, yes. Are they separated electrically? No. We got a tie bar here. That tie bar can be removed. Okay. There's 2 strikes against us. Well, this is a double tap breaker. I don't know if that's what you saw. You may have been talking about the double tap neutral. This one was not that obvious in the back view, but there's a double tap. It does. It probably is.
Yeah, the 10 going in the back.
Okay, what do you see here? Look at that left lug. The insulation is under part of that. It doesn't look like it's been overheated, but it could. That can hold that off the conductor and cause a loose connection. So you don't want any insulation behind that terminal screw. And I've kind of blurred his name. I know this guy. He's a code inspector in our area. He's a great guy, but he shouldn't be inspecting anymore. He's 84 years old. And he passed this. Just like it is. Okay, here's another macro view. This is a new service, service lateral coming in from the bottom, 200 amp service next to the meter. That looks pretty good, doesn't it? Pretty neat looking work. You see anything? Okay, this is the macro view, like I say. Now we're going to zoom in. Oops. Now you can actually see this if you look at the top. But generally, unless you got up close and started looking around, you probably missed that. Now, none of the conductor strands appear to be damaged. This is a brand new house, brand new service entrance conductor. The contractor argued, he said, just stick some tape on it, which could be okay, but I told my client, I said, you paid a lot of money for this guy to wire this house. I don't want to cut patched up service conductor on my brand new $750,000 house. They agreed. They want it fixed. So there was enough slack in the wire. He could cut it off there, pull it up, make the bend, terminate it. It wasn't a big deal. So just showing where, you know, you just got to keep looking close. Okay, here's a sub panel. See a little paint overspray in our macro view. See that? What else do you see? That blue screw, that's what we talked about earlier, that's a square D panel. Okay, and above that is where the bonding jumper goes. So you didn't want that in there, correct, because it's a sub panel. But if you look closer, look where they terminated the equipment grounding feeder. They bonded it to the neutral load. That should have gone right there. There's no equipment grounding feeder to that ground bar. Pick on him. This is the same code inspector that passed this one. Code inspectors aren't always right, guys. I mean, they're like us. They miss stuff. So just because the contractor tells you or the builder tells you, I pass codes, I don't care what you say. Stand your ground, argue with them. Okay, so what is the potential problems with this? Well, this had some load in this house. This is an upstairs sub panel in a pretty big house. So I put an amp meter on that equipment grounding conductor. 7.3 amps of that neutral current is going back to the feeder, through the feeder circuit on that bare conductor. That's dangerous. You know, you can grab that. Anything grounded is getting that current in that circuit. Then I put it on the neutral. The neutral's a bigger conductor, so it's dividing that, whatever that was, 7 and about 19 amps total neutral load on this feeder circuit, divided between the equipment ground and the neutral, parallel path. Bad deal. So I didn't have to do this to call it out. Visually, we could see it was wrong in the other slide, but I did this just, you know, to prove it, to show. And 7 amps on that bare wire, that's death. I mean, that's why ground fault threshold is anything above 5 milliamps. This is 7 amps. That's several hundred times more, 1,000 times more than that requirement for shock. Okay, proper terminology in your reports is important. You need to be technically correct, and it's good if you can use verbiage you'll get more respect with contractors if you know things like what an equipment grounding conductor is, a neutral, service equipment. They're going to respect you more if you know those terms. But now when you're talking to your client, you got to talk to them in terms that they understand, communication is the key to what we do. You know, if you can be the best inspector in the world and find every defect, if you can't relay that information to your client, you really haven't done anything. Okay, concern should be described, location noted, where that concern is, possible implications if not addressed, and recommendations for correction. Always try to cover those bases when you're listing concerns. Now, I've read this in many reports, and I don't know who the software providers are that put this in there that you should edit, but this is what they say in their general view. 1 or more receptacles in the house has reverse polarity. And I've seen guys put that in the report, and that's all they put. Okay, 1 or more? Was there 2 or was there 27? Where were they? Be specific. That's a useless, you're going to explain that one in court someday, and you don't want to. So don't use that. And that's actually in the verbiage, the canned verbiage in some of these professional softwares that they're offering to home inspectors. But you can edit that and put it in your own words, you know, or detail it. Where was it? How many were there?
So the complication with that is that we're not moving furniture.
That's
so
true.
If we can't get to everyone, now you've itemized the ones you did see.
Yeah.
You know, people infer that the ones that you didn't note are okay, but you just simply didn't find them because there was furniture in the way.
Right, but I mean, if you say 1 or more, that's indicating that it's going to be several. I mean, now, yeah, you can't say that one behind that couch is or isn't reverse polarity. But if you find one, I mean, if you just say 1 or more, and if I found one, I'm going to say it was in the living room on the west wall. If that's the only one I found, I'm going to say where it was. I'm not going to just say 1 or more, you know. Okay, describe the system.
Can we, Sean, can you weigh in on that? On this idea that if you didn't move any furniture, you found 2 or 3 receptacles, reverse polarity, but half the receptacles you didn't test, are you providing more valuable information by identifying the locations of those that you did find, inferring that those that you didn't report were okay, but really you just don't know because you didn't test them because of the furniture in the way?
I would make sure that your report has some kind of canned language that you didn't test every outlet, unless you did. And then in a comment like that, I would definitely put the locations of the issues you found, and then something at the end, others may exist, further evaluation recommended, something like that.
Right, not only for reference to your client, the electrician's gonna come fix it. He's gonna wanna know which one's got reverse polarity, because he's gonna move the couch, and he's gonna, if he does it right, and find out however many, but he's gotta have a starting point. So
Exactly.
if that's reverse polarity, anything downstream of it's gonna be reverse polarity. So you need to report that location of the one you found. If you didn't find any more, okay, but just to say one or more and not tell them where it is, it's not good reporting. Agree with that?
I totally agree. Think about your mother reading the report, and if she's going to be able to realize or know what you're saying.
Yeah. Thank you, Sean. Okay, we've gone over this, describing the voltage, overhead or underground, service size. You want to do the amp rating. Sometimes that's difficult to. It's the least of the conductor size, the rating of the panel, and the overcurrent protection device. Sometimes we can't see the writing on the service entrance conductors, and a 250 kcm in physical size looks a lot like a 4-aught. It's kind of hard to just visually look at it and tell you the difference. And that's a pet peeve I have with a lot of conductor marking. Put that in big print where I can see it. You know, stamp it all the way around. They put it, and it fades, and it's always on the back side, and you can't see if it's a 2-aught or 3-aught or whatever. So sometimes that's hard to determine the conductor size. Now, the breaker size and the service rating of the panel, you should be able to get that from the information on the panel and looking at the breaker, but that's how you describe the amp rating. What are the predominant wiring methods? What do they use? NM cable? Is it Chicago guys in conduit? And you know, they don't allow NM cable in the Chicago area, I'm told. Describe the predominant wiring methods. Service equipment, and who made the equipment? I always, you know, I'd always tell, if it's Siemens panel, describe the panel. That's not really a SOP requirement, but I would do it. Invisible grounding methods. We talked about that earlier. Okay, look for clues and maybe something's not right. That's pretty obvious something's not right here. Brother-in-law has been here, or Uncle Charlie, for sure. Some can be obscure. Now, this is a condo complex. What looks weird about that? What's this little guy here going between these two disconnects? Well, that jumped out at me. I thought, so I macro view, did a micro view. I don't have a picture of it, but what they had done is they had run the refrigerant lines and everything to this condenser from apartment A, but they ran the electricity to this condenser to this location, to this box. So they had to make a splice and run this conduit over to here to feed this disconnect to turn this unit off. Same way here. Those are going across. So if the technician has to come out and he's got to, maybe this little box has gone bad, he's got to change it out. He got to get permission from this guy to go in his condo to turn off power, because there's still some hot wires in there because they're using it as a feed-through junction box. So that's just something that, you know, you could overlook that pretty easily, but you say, why are those two connected together? And that's why. They had set them in the wrong place. This was the fix. This is the guy who came out and did it. And I mean, it looks stupid, but that's okay. At least now they're not feeding through each other. And he did label which apartment went to which. So that was the fix for that. So that's just like a micro view. Now that one's pretty obvious. That's not mine. That's been around the internet for years, where they use the drywall screw to tap into the service conductor and feed a panel. So And the argument would be, you know, it worked, the light came on, what's your problem? Okay. They visualize how they fit in older homes. If you're not, you know, if they're all test grounded, and then you go to the panel and you don't see many equipment grounds coming back, that's a pretty good clue that somebody's done some bootlegging. You know what a bootleg is? That's where at the receptacle you put a jumper from the grounding screw to the neutral. You put your 3-light tester in and it shows it's properly grounded, which it's not. That's a bootleg ground. Okay, thank you. Service upgrades should always get a closer look. This is one that I was doing a compliance inspection for VA on this. They put an addition on this house. Actually, this is a little bit after the fact. I walked by the guy and he's got this meter box open before he added these 2 new disconnects on the side. He was upgrading to a 400 amp from a 200 amp service. He's got the meter pulled and he's trying to stuff 2 new wires on that load lug to feed his new addition, double tapping, and he's cutting strands when I'm going by to make them fit. I said, of course, I'm supposed to be there doing a compliance inspection for specially adapted housing for a disabled veteran. I'm nosy, I can't help. I walked by and I said, dude, what are you doing? And then he starts just confessing to me like I'm the priest and he's in confession. He said, man, I'm the heat and air guy, and the dadgum contractor told me to do this. And he said, he wants me to hook this up. And I said, so you're doing the electrical work? He said, yeah. I said, who pulled the permit? He said, he laughed. He said, he's a general contractor. They let him have the permit. I said, that's wrong. It's a little rural county outside of Nashville. But anyway, long story short, he comes back and he said, well, what should I do? I said, well, he still double loaded it, but he was going to downstream this other panel. So he puts 2 200 amp disconnects in here. But if you look, he ain't got with the utility company. That's where he cut the tag off. So that's still their drop to this meter base is still rated at 200 amps. And he's adding 400 amp. And the guy's fixing to put a woodworking shop in there. He's fixing to have some heavy loads on this. So anyway, I called the code inspector on this and he said, well, I kind of saw that, but I put my blinders on because I was just going back looking at that addition, the panel he put in there. I said, well, take your blinders off and go back out there and look at it. He was a young guy. He did. So they got the utility company involved and they ended up having to put a bigger drop, put a CL320 meter in meter base in there and redo the whole thing. So anyway, I failed that and didn't really have the authority to because the code guy had approved it, but the contractor, there was a draw inspection. He doesn't get paid till I approve the VA part of it. So that put a little light under his butt, getting him to get it fixed. So anyway, like I say, don't be scared to call things out. Common sense, this is inside a cavity for a whirlpool tub. You can see the receptacle was put in before it's all framed in. If I'm the electrician, I've got to go back and change that receptacle when it goes bad. I got to have mirrors set up to see it. I can't get in there. It's in this little cubby hole. Put the thing facing where the guy can get to it, you know. See that a lot. There's a bootleg ground. Okay, we've got several things going on. I think we've got 3 or 4 minutes, maybe. In this one panel, you see triple tap on the bottom, double tap, next one up. That's also a tandem breaker. It's got a multi-wire branch circuit going off the same leg, which is bad. Double tap neutrals up here. That's a micro view. Just look at this stuff. Circuit legend, jacuzzi. Okay, that's kind of funny, but then you look closer, a jacuzzi has to have ground fault protection, correct? Whirlpool tub. That's an arc fault circuit breaker. Well, the guy that was doing this, he said, it's got a test button on it. That's all it needs, right? He thought as long as it's got a test button, it's good for a bathtub. This one's not important. The washer's on a combination arc fault, but you just want to verify that, which is required for laundry's arc faults in newer codes. You just want to verify that in the laundry, that washer receptacle is ground fault protected. Normally, you'll see the dual function on these now. Another panel that does not have the retainer on this back-fed breaker, 125 upright. You can take that breaker out and it's still hot in your hand with it off. Pre-drywall inspection, they'll just barely miss that NM cable. That's not a good idea. You can stand in the tub and change the light bulb. This is a Federal Pacific. It's got a duct tape on it that says "Do not touch," and it's signed Daddy. So if Daddy says don't touch it, don't touch it. This is a pull-out HVAC disconnect. I've seen a lot of failures with these. Look at these guys. The T-bar does not always seat well in there and get a good connection, and they melt down. This one, I've changed 4 personally. Look at those close, and when they first start getting hot, you'll start seeing a little deformation in that plastic or a little crack. You have to really look at them. There's a reason they cost about $8. There's the melt. There's one that's broken. That was in new construction. It just came apart when I pulled it out. That wasn't even energized. It wasn't even powered to the house yet. It just fell apart in my hand. There's one that was still energized in an attic for an electric furnace in an attic. This was still hot. And people say, why didn't it trip the breaker? Keep in mind, heat does not trip the breaker, current does. So it can have 2 amps on it, called a glowing connection, and it can sit there and burn and melt down and never trip that breaker. The current will never get up to trip the breaker. So that one was still energized when I went out and turned the power off and took that picture. You've seen that one. There's a GFCI tripped, still showing power. That's the line and loads reversed on that. That's too close for comfort in an old wiring. That was actually 240 volts. At least they marked it. If you've ever seen that with your 3-light tester, that one actually had 240 volts on it. That's what it's telling you. Somebody had a window air conditioner above that and took the 240 volt receptacle out, put a duplex out, and put the hots on each side and made that a 240 volt receptacle. Somebody plugs their hair dryer into that, it's not going to be good. NM cable on exterior is not allowed in wet locations. Interior of a conduit in a wet location is considered a wet location. NM cable is not allowed in conduit in wet locations. Okay? You see it a lot. Plumber got there first. That's the overhead riser that's pulled out of the meter base. Arcing on the bus stab in the panel. That's pretty common. You look for that. We put the child-proof covers on there, but we didn't put the cover. So this is a chased-in new construction. This is a dryer vent, and that's going to be enclosed, and that's a junction box. That's got to be accessible. Had to make them pull that out where it was on the exterior where they could get to it. Discoloration on that neutral, look for that. Heat will show through discoloration. There's one that's very obvious, melted on that square D breaker that's in a Bryant panel. It shouldn't have been, but that's not what caused that. It was a loose connection.
Question.
Plumber got there first on this one too.
Our standards in Maryland require us to check for loose connections at breaker wires and connections, and without using a torque screwdriver or another tool, and without pulling on them, it's almost impossible to meet that requirement other than an insulated screwdriver. But I see
The standards require you to check
for loose connections.
Well, I would assume they mean a visual check.
Correct. But again, that's not, I inspect new homes with an insulated screwdriver and I find loose connections all the time where I rotate the screwdriver 360 degrees. So they're obviously loose.
Right.
So,
And electricians are supposed to be using torque screwdrivers now, and the inspectors are supposed to be checking that, but that's not going to happen. Yeah.
All right, guys, it's time to wrap it up here.
Okay, we're going to wrap up. Here's a summary. Follow a plan. Use safety procedures. That's very important. If you're not safe, you're not going to do the next one. So that's really important primary. Use the macro and micro method. Be specific and concise, like we talked about when you're reporting concerns, and use proper terminology. And always recommend safety upgrades, regardless of code timelines. If you think it's unsafe, recommend an upgrade. You can do it as a recommendation. It doesn't have to be a requirement. But that's it, guys. Thank you.
Just real quick, my name is Stockton Barney. I'm with Inspector Pro Insurance. By show of hands, who gets their insurance through Inspector Pro? Cool, about half. So I've got some work to do. How many of you are ASHI members? Pretty good, pretty good. So we've got a relationship with ASHI. If you don't get your insurance through us, we've got a partnership with them where we get you a discount on your insurance along with a couple different policy benefits like 5 years of free tail coverage, which that's not even something that you can buy on the market. Little bit about what I do. I kind of describe myself more as a risk management specialist when it comes to the home inspection industry. I happen to write insurance, as a main part, but most of my day, I'd say I spend helping home inspectors and advising them how to be better protected against claims and lawsuits. I only handle home inspection insurance, so I eat, sleep, and breathe home inspection liability. Yeah, I used to live in this area, so I'm pretty familiar with kind of how houses are built and stuff like that in the market in the area. So if you've got any questions about liability or you're looking to get a quote or anything like that, feel free to come by. I've got a ton of books left and I'm not taking any of them home. So please come stop by and yeah, let's talk.
Okay, I usually start my presentations where I let you know that I bring a case of toilet paper to the meeting, because if you haven't crapped your pants by the time I'm done, I didn't do my job. I forgot the toilet paper. So first come, first serve. That's supposed to go over a little better with a little bit of laugh. There we go. There we go. Thank you. What I'm going over here, guys, is years of construction defects investigations, and it started early on in my career where I did a lot of repairs on buildings, and I would look at them as I came in. I started as a framing carpenter when I was 19, and then progressed on, did my own home building, but the real education came was when we started remodeling and seeing all the things that were in failure from the houses that we were remodeling, and look at the problems that were built into them. And you guys as home inspectors are expected to catch all that stuff, right? For your little bit of money on your, I'll just tell you right now, you guys don't charge enough for home inspections. I don't care what you're charging. I don't care. Get it up there a little bit. Do a good inspection, get the price up to where you can feel like you're able to spend the time it takes. These are just going to highlight a lot of the failures that I see and let you know what's behind maybe that stain that you're seeing. How many of you are familiar with adhered masonry, the new lick and stick? How many of you remember the EIFS problems? The EIFS problems are going to seem like a tiny drop in the bucket compared to the problems that you're having with adhered stone veneer. I'm currently in one area, currently in my third $2-point-something million lawsuit on stone veneer failure, and I've got 3 more condominiums to go that'll be the same. All the telltale signs are there. We're going to go over them. There's a little bit of reading that I'll be doing here. Your inspector tools. Tell me what your most valuable tool you can bring to the job is. Your brain. Your brain. That's right. Our brain. How can we make that tool even better?
Listen to you, Ken.
Okay, thank you. Yeah, you come to the mic and make that statement? He said, listen to me. Be observant, look, get experience, listen to others, and look at your past mistakes. That's a good part of it. We need to dedicate ourselves to being lifelong learners, and we need good judgment. Anybody know where good judgment comes from? Where? Here's a slide I found. Now, Mark Twain and Will Rogers both take credit for this, so I don't know who to give credit for. Did I just run out of battery? Am I still? Okay. But I'll take credit for it now, okay? Let's go over that. Good judgment comes from experience, and a lot of that comes from bad judgment. What you do out there, you make some judgments, you make mistakes, you get experience, hopefully, and now your judgment refines. Inspecting exterior envelope and the enclosure. That's what we're going to go over here. These are some points that we'll cover throughout the presentation. We need to be able to identify incorrect and missing application details that can and will lead to moisture intrusion and degradation of the structure. We should have a good understanding of the building code requirements and manufacturer requirements for exterior cladding. And I know out here you guys can't really cite the building code, but you ought to have a good working knowledge of the building code and what is required. The building code, by the way, is the lowest standard. Do you know that? The building code is your lowest standard. Manufacturer's installation instructions will trump the building code. There's a thing called the ESR, Evaluation Services Report, and you can find it for James Hardy. That document tells you how to do things and what to do with them. And in those documents, it often says, where this document and code disagree, this document prevails.
I was going to mention exactly that the manufacturer's installation instructions trump everything, including what the builder says is, oh, that's the way we do it anyway.
Yeah.
So if you can find a copy of the manufacturer's instructions, I often include a piece of that in my report saying, this is the way it's supposed to be done.
Yeah. And you'll hear people say, Hardy specifically, oh, well, they change all the time. You know, I've got every single installation document clear back to the 90s, and you will see little changes, but I will challenge you to find big changes, and any changes that they do make are for the better. Hardy used to say initially 2-inch clearance from the roof line. Then it changed 1 to 2-inch clearance. And then they came out with the zone system, which zone 10 is your southern states and zone 5 is your northern states. Zone 5, clearance, 2 inches. Zone 10, 1 inch. There's nothing that says you can put it against the shingles. That's where we see our failures. We can learn to be the expert, or we need to know when to call an expert. This will give the homeowner and the most thorough inspection and reduce the potential liability from you, the home inspector. There's another guy back here that can help you limit your liability to at least what you have to pay out once you miss something, right? Building envelope enclosure defined. We're going to go over that. Waterproofing principles. Exterior envelope enclosure inspections. Various claddings, telltale signs of a job gone wrong, adhered masonry veneer. This is the new problem. This will make the eaves problem look like a tiny drop in the bucket. We'll go over critical installation details of adhered stone veneer. Is this stucco? Is adhered stone veneer stucco? Yes, raise your hand. No, raise your hand. The no's are wrong. Sorry. There's a lath and scratch that's put on. That is your start, okay? And instead of troweling on a finish coat, you stick bricks or rocks into the finish. It is a stucco. Code defines it as such. We've brought it into court and had satisfactory results when people say, no, it's not stucco, and we bring our case forward. Does anyone do it correctly? Not many. Not many. How do you know whether it's correct or not? This course is going to show you a little bit of that stuff, telltale signs, but the EDI, Exterior Design Institute, has a certification course for inspection of stucco, eaves, and the newest one is stone veneer. And I would recommend anybody who wants to specialize in that, definitely take the course. EDI, Exterior Design Institute. Here's the definition, or my defining of the building enclosure. The combination of roofing, waterproofing, damp proofing, flashing, and diverter systems in combination with all exterior facade elements acting cohesively as a complete barrier to the natural forces and elements, particularly that of water and weather intrusion. The system envelopes the building or structure from the top to the bottom, from below grade to the roof. It's your total exterior enclosure. The entire building exterior skin must be enveloped to prevent water infiltration. It is important to recognize that every component used in the envelope of building skin must be waterproof. Every element. 90% is not good enough. Is there a test? Do you guys have to do a test after this? Sometimes they do. These little explanation points are kind of to bring you to attention that if you did have to take the test, I just gave you an answer. Waterproofing principles. The first principle is the 90%, 1% principle. 90% of all water intrusion problems occur within 1% of the building envelope or structure, the exterior. 90% of all water leaks happen within 1% of the envelope. This 1% contains a termination and transition detailing. This all too frequently leads to breaches and complete failure of the effectiveness of the building envelope and is the main cause of all waterproofing problems. Somebody didn't do their job right. The second principle, 99% principle. Approximately 99% of waterproofing leaks are attributable to causes other than material system failures. It's other than material system failures. These include human installation errors, wrong systems being specified for in-place requirements. The example is thermal movement encountered exceeds a material's capability. You put a sealant joint in, and the movement of that joint that it's supposed to protect, it exceeds the ability of that sealant. Does anybody remember when Hardy used to say, leave an 1/8 of an inch gap and caulk it? Always a failure. Why? If the Hardy moves, if you left an 1/8 inch gap and it moved an 1/8 of an inch, how much joint movement is that? 100%. Most of our polyurethanes will only allow a 30% joint movement. They can only expand and contract 30%. So you move 100, you have a system failure. The wrong or no primer being used. Many sealants need primers, not so much in residential, although I can make a case for some materials that we're using in residential that you should put a primer on before you apply your sealant. But most of your residential builders don't even know that, and half of your commercial builders don't know it. Inadequate preparatory work. Back to sealants. So many people don't clean their joints. In the wintertime, you should defrost your joints, whether you know there's frost on them or not. And what it is, it's just chemical that you wipe on before you do your sealant, and it evaporates any moisture there, so you know you don't have frost. Most people, that's new news to a lot of people here. It's generally new news when I present it even to sealant contractors. Incompatible materials being transitioned together. We have window flashing tapes that are incompatible with some of the sealants that we use, and when that sealant touches it, it will liquefy the asphalt. Have you ever seen at the top of a window just these little black streaks running down in between? I'll give you Anderson Windows uses a tape across the top, and some other brands, where you have a mullion and sometimes you see black streaks coming down. Anybody ever seen that? Okay, well that is where they used a solvent-based sealant at the top and it liquefied that tape and it bubbles out, especially on the south side where the heat of the sun will just exacerbate all that and it bubbles it out underneath the sealant. Insufficient material being applied. So many people use their caulking and then they wipe it with their fingers and they took off half of the sealant that they just put on. A sealant bead has a certain dimension to it, and it should generally be bigger than anything that anybody's putting on, but everybody likes those petite little beads, and they look good when they're new, but they fail in the first season. Capillary rise. We're gonna talk about moisture. I wanna make sure, yeah, I can get this video going. This just shows you what capillary action does. And how fast it can rise in the various materials we use. That's a concrete block, that's 16 inches. Obviously a wood block, 16 inches. These others could represent cracks in your concrete slab in the basement. If you notice this one, right here, the thinnest one, rose the most. You guys have basements here? Yeah. Okay, I talk in places that don't have basements and they get a confused look. You have sump pumps. Okay. If the sump pump isn't working and the water touches the bottom of the basement slab, just touches the bottom, the narrower the gap, the higher the capillary raise. The water doesn't have to come up and overflow out the sump pump. It will climb through that concrete. And if you have carpet on the top that has an absorbent backer underneath it, it will form a suction, and you'll find at that crack, you'll find the whole room wet because it just keeps pulling. That's just an example of capillary. How high can water go in wood?
365 feet or something.
Because of why? What is that? What do we call those things that are 365 feet tall? Exactly. There's no pump. Water capillary rises to the top of the tree. So in wood. And there are some engineering studies that I've read that say water can wick up in concrete 5/8 of a mile, 1 kilometer. I've never seen it, but I have seen rising damp in a concrete structure that's 3 feet up. And that's pretty easy to have. Exterior envelope and inspections, again, determine what kind of claddings are in what type of cladding or what kind of cladding. Cladding, siding, brick, stone, whatever. What are the unique characteristics of the claddings installed on this structure? When you're inspecting it, you need to know what you're inspecting and you need to know installation details from the manufacturer. how do these various claddings interface with one another? Remember what I told you about the 99 percentile percent, or the 90%, 1%, 1%. I'm getting back 90%, 10%. Your leaks occur at transition points, you know, where a siding comes down and transits to a sill, a stone sill. Those are not flashed right a lot of times. Leaks happen at windows. They're not sealed right. Review and familiarize yourself with the installation guidelines. Before you can do a proper inspection, you need to know what you're looking at and you need to know the requirements. Various claddings, we're going to talk about fiber cement, vinyl, steel, wood, composite, such as LP SmartSide, wood, brick, adhered manufactured stone veneer, EIFS, it's pronounced EIFS, not EIFS. Where's the I? It's not between the F and the S. EIFS, exterior insulation and finishing system. DEIFS, it's somewhat newer, same as the EIFS, except for it doesn't have the insulation on the outside. They're coating over Durock or Hardy, or for a while LP made this OSB stucco board, which they coated over. And they coat over it with basically the same things as the EIFS. You can use Dryvit or Stow, Parex, any of those chemicals. They have some made for that, those materials made for that. That's what DEIFS is, direct applied exterior finish system. When you go up, you guys, do you have much EIFS around here, the foam? How about the DEIFS? Yes. Do you know how to tell the difference real quickly? Yeah. If it's hollow sounding when you wrap your fingers on it. The next way is to get out your saw and cut a core sample out of it, and then you can show, but do it nicely because then you can put it back in. Okay. Guys, I get to do that. In my job, I told my mom this before she died, and I think she was a little bit proud of me. I told her, Mom, you know, the things that used to spank me for, like drawing on the walls and cutting holes in and making a mess. I said, people pay me for that now, and they clean up after me. So she felt pretty good. I felt pretty good. I made her laugh. Fiber cement, it's fragile while handling. How many of you have ever installed fiber cement? It's fragile, isn't it? Pick it up wrong, it'll break, or if it's too long, it's easy to break. Dust is harmful when cutting. Clearances must be maintained. It's easy to overdrive the nails. Clearance requirements vary regionally north and south. That would be for Hardy. Zone 5 is different than Zone 10. What are you guys here? Are you Zone 10? Maybe 5. 5? Okay, then you need to, when you're evaluating James Hardy, you need the Zone 5 installation diagrams. This is, the clearance is okay, right? What's the failure here? Didn't paint the cut ends. The new Zone 5 material is less susceptible to this than the old Zone 10 material was. The old Hardy, which basically they haven't done a lot to it in my understanding for the Zone 10, but the Zone 5 is a lot less absorptive. So this would be the older plank, and it absorbed water pretty readily. This is a little ding during installation that didn't show up until afterward. We get a little bit of freeze thaw, a little moisture in there, and it freezes. What happens to moisture when it freezes? Expands. How much? 9. But you might be able to get a 10 out of it. But it's pretty, but still that's big. That's an expansion. Now you can let a little more moisture in, and now we get a bigger expansion. And that's why this stuff shatters and falls apart after repeated freeze-thaw cycles. When you go to the mountains and you see these big boulders that have fallen down, that are kind of broken up and stuff, That's because of freeze thaw. It loosens some of this rock, not the actual big boulders, but the rock, the shavings of it. Freeze thaw. Pretty soon you have a big rock across your street, or a multitude of them. That's a freeze thaw. That's just an example of the power of it. This is what I was telling you about that, the joint, and it's sealed, and it cracked, and it allows water in there. The narrower the gap, the higher the capillary draw. So when it rains on a really narrow gap, that water is drawn in. It was drawn into this siding, it wets the siding, and then during the freeze thaw cycles, all the water kind of pops down to the bottom of it. It generally goes down there, and then the freeze thaw just spalls this apart. I can show you whole neighborhoods where it looks like this, and that's why. And the ones they didn't caulk are still in great condition. This is nothing but a nail that's, well, it's not really technically too close. It's supposed to be 3/8 from the end. But when they did fire it, it fractured the piece, and then over time as it moves, it pulls apart. CertainTeed made their weatherboards for a while, and it was really prone to this. CertainTeed made a cement board, and you can identify CertainTeed problems. It vertically cracks through them. If you ever go to a job and just find all these vertical cracks and a lot of this end nailing here, you can be pretty certain that it's CertainTeed. I was involved in their class action as an investigator for just a brief time, and there's a lot of problems with the CertainTeed, and it's being manufactured under a new name now called Allura. So,
What about face nailing?
Well, it's a blind nail product, okay, but it is allowed to be face nailed. But you don't, and as a matter of fact, as it gets wider, in like a 12-inch, you have to face nail it. They don't allow blind nailing.
So I want to remind everybody, please use a mic when you have a question. Thank you.
The question was, what about face nailing? I'll try to repeat the little ones. What about face nailing? It's allowed. You can't double blind and face nail. And the reason why is they don't want you firing your gun in and hitting that other nail beyond. That's why. It's not that it's going to hurt anything, other than once in a while you're going to hit those and it's going to mess things up. So if you ever got to a job and it looked fine and it was all face nailed and you thought, oh, it's blind nailed, well, it's a kind of a no harm, no foul deal. What's wrong here? Just overdriven and sloppy. When you overdrive a nail, you're supposed to caulk over it and then drive another nail in a close proximity that's properly face nailed. And they do allow face nails on the edges, you know. I mean, they don't disallow them. This is what happens in our freeze thaw environment when it's too close to the roof. It's touching the roof, and you have your freeze thaw and you're spalling. That's why they want 2-inch clearance. What's that? Golf ball. Yeah, close up to 200 feet from the tee. There's been other balls that went over the top of this house and hit windshields in cars. And it's just the privilege of living on a golf course. Yeah, and the neat thing about it is after they smack your house with that ball, a lot of them don't have the guts to come pick it up, so at least you got a new golf ball out of the deal. This is fiber cement. It does not support microbial growth. However, the dirt that grows, that is on the outside of the siding can support it. You ever see vinyl with all this mildew on it? Vinyl can't support a microbial growth. Vinyl has a static electric charge that pulls dust and dirt to it, and it just gets dirty. And then the dust and dirt is what supports that microbial growth. Vinyl can't in itself. This is one of my houses. We're going a little sideways. We're talking about hardy, but we're just gonna, I got called to do a leak investigation on this house. New house, less than a year old. So there's my thermal image of the, right along there, you can see the discoloration. We're 44% in the carpet tack. Anybody do any moisture testing? Tell me about 30%. What is that threshold? Saturation of wood fibers. Yeah, anything above 30% is just relative. Some of your moisture meters, depending on the brand, don't even go much above 30, because that's considered 100%. Anybody do any drywall moisture meter tests? Do you have a drywall meter scale? What? Yeah. 4 is high. 3, drywall is considered saturated at 1%. Now you can use a wood moisture meter to check your drywall, but don't ever call it out as that percentage. Call it out as elevated. And the best thing to do is go around and take some different, if I'm there to do moisture meter readings and I see something that I know is wet, I'll go get some dry standards too. And I can call it elevated based on that. You got to be careful how you do it, but just use that. And the more you do, the more experience you get in these little things. There's my probes. They're into the wall plate. We're down into the wood subfloor. There's my probe. There's how far it went in, about a ½ inch. This is down the basement. Pull the insulation out. It's elevated. I joists really enjoy water. Now I go outside to look at where this leak is. The builder had already tried to fix it. We're up on the roof. There is kick-out flashing. It is not right, but they tried. And then look at this. See that's LP Smart Side trim. Do you know what the clearance above the roof is supposed to be for LP Smart Side trim? 1 inch. Does that look like 1 inch? No. So I call that out. We go around the corner. There's the builder's fix, caulking it. But you know what it does up here? That's open. So now we have a big funnel of water that can just fill, and then it fills up, and then it can get under the shingles and then go in. So he exacerbated the problem. Now we take it off. No house wrap. It's required. House wrap is required on the entire building envelope, including the gable ends and the unheated garages. A flashing without counter flashing is what?
Wrong.
A funnel. Who said that? Yeah. You've been to too many of these. Well, I would expected you to pipe up. So this is what it looks like. And by the way, while I'm there, I'm just going to look at everything. And I ask questions. Does your hardy ever rattle when the wind blows? Well, yes, it does. It wakes us up. I shouldn't do that. So that's loose. Now hardy allows 3/4 of an inch to 1 inch down. And it needs to not be overdriven. That's the nail placement. Not this far from the top like I so many times see. And generally, the little gun, the mini coil nails that they're using to apply it now are technically not big enough in the head. Now it's a technicality, it's pretty small, because they're about a 32nd, they want you to use a 1/4 inch head, and these are about a 32nd inch smaller than a 1/4. So I can call them out depending on what we see.
Mark, let me interrupt you just a second.
Yes.
I have a question. I'm just going to read this. It's about scanning type moisture meters. What he's saying is, do scanning type moisture meters measure percent of moisture by weight or the percent of saturation? I get readings like 78%, which make no sense for percent by weight.
I use a scanning moisture meter as a tool to show me elevated moisture when I'm just curious about an area that may or may not be wet, and I don't ever rely on them. I'm going to probe something. If I really want to determine whether it's wet, I'm going to probe it. They're a good first diagnostic tool, but I'd never use it. The little handhelds. Now I have a Tramex roof wall scanner that I do use when I'm doing a flat roof, but you got to be very careful with that too. When I get to an elevated area, I'm probably going to pin it and patch it, or I'm going to do a core sample. Is that good? Okay. Be careful when a scan. It's another tool. Know your tools. Check your tools. Even when I carry 5 moisture meters with me, and I'm always got 2 in my hand, and I'm checking them against each other. And a protimeter is one of my favorite ones. But when I'm pinning things, I'm always poking myself just a little bit just to watch it go up, because I'm always making sure it's working. Or if I'm using the scan function, I'm always putting it against I'm watching it. I'm always watching that meter's functioning like I know that it should be. I'm familiar with my meter, but even with the familiarity of it, I'm always just double checking it to know that it's working. The last thing, I do a lot of expert witnessing. I got 38 cases going right now, somewhere from just starting to just finishing. And those are my ones that are kind of that I consider in litigation. In the last 2 weeks, I've got 5 or 6 more that I think very highly possible will go to litigation. There's an example of the high nail that I told you about, and then that's no good. Too close to the edge and it fractures. There's no way that one of those nails hit. We're going into an 1.5 inch stud. There's no way that one of those hit. One might have, the other one didn't. What's wrong right there? It's a horizontal surface. It's required to have a flashing protection on top of it. That's both by the manufacturer, that's LP. And if it was Hardy, Hardy has their same thing. And the building code says no horizontal wood surfaces without flashing protection. The only thing that you could have there that would be okay without a flashing protection is a piece of PVC, because it's not susceptible to water.
Hey, Mark.
Entrainment. Yes.
Can't water still get in to the building enclosure if you're using PVC or something like that? It's not necessarily the trim, but.
No, you'd want to make sure it's caulked at that point, like this.
Okay.
You know.
The problem with PVC is that you don't install it correctly, a lot of people use 18-gauge nails.
Oh yeah, it'll move like crazy. Yeah. He's saying that the problem with PVC, a lot of people use 18-gauge nails to install it, and it has a high expansion and contraction rate, especially if somebody paints it a dark color. There's a certain light reflective value of paint that you use for it. Now, some of the painting, and the darker the color, the less reflective. If we'd call white 100% and black 1%. Now, they have some darker colors that they're doing some paint additives that make it a higher reflective so you can get dark colors on your PVC. But that stuff really moves, so you got to be careful with that. Yeah, and my favorite fastener for it is a Tech screw that you screw it in and then you put a vinyl plug in it, and that holds it pretty good. It still has heavy movement no matter what you do. Not painted. It's required to be painted wherever exposed fabric is, or I mean material is. It's required to be painted. Another example of it, like I say, I was there to do the leak investigation, and out of that came a 60-page report and litigation against the builder. Gave them a chance to fix it, but they just didn't seem to be able to. Here is the HZ5 overview of installation. You can drill down and get deeper on every one, but that's a good thing to take with you if you're inspecting fiber cement. It gives you a good overview of the requirements. This is available online. It's real easy to find. Go to James Hardy, install Pro, and download their manuals. These are good things for you to have. Then we get to the deck, and we get to the joist hangers. And tell me this, guys. You know those angle shear nails that go in? How long are they supposed to be? A minimum of 2.5, probably 3, not 1.5 inches. You can't use the 1.5 inch Tico nails for your shear nails. Do you guys get to pull a nail out and look at it? Yeah.
Mark,
Yeah.
If you can pull it out with your fingers, you can pull it out. Don't feel like you're going to damage it. Go ahead, pull it out.
Just make sure you drive it back in with your fist.
With your fist, right.
If you pull it out with your finger. Yeah. This just shows, I'm pulling it out. There's the ESR 2523 on the bottom of the hanger, and that is a code document that is a index that you look up your hanger, which was an LUS 210Z, and you find out where that is, and it takes you to another code document, and in that code document, it'll tell you exactly what nails to have in it. And they all say either 2.5 or 3s. It depends on the hanger and the weight, but it's there. And then not only that, there's a little one that gives you a little more graphic. You can see how the 1.5 inch nail doesn't quite fit. And then this is what should be there. A 10D by 1.5 doesn't even begin to penetrate the ledger board. And then a 10D will either be a 2.5 or 3 inch nail. A little later on in the thing, I think I show on the side of the joist hanger, there is a graphic there that shows the longer nails. And there's a little web address that you can go download the installation documents. But I guess if you have somebody out there that's looking, you'd be thinking he was fiddling on his phone and fire him as he tells you, no, I'm really looking up the installation documents. Yeah. We're back to this. What's the clearance at a ledger board on a deck? 1 inch for LP, and Hardy allows 1 inch on their new Hardy trim. It used to be 2, and if it's siding, it's 2 inches. If it's LP siding that's down there, it's 1 inch. But always remember this, it's either 1 or 2 inches, and you don't care. This is wrong. Right? I don't care what material it is, unless it's PVC. Yeah. This just shows how a deck ledger should be flashed. You guys, when you look at decks, you should be able to go under and look up under there and see the flashing. This was another reason they wanted me to come out. The stones were falling off, okay? Just not put on right. And the contractor had come back. This is an adhesion problem between the bedding coat and the scratch coat, because that's all bedding coat there. When you pick up the stones, there's no bedding coat on the back side of them. Okay, it's if it's an adhesion problem between the scratch coat and the bedding coat, then it'll be all over the stones. You had a question or statement?
So, can you hear me?
Yes.
So going back to you saying that that's just like stucco, right? Each one of those stones is unique and pressed into the mortar. So you're going to get water between the stones, which you usually don't get with stucco because it's a solid surface.
When I say it's stucco, it starts out in the lath and scratch section, and that makes it a stucco. It's just you put a different finish coat on, but it'll function a little different. It won't function the same as a stucco with a finish coat of stucco on it. No, you're right. You're right. And this is dry stack stone, and dry stack in freeze-thaw environments has a lot more problems because the water gets back in behind there. It can saturate. The bedding coat is supposed to be total and solid, smeared on the back of the stone, not a partial. So when you pull it off, there is a little bit of problem right here with this bedding coat, right there. See how that shouldn't be that gap right there. See that gap right there? That'll allow water to pocket in there and then push as it freezes. That's not what happened here. These stones were just loose. They're not good.
Doesn't even look like it's elaborate.
Oh, it's behind. It's on the scratch coat. Yeah. So I did a little survey. What I used is, I got tired of using my fist, because it gets tired. I did a 5-story hotel with just my hand, and I was bruised. So I bought a rubber mallet. I got a white one, okay, because it doesn't leave marks. I can beat you up and not leave a mark on you with my white rubber mallet. If I got the black one, it leaves all these, and they know I'm there. But so use a non-marking rubber mallet if you do these things. Yeah. Take a look at this stuff. These are all loose. I left the tape on there though, because I knew the contractor was coming. And they get, what's this? This is a drive-by inspection. I just driving by. So let's inspect it. It's kind of fun to be with me. Seriously, my wife just loves going.
You don't pay attention to the no trespassing.
What? I can't read. I can't read. Yeah, I don't pay attention to the no trespassing signs was the comment. Wait a minute, let's go back. I'm going the wrong way. I gotta get back here. I gotta show you something here. See that? What does that say? It says open. So I'm driving by looking for open houses. So AMSV on the garage. That has got the right clearance above. Now it needs to be painted underneath, okay? But that's got the right clearance. Hardy wants you to be a minimum of a 1/4 inch above any horizontal flashings. Now, there's a problem. Flashing is not embedded in sealant. That metal flashing on top is supposed to be embedded in a sealant. You never see that? I know. I hardly ever do either. The weave screed is present right down there, the little metal piece. Clearance is less than 2 inches. It's supposed to be 2 inches off of the concrete. But what they did was put an expansion joint in lieu of the proper clearance. I can let that go. Technically, it's not correct, but I understand the spirit of what they're doing. We have the frost heave of the driveway, and that'll either hit the stone and shear it off, or it'll crack the concrete, or both will happen. So the expansion joint, as long as it's out far enough, will do its job, and that is. Now, grouted to trim instead of a backer rod and sealant joint. All terminations of stone veneer or thin brick, any of this adhered stuff is supposed to have a backer rod and sealant joint. If it's Pella windows, it's supposed to be 3/8 of an inch all the way around, filled with a backer rod and sealant joint. Nothing's supposed to touch. That would include wood trim as well, by the way, in technicality on a Pella window. And I could show almost all windows need at least a 1/4 inch joint all the way around them. And so many times you see these wood trims stuck right, solid, tight to them with no sealant. And that is for expansion of the window, because a lot of vinyl windows are coming into play, and the sun shines on them and they move, and that trim board doesn't. Now, if the window ever fails because it couldn't expand, technically the warranty is void. So that's why we want to see that. There's parameters for everything that's done that are supposed to be installed. Here's a couple of points. No flashing protection at the horizontal surface top of the pillar. Hardy says nothing horizontal that's exposed. You put a flashing over the top. Now, right here, you see a lot of these, I'll bet, the Craftsman pillars. Almost all of them are done wrong. This one is a little more right, because it does have its joint here, and it does have a flashing protection here. But what about that horizontal joint there? There's a gap in the flashing. It's not doing its job. But we don't have a flashing there. Some of these designs don't work. People want it pretty, and they look at it, it just doesn't work. There's a flashing right there at the, but it's not sealed in, it's not in a sealant. What's wrong there? No clearance, and on a frost protected concrete, you can get away with 1/2 inch, but you still need a weave screed, and that's frost protected because that's on the stoop, so it's sitting on the foundation. It doesn't need the 2-inch clearance that you would have next to a sidewalk. That's not frost protected. Here again, remember the flat with nothing. Now there's a covered porch over here, and chances are that'll never fail, but it's still technically not correct. Penetrations. Now, it has the gap at the top, which I will contend is really ridiculous. That gap there is to let water out if it ever got behind the siding, okay? Let's talk about this. I have a little 4-inch gap there and I'm letting water out. If I'm getting water in and I have to let out a 4-inch gap, I got bigger problems than you could ever imagine. I'm all for, I know some people at some of these in their technical departments, and I'm working with them to come up with a standard of if it's 4 inches or 12 inches at a certain level. This is where we leave the gap. All others are caulked. Now, in this, that's a straight cut. They cut it straight, put the hole in, and put the piece around it. Can you see that cut right there that the arrow's pointing to? It's supposed to be a weather cut, 22.5 degrees or 22 degrees. It's supposed to be a weather cut. On all hardy corner boards and anything that you're butting together on with hardy, it's supposed to be weather cut. LP, no. Leave a gap and caulk it.
Wouldn't, even if that's weather cut, with a small enough gap, won't that suck water in?
It won't suck it up. It'll come down. Yeah, I understand your point. Yeah.
Those pieces of the weather cut should be painted prior to installation.
All cut edges are supposed to be painted. That's right. That's right. Now, there's the hardy detail. See the 22.5 degree weather cut right there? It calls it out. This doesn't have it. It's straight. But there's a detail for all these. You guys can find them. And this is technically correct. But here's the problem with that particular, there's my little probe, right? Now look at my probe. From this to this. So what's wrong with the caulk joint? That's a back dam caulking joint, and it's not complete. It should be shoved clear in there. That'll allow water to get back in. All cut edges must be sealed and painted. Meter panel, you'll find these different kind of mounts for stuff. At least it's mounted on a panel versus just mounted over the siding. But they use a lot of vinyl siding accessories for this kind of stuff. And I don't find any fault with this. It's sealed up here at the edge, at the top edge. And this is all drainable down the side. So I can't see what's behind the panel, but it all looks pretty reasonable. One thing I would say, that this should have been caulked down this edge and across the top, because the water can get down in there, come down, and whatever they came through with, probably a piece of conduit, the water can sit on that conduit and come into the interstitial wall cavity. Will it be a lot? No, but if it's the right exposure, let's just say they have a lawn sprinkler that's out of adjustment and it fires on that, it can cause problems. Oh, this was a drive-by inspection. So I went next door. No Z flashing between the LP panels. Anytime there's a horizontal siding and you have a panel, you're not supposed to caulk it. You're supposed to put a Z flashing between it. And then the corner trim, look at that. It's easier for these guys to put it on two pieces than it is to make that notch in there and make it fit. So they added an extra joint. And by the way, you know, I told you LP says butt it and caulk it. You got to leave 1/8 of an inch. I find a lot of those joints deteriorating in a rapid amount of time, and then water goes in, and then the LP panel starts, or the LP siding trim starts expanding. It does well at absorbing water. This is the detail from LP. It shows the Z flashing between the panels, or an alternate detail where you can stagger the panel out. That couldn't have been happened on, this was what's required. If you're doing hardy, same thing. It shows that you use a Z flashing between the panels. And if you put a trim on here, your Z flashing goes clear over the panels. just another, we already looked at that. It's another sealant not complete in these. You can check those out. It's a lot of stuff, isn't it, guys? So I know in a regular home inspection, you're not, what, for the money you make on them, you can't do it. You need to up your prices so you can do this stuff. I'm telling you. Did I get approval on that statement? I just keep reminding you, up your prices. Get these riffraff out of here, right? But you can eyeball back in there, and you can see that. You can see that's open. And that was just with my phone camera. Go ahead, I'll repeat your question.
If it's flashed properly under there the way it's supposed to be, do you still need to do that? Because if you have flash taping around the window like it's supposed to.
Well, this is on a, he's asking if it's, yeah, let's have a discussion. I got time.
So the proper way.
Hello. So the proper way to do that is to have flashing tape around the window before you even put that in.
But this isn't the window. This is. Oh,
that's just what, over a trim?
This is a block, so you really can't, you put that block over and it's just right on. So you got to have the flashing.
Right.
The way they do it.
Right.
Yeah.
Okay.
Yeah. Yep. And we'll get to windows. I'll talk about windows right now. Yes, you're not supposed to let any water back in behind your siding because deliberately, there's water going to get, I don't see a lot of water getting behind Hardy or LP, the smarter, the hard sides. I'll tell you where it gets behind is vinyl and steel. Blows back in there like crazy and it gets wet. It's pretty important to have those flashed. But yeah, that back dam needs to be back in there. That sealant back dam needs to be all the way because yeah, the window has got its flashing tape, but you don't know if it's going to migrate over and come down in and go in through a staple hole or even a nail hole because water clings to the surface and follows it in. It's got a surfactant, there's no surfactant, so it's got to cling to it. Yeah, surface tension. A surfactant releases surface tension and makes the water slicker. That's why in your dishwasher you use jet dry because it surfactantly treats all that rinse water and it can't bubble. No blocks. That's right. No blocks. That's required. Isn't that pretty? There's the LP detail that you will have a block. And they get pretty specific. Look at this. Make sure that you have a minimum 3/16 inch space all the way around this block. That's so you can put a decent bead of sealant in there and the sealant isn't three-sided adhesion. It's actually loose back in there and it can stretch and expand and move with the dynamic movement of the joint.
Two weeks ago, a builder told me Hardy does not require the siding block, the mounting blocks.
Oh.
Yeah.
Well, I can, I think I got some, where are you? Oh, yeah. Yeah, they do. And I have some diagram. A cider told you that? Builder. Oh, builder. Oh, well, shoot. Maybe I better go re-examine everything I know.
I put the pictures from HZ5 right into report for the builder.
Yeah. Well, they can't read sometimes. And
give them pictures.
And they're deliberately blind other times. And sometimes you can't read, can't hear, and deliberately blind as they go out and climb into their car and drive away. Yeah. I know I fight with them all the time too, on things. Because they have excuses for why they do everything. One of them I hear is, well, I've been doing it that way all my life and never had problems. And I tell them, you've been doing it that way all your life, you don't know how many problems you have. Or the better one is, I've always done it that way. Say, well, you've always been doing it wrong. And if you want to stir things up, and sometimes in our business, it does get heated and stirred up. That's why it's good to know and have the backdrop of information that you can bring forward to show them. Let them talk sometimes. Hopefully they sound, when they're coming with stuff you just don't know, just let them talk sometimes. There's one, it's mounted, but not on a block. They trimmed it, and they did this per the diagram, but water can sit on there and go right down in behind, and actually is kind of trapped because we have this one down here. Oops, copyright EDI, March 2020. Well, it's my PowerPoint for EDI, so I tried to erase all that, but I mean, it was my presentation to EDI anyway. So, sir, protected with flashing, that's good. This is just reinforcing what we say. Here's what I will say, is I think that flashing should be sealed, kind of set in a bed of sealant, or shouldn't we downturn this edge? But then when you downturn the edge, you got that little gap in the front. So it's always good to bed it in a little bit of sealant. Then you get complete protection. I want to go over this poor detail again. That's what's required, that gap. And remember this, if I have to let water out that's getting behind my siding there, I got bigger problems than you can imagine. That's 2 inches. Clearance at grade, 6 inches minimum. That's Hardy, that's LP, and that's code. 6 inches in residential, 8 inches in commercial. If you have brick on your house all the way up and you have dirt up against the brick, the dirt is still supposed to be 4 inches lower than any wood that's behind the brick. So if you were to drill a hole through your brick and find the bottom edge of your wall sheeting, the dirt is supposed to be 4 inches down below that, not piled up here. Yeah, well, mulch and gravel isn't as bad because it drains. I'm one who, if they got gravel, even if it's against their siding, I tell them about it, but I'm not making a big issue of it because it dries. Question?
I'm not questioning your expert witnesses, but I was a builder developer for 38 years.
Sure.
Built a lot of homes.
Sure.
You are pretty much approaching the manufacturer's instructions on how perfect everything needs to be. In reality, it really isn't so. I agree with some of what you're saying. I disagree with, well, it's not that I disagree with it, but.
I know where you're at because I was a builder too, and I understand the reality of the world out there.
Okay, but here we are, we're trying to protect moisture from getting to the subsurface to at least the house wrap.
Yes.
Et cetera, et cetera. But what do you say about a masonry veneer construction? Okay, when we have moisture condensation behind the masonry.
Oh, I'm going to get to the masonry veneer and all the failures that I've seen in masonry. Yeah.
Okay, I'll let you do your thing.
Yeah. No, that's okay. It's good dialogue. I had a house that I looked at. It was a $2 million house, all brick and everything. They hadn't put the weeps in, and code says you have a 1 inch brick space behind. The BIA now says they want 2 inches behind, not just 1 inch anymore. And that eliminates the ability that what they're trying to do is eliminate the ability of that squish out mortar from touching the house wrap. Because when that back trash mortar touches the house wrap, it forms a capillary bond, and the water will go right through your house wrap and rot your OSB. We've had several cases where we've had to pull the brick off and found the whole wall rotted from that. Oh, it takes a while in brick. The one thing that the builders could have done different to enhance that protection was, instead of 1 layer of house wrap, stick some tar paper over your house wrap, and now that breaks that capillary bond.
Then they'll say the house doesn't breathe.
Breathing is a wrong connotation. Your house shouldn't breathe. Your house should perm, okay? It should perm. So your house wraps all perm and allow moisture and vapors to escape to the dry side. Don't ever believe a house wrap is one way. It's 2-way.
No, but then we're getting into a whole different ordeal, because now we make houses way too tight, and we have to bring fresh air into them.
Yeah, well, that's how the code and that's how builders are going right now. That's what's required by the energy code, that the house be tight and you have fresh air and makeup air coming in. Now, there's all kinds of strategies for it, all kinds of failures for it. We're still in a learning curve, so to speak, and the problem is the people that are paying the price are the homeowners. Yes,
okay.
and I want to talk to you as we get going about this, because
I'm sorry to jump ahead.
No problem at all. No. Listen, I got 471 slides, and I'm always accused of going too fast, and we're not in an hour yet. I'm slowing down because I'm on 107. Okay. No, we can have some good discussion. I was just out in Vegas at the ASHI thing, and I had 365 slides, and I had 2 hours to do them. And I thought, man, am I going to get through? And I look up at an hour and 5 minutes, and I said, I think my words were, do you remember this? Oh, crap, I'm done. And here's what I said, because usually we don't have question and answer for my presentations because I have so much material. And I tell people, hold your questions till the end, because if I didn't cover it, then we'll talk about it. And that's not what I want you to do. I want you to bring up questions here, and if I don't get through all my slides, we can stay late. Okay, we don't stay late. But no, the discussion is good because we're all here to learn. I'm here to learn as well. I've got a lot of information that I've learned, but you guys can bring some stuff. I value the discussion. At EDI, I have students that call me with something they see and say, hey, Mark, I'm looking at this. What's your take on it? And through all my experience, I can usually give them a good answer. But there's times I want more information, so they send me pictures and stuff, and it's a good learning environment for me and my students. What my students don't know is I tend to learn more from their input that makes me better. It makes, and every time I present. So I encourage everybody to we're in this business first of all to provide for our families, make money, and we want to do a good job, because if people come after us, that takes away and from us. And I do a lot of going after of builders, and I think everybody in here would, if they knew all the cases, would say, and rightly so. We're trying to protect people. So the discussion and dialogue is good. Clearance needs to be. There's the LP, Diagram, 6 inches. Well, this is we're still on drive-by. So I drove by this apartment and this is what it looks like. Do you know what material is on the facer of the deck? It's hardy. Yeah. And Hardy says you will cover all of my tops with a flashing. That can't be done in this here. And the water will go right down between there and kind of be trapped to some extent between the Hardy and the deck beam. And deck beam, treated lumber that's always wet will rot and degrade unless it's foundation grade treatment. The above grade is 20 and 25% treated. Most of your 6x6 posts are 40% and foundation grade is 60%. I used to build treated wood foundations. I lived in one for a while. And there's a reason for those treatments. They got to preserve it. When you're doing that detail there, you've made it no longer just direct contact. You've actually equated below grade scenarios. And you can see how everything's chipping off. Yes?
Is that gravel intentionally put in between the wood and that gravel?
He's asking if that's gravel that's in between the wood. That's debris. Well, I just lost my. There, right in there. That's unintentional debris, and it's just garbage. It could be gravel. It could be chips of the Hardy that are falling in there a little from places. But what it does do is helps hold moisture better. You know, it might filter it. If you're thirsty, it might filter it as it goes through. I put these in here just for Mike. You like those? You were the cider, Mike. It's amazing what we see. And I had those. I wanted to show you guys. Vinyl siding. Any questions on this fiber cement board? Yes.
I was hoping you'd get, while you were on the roof, a lot of the new homes that I inspect, they put like a 1-inch or 2-inch aluminum, like a box trim along the roof surface.
Above the Hardy plank?
No, below the Hardy plank.
No, I'm sorry, at the roof sign, it's this little box that comes out and comes down like that, in a sense.
Yeah.
That is in the Hardy details.
Right.
For that clearance to cover the step flashing, because people want to cover their step flashing. So Hardy has come up with this little bent profile metal that covers that step flashing for the 1 or 2 inch clearance.
And then they slam the Hardy right up against the aluminum.
Right tight to the aluminum, yeah. Yeah. Hardy says they want a gap above the aluminum. And above it, if you had a trim board, they want a gap above it.
I have to go back and look at the manual, because when I write it up, the builders say, no, that's in the Hardy manual, that's the way it's supposed to be.
I'll tell you what, when we're all done here, you give me your contact info and we can have a discussion from afar, and you let me know and I'll send you some details. I make that offer to everybody I talk to. Please don't. I'm really busy with my own stuff, but I don't like anybody to drop between the cracks. So if you contact me, make sure if I don't get to you within a reasonable amount of time, and that doesn't mean 1 hour, a couple days or something, hit me again, okay? Because I have all these details, and I have massive storage on my computer. I have 8 2-terabyte hard drives. So, and hundreds of case files, plus it's all backed up to Google and to Amazon and a couple other backups so that I don't lose anything. And I still worry about that because they're all a bunch of legal files that I have to keep track of, and I keep track of everything else the same way. So I'll be happy to dialogue with you on it. Vinyl siding. It is a rain screen. Does everybody know what a rain screen is? It allows water to just flow behind it. Okay, there's intentional rain screens, they have rain screen material that you can put over and space your siding away from the house. But vinyl hung properly is already spaced, vinyl and steel spaced away from the house, so the water does run out of it. That's why it is the first deflection against airborne moisture. It's not waterproof by any stretch of the imagination, and that's why the weather-resistant barrier and flashing detail are very important. It's important anyway, but especially on a vinyl or steel-sided home, or one of these sidings that really isn't totally watertight. Your house should be able to exist for a week outside with a blowing rain against it, with just the weather-resistant barrier on it, no siding, without any leaks to the interior. Then you know your weather-resistant barrier is doing its job. So if you look at it and say, wow, that really could happen, that's a good thing. If you're inspecting a house pre-siding and say, no, I could get water in there, that needs to be fixed. It's important. It's supposed to be airtight and watertight, not just watertight. Your wall is supposed to be airtight, built airtight. There's a lot of walls that aren't. Your biggest leakage is under the plate line where it sits on that foam sill seal. I've got some pictures of some stuff we did this winter. Several people had frost on the inside of their house and icing up on the drywall. So we investigated a lot of that. Caulking vinyl does not make it watertight. So when somebody caulks around a window, say, I'm keeping the water out, you're probably trapping the water in. The only thing you use caulking on vinyl, it should be clear, because you're using it as a glue to hold the piece on. A lot of times at the top, they have to stick that little ripper in at the top, and instead of using the little notch trim and sticking it up there right, they just throw a bunch of sealant on that last lip and shove it up there. So that's the only thing you should use sealant for, is glue, if you're going to use sealant. That, look at that. Isn't that talented right there? This guy should be a trim carpenter. It's not right, but it sure looks good. There might be. Yeah. Good point. VSI, Vinyl Siding Institute, who is about the only ones who have installation manuals for their vinyl. More and more vinyl companies are putting a few details in, but most of them refer to the VSI, and you can download that thing for free if you VSI, Vinyl Siding Institute. You can download their manual. As they hear me say that, they're going to start charging you and giving me a commission. So get it now or get it later. The VSI says that you will put this piece of J 1/2 inch above the roof shingles. Now, there's no real magic for that, but there's a lot of heat that happens there, and they want you to be a 1/2 inch up. The thing I don't like about even the J on the roof, that nail is up this high above the roof. That's all. And you just punctured through your weather-resistant barrier, and you got a nail puncture. And if the guy didn't run the ice and water shield up the roof and up the wall, which they probably didn't, it is a potential leak point. And that J, by the way, focuses a lot of water. It catches it and it acts as a gutter and runs it down. And I'll show you later what that J really contributed to. This is an existing assembly. It's missing the flashing up here. These are all suspect. They wrapped those header pieces in metal. It becomes a bathtub, if you will, and just holds water because they don't flash them right. And then what's inside? Your wood header, right? It's just, this is the only thing the owner had seen, and they were worried about it. That is an LVL header. You're familiar with LVLs? Your nail gun almost doesn't drive nails in them when they're brand new, when the LVLs are new. You've got to nail them together. Your nail gun has a difficult time. You usually end up hand driving after you're done to set those nails. So it's a pretty stout piece of wood. There is my 12-inch rule. Does that look stout? Absolutely not. That's 12 inches. And I'm able to just shove it up through there. Right there, if they would have put this cap flashing on behind the vinyl and turned it up the wall and sealed it into the frame and brought the weather-resistant barrier down over it, this little baby right here would not be the bathtub any longer. It's important to have those headers clean, I understand, but they don't need to take a bath. Built in 2007, corrected in 2019. And the builder has had the wonderful and profitable privilege of doing this as many times on both ASV and vinyl. 350 times they've had to replace these headers. I'm their consultant. 350 homes.
Different houses. Okay.
Yeah. And these are a cheap one is $6,000. This one was closer to 18 to redo this. And
The builder?
what's that?
Are you working for the builder?
I am now.
Yeah.
I'm their consultant. It's the largest developer in the state of Iowa. They paid me six-figure consulting fees 4 years in a row. I've cost them $7 million, and I am on their side. I won't take a case against them. However, when a case comes to me that is against this builder, here's what I tell the people. Say, let me talk to them. I'm their consultant. They will pay me to come out and evaluate your problem, and they'll fix it per my recommendations. And it's worked several times, and it's a good deal. But I'm always trying to keep them awake and understand why some of this stuff is so important. And if I don't keep elbowing them, they'll fall back asleep.
Sounds like they're idiots.
Not these guys. I wouldn't say that. They're learning a lot. There's a lot of idiots out there. The ones that don't want to, willful ignorance. You know, we're all ignorant, right, of something. Ignorance is just we lack the knowledge in it. But willful ignorance is stupidity, and it's a lifestyle. And if somebody wants to be willfully ignorant, I'll happily educate them on the witness stand. The trim needs to be properly counterflashed. Can you see all kind of problems where water could get in behind? Sure. This is what it looked like.
Just suck the water right up.
Oh, yeah.
So when you mentioned properly counterflashed, does that mean that metal should be behind the house wrap?
There should be.
Hey, Mark, can you say that again?
He wants to know, when I say properly counterflash, he says, should the metal be behind the house wrap? There's all kinds of ways to do it. I give a lot of means and methods when I'm consulting. If I were doing this, there would be another piece of metal that follows down here and over here and caps over and closes that off. And then the house wrap would lap over that. So it shingles.
Hey, Mark,
Yes.
could you get away with siding tape at that joint instead of having the weather-resistant barrier overlap if you just tape that joint?
You can. There are details saying that you should, a window installation, for example, they want you to tape to the sheathing at the top and then lap the house wrap over it. Yes, you could get away with putting that Z flashing on there and taping to the house wrap, but it wouldn't guard against any possible water that might get behind the house wrap. Now, if nothing's getting behind the house wrap or very, very small amount, you know, but to do it right, and when you're open, you might as well do it right.
You can overlap the Z-flash, so you have to cut the paper.
Right.
Cut that paper barrier at the top, you overlap the metal.
Let me get
the
a,
top of the metal so that water can get back to it.
No one can hear you.
Sorry.
So the right way to do that is to cut the vapor barrier.
Cut the paper.
Install the Z-flash.
Fold it up.
Tape the top of the Z-flash.
That's right. That's
to
right.
the plywood.
Yes.
Then overlap the vapor barrier that you cut back over
just
the top.
like what I talked to Sean about a window, the way, same way you do a window. That's the right way to do it. Yeah. No, that's correct. This thing was just gone. The siding J acts as a gutter. Remember, all that water comes down here and shoots right down and in, and we see a lot of damage right there.
How did it take to get to that point?
This was,
5 years?
no, it was done in 2019. I think I said the house was built in 2007, if I recall right. Yeah, I'm surprised it took that long. You know, I've seen this kind of damage in as little as 5 years. Yeah. But from this right here to this, it just looks like it was when they built it. And if they would have just done a few things different, it wouldn't have cost them. Now, this is at the head of that door. This is at the top of that door, right along the top trim. And you see what's there? There's a weep screed. It's drainable. It's supposed to be drainable across that whole thing. So many times you'll go and find these grouted. You'll find a grout joint right along here. This will all be grouted shut. That's wrong. Horizontal transitions at stone veneer are supposed to be drainable. No caulking, no grout. And you won't always see that type of a weep screed metal. You might see a casing bead, but it's to be drainable at that point. There's the detail from the NCMA, from their MSV, and it does show, this is a window detail, but it's a horizontal transition, and it does show that open and drainable right there. The NCMA, you can look this up. If you were to look up NCMA space MSV, it should take you into the National Concrete Manufacturers Association website, and you can find this manual. It was formerly the MVMA. You can find their manual online, and it's a wonderful document for you. It's got all these little, that's figure 23 window head. It's got all 50, 60 little diagrams that you can output and put in. And I tell you, I think I've been through the manual 30 times. It's kind of like the Bible. You see something new every time you go through it, you know, and I see something new every time I go through this. It's been a while since I've seen something new, because I was on the editing committee for a little while, and then I get the newest version sent to me before it's released.
Hey, Mark.
And so I get a B up on it, yes.
Does this guide apply to stone that isn't manufactured?
Yeah, you do it the same way. There's another natural stone installation diagrams, and I don't think they're quite as detailed, but all the principles apply, the same things, because when you're adhering something, a lot of these details came out of the Stucco Manufacturers Association when it first started, because people started slapping the stuff and nobody had any method or means that were good. And so when Certainteed had their stone veneer, they produced the first manual, and it was back in 2006. And then they turned all their information over to the MVMA, who started producing manuals. And now the MVMA has morphed into the NC, taken over by the NCMA, National Concrete Manufacturers Association. And they're still producing manuals every so often. I think I'm on the 5th and 7th printing, you know, and there's a whole bunch. Do you have 5th and 10th? 10 minutes. Oh, 10 minutes. Till break? Yeah. Oh, very good, very good. Thank you. So wait a minute. I'm over? Always easier and cheaper to do it right. See what's up here? There's a kick-out flashing. You're going to have a kick-out flashing at every termination of the roof into a wall. It's required by most building material manufacturers, and by the building code. It's required.
The only issue is the gutter touches the wall. It's supposed to be an inch up.
That is an issue. That is an issue. Actually, that gutter isn't touching the wall. There's vinyl siding there. And here's what I will say about that. Hardy says to keep it 1 inch clear of the wall, to shorten it, the good point. LP says 1 inch clear, and Drive It and Stowe and Parex they're all pretty much 1 inch clear. Now, this is vinyl siding, and I'll have to go into the VSI because I don't think they call for clearance on it. And I still see this though on Hardy and everything. You can call out when they don't keep it 1 inch clear. They just want you to be away. And by the way, the gutter wouldn't work if it didn't have a kick-out flashing, if it's 1 inch clear.
Not only that, but gutters move a lot.
They do.
What's the clearance on wood siding? For this particular application, if that wasn't stone, it was wood siding.
You'd have to look at all your wood siding, and some of the wood sidings just aren't as clear. They need to be up off of the roof. I found a document that was 1968 that showed masonite required to be 2 inches clear off of the roof. And I started in 1976 in construction. Same year ASHI was born, right? We're getting old together. And I never saw anybody holding masonite up off the roof. It was always down tight. I will say that I see sidings that aren't 2 inches up. I've seen sidings that are only a ½ inch off of the roof that have performed relatively fine. So a gap is you'd have to find which wood siding, like the cedar or whatever, and dig into that. And the Cedar Bureau has all kinds of stuff, but a clearance is always good, and a kick out is required. And it's to be a minimum of 4 inches tall and 4 inches out. That's what the code says. Hardy wants you to be at a 110-degree bend, 4 inches tall and 4 inches out. They don't want you to be at one of these shallower bends. There's a lot of people that are making these shallower bends and they don't work. Another vinyl siding problem, right here. This was not flashed correctly. Those meter pins are this long. 100%. That's a relative measurement. Anything over 30 is saturated. I show an inch and a clearance. There, right there at the plate line. I'm reading 90. We can get through the steel siding. Steel siding is real simple. Same as vinyl. Is a rain screen. First deflection against airborne moisture. Not waterproof by any stretch of the imagination. Weather resistant barrier and flashing detail, very important. And I don't have any critiques on it. The same thing as vinyl. I just brought some pictures to show how good it can make a house look. This thing had real problems. It was rotting walls. It went from that to this. It's amazing what a few $1,000s will buy you.
All right, good stuff. Thank you, Hollis. And speaking of thank you, Hollis, thanks to Hollis and the whole MAC-ASHI team for putting this together. I have a pretty good appreciation for how much work these things are. So thanks to all of you for doing that. And I wanted to say thanks to Mike for a great presentation this morning. And I love how Mike takes complicated topic. I think electrical might be one of the most complex, makes it nice and simple and understandable. So that was very cool. I'm not going to spend my 5 minutes talking about our amazing Horizon product, which does, by the way, for Mike's benefit, encourage you to include the location or reverse polarity outlets. So it tells you to put in the location, task, and time, because that's the right thing to do. It tells you to put in the implications and illustrations that fit, and as a matter of fact, does that for you. So that's all fun. But what I'd rather talk about for a couple of minutes is pre-listing inspections, because they have kind of saved our bacon over the last 2 or 3 years. And I'm not saying they're going to do the same for you or work magically for you, but I did want to share our experience for what it's worth. So we've been in this crazy market up here in Toronto, a city of about 6 million people in Canada. And we have had the same market a lot of folks in the States have had, where we had bidding wars, we had not enough houses on the market, we had crazy pricing, home inspections getting bypassed. And then the pendulum swung and the market has been so slow, we don't have enough listings, interest rates are high, buyers are sitting on the sidelines. It's been tough for home inspectors the last 3 years, at least in a lot of areas. What has really helped us is communicating with real estate professionals about why pre-listing inspections make so much sense. And as a matter of fact, they became about 70% of our inspection business. And that's why I say they saved our bacon. When other folks were doing no home inspections, we were doing a lot of pre-listing, sellers inspections. And when you talk to an agent about it, the thing I love is that it's a win-win-win for everybody. There's no losers in pre-listing. So agents can use that to help win a listing in a competitive situation. And when there are not enough houses listed, agents are really fighting for listings. So they're bringing something different to the table. And then it helps the agent and the seller sell the house faster and for more money. So the pre-listing inspection can be a pretty powerful marketing tool for the agent and for the seller. It brings more buyers to the table, especially during the times when buyers were having to forego home inspections. The fact that they could get their hands on one can bring an offer to the table where people would otherwise sit back. I've always thought that home inspection made no sense, and I understand why it happened initially. But now that people are, for the most part, getting a home inspection as a buyer, why don't we do it at the front instead of negotiating the price, beating each other up, and then go figure out what it is we're buying? Doesn't make much sense anymore. So in a nutshell, it makes the transaction faster and easier for everybody, takes the 11th hour renegotiations off the table. Life gets simpler. And I encourage sellers to do it because you can take control. You can understand what the inspector is going to say, make sure the inspector gets it right. You're not going to have a deal fall apart because of bedside manner. And understanding that the buyer will probably get their own inspection, the seller may as well take control. If there's stuff that's wrong, and there always is, as we know, they can choose to fix it or just modify the price slightly. I have a long conversation about that we won't have. It also reduces your liability, in my opinion, because you're not under the gun. You're not having to produce the report same day. There is time to research, to get it right, to resolve controversial issues before the report gets out in the wild. What it's also meant for us is more inspections. So you do the pre-listing inspection, and then that seller is going to buy a house in a lot of cases. So we do a second inspection for the seller, and then we do an on-site review for whoever ends up buying the house and walk them through. So it has been good for our business that way too. And then the fact that the house is marketed with a pre-listing inspection by Carson Dunlop helps build our brand and gets us more visible in our community. I've got a presentation that I do for realtors. I've actually got a few of them on pre-listings. If anybody wants a copy, I'm happy to share. It takes a bit of work to make this work, but if you're serious about it and you want to have a look at that, just let me know. Send me an email at carson@carsondunlop.com. And I will shut up because I want to hear what Mark has to say for the rest of the afternoon. Thank you, folks.
That's Carson@carsondunlop.com.
Yeah, why I didn't put the email address on the slide is a good question, Hollis. I'm an idiot.
Carson@carsondunlop.com.
Yep.
Okay, thanks, Alan.
I'm with Monroe Infrared. We do a lot of events to support home inspectors across the country. I travel usually, instead of now, I either travel with or instead of handsome Bill Fabian. Bill had a grandchild and thinks he can stay home, and he's talking about retiring sometimes. So I don't think it's going to take. But come over to the booth. I'll show you some cameras if you're interested. Talk to you about CRT classes, taking a certified residential thermography class, and the cameras are real solid. We have the Hike Micro, the FLIR, and also we give the best after sales service. Anybody in the industry, we're always available. Bill loves to see photos from you guys and answer any questions you have, and pretty much 24/7. So thank you very much again for having me, and y'all have a great day.
If you need to get a hold of me, the building consultant.com. That's a singular consultant. I'm looking for the S. Okay, thebuildingconsultant.com. Wood composite LP Smart Side. Sawdust instead of silica dust, which they tell me that can kill you too. More substantial than fiber cement. It's not near as easy to overdrive the nail. Nails hold this product well. Edges do not fracture like what you saw. It's got its own brand of problem. Still has its issues. I'm reviewing some stuff right now. It's hard to seal that bottom edge on all of them. And it's got to be sealed or else water will wick up in it. And I've got some that I'm actively watching right now. And right now I can get a probe up through the bottom of the siding, up vertically about 1.5 inches up. And it shouldn't be, but that's because of water capillary action through the siding. It wasn't completely sealed nor maintained in seal. I'm just going to go over some of the good details with it. Yeah, you got to have roof clearance, 1 inch. There's your clearance above the Z flashing right there. There is your Z flashing where 2 pieces of vertical siding go together. You need a Z flashing, you can't button caulk it. Got clearance there. What's missing there? No, it's not. No, it's not. The vertical, the gutter, the roof doesn't return all the way in. That was a trick question, guys. There's no need for a kick out there. All the water flows into the gutter. There's no wall. It's not butting into the wall. If the roof butt clear over here into the wall, If the roof fan in there, then you'd need a kick out. Trick question.
While we are on that subject, I'm over here.
Yeah.
Earlier you were talking about the gutter where it meets the siding, and I believe you were saying the gap should be 1 inch for most sidings between the gutter and the siding?
Yes, 1 inch.
Okay, because then you got into talking about the clearance from the roof.
Yeah,
So
yeah.
1 inch from the gutter to the side.
Yeah, yeah, yep. And this has the 1 inch clearance, by the way, from the roof line, right there. Mounting blocks for penetrations. And if you notice, there is no flashing on top and it's cocked. That's PVC. And that is a PVC block there because grade is too high. That's a PVC. So it doesn't have the wood earth problems. However, the wall behind it does. But that's one way of taking care of it. Sometimes you deal with what you deal with. Remember we talked how dumb? That's even dumber.
Okay, sorry. So what is the solution in that case?
On that?
Yes. Caulk it completely, or what's the
I
solution?
can't tell you that.
You can't tell me. Okay.
No, that's technically correct. If it were on my house, it would be caulked all the way across.
Okay.
And then I take responsibility for it. Yeah. But they want you to have that gap. Definitely on the longer ones, it's more important. These smaller ones, I say it's not, but who am I? You know, unless LP's listening to me right now. Let's talk. No, that's fine.
Okay, so on your house, you would caulk it, but as inspectors, how do we address this? Call it out?
I'm not an inspector. Here's what I'll tell you about the houses that I do get called in for to look at, and it's in a case or so, you know, it's because I see a lot wrong. If that was caulked on that little deal, myself, I wouldn't call that out. And on a dryer vent, I would not call that out myself for going, if I'm there looking for problems, because on these houses, I show you, I would not call that out in my report. I will, however, call it out that the back damming wasn't right when I stick my wire in it, you know, at those locations. If I could stick a wire in behind there and there, I'd call that out myself, because it's open, the back dam isn't open. But if that was caulked right there all the way across, water's not getting in. This was a house recent, and I'm going to show you, just step you through some things I found that's wrong. What is that material on the deck band? That's LP. Does that look like that's going to perform over time? Let's see what LP says about it. Trim and fascia are not designed for siding or structural applications and should not be used as structural members in construction, such as trellis, railing, fence, decking, deck trim, or sills. See the underlined deck trim? Not used. So I let them make the case. It looks pretty. Right now, it looks pretty. But when it starts to rot, it's not going to look so pretty, and it's going to rot. What's wrong here? No flashing. And I get messed up here. No flashing and too close to the ground. We'll show that. Here is one of LP's details for Craftsman pillars. And if you notice, right here, there's a gap and a flashing, right? So that kind of goes with what was in the previous. There's no flashing over that horizontal transition. Here's another one. This shows a flashing at the horizontal trim board. I don't care that there's siding there and brick there. I'm showing the flashing is to be a horizontal trim board.
I've had multiple conversations, arguments, whatever, with builders about bedding that lower trim and ceiling. Is there a reference, hard pass reference that we can use for that?
On this lower trim down here in sealant?
Over the brick.
The MVMA shows it in their documents for adhered stone, or the NCMA. It shows a bedding sealant. I think I have that detail later on. Clearance off a grade, right? 1 inch. Right here. Minimum 1 inch clearance. A siding applied adjacent to porches, patios, walks, etc. must have a clearance of at least 1 inch above any surface. There's the call out. That's from LP. What's wrong there? I just read it, didn't I? 1 inch. 1 inch. That's a garage door jamb. Okay. You can't use LP for a garage door jamb. And why is that? Well, you could if you want to hold it 1 inch up. But if you hold it 1 inch up, right? What happens right there? It's 1 inch up all the way through. So this little thing comes down and touches, and you have a little 1 inch mouse door, right? So you shouldn't use that. Hardy, however, can be 1/4 inch off of the, and then you could caulk that mouse door shut. I was just at a trade show with LP, and I showed them the pictures, and I said, "What do you do here?" And the guy made a bold statement: "Well, you can't use LP for garage door bucking." You know, and I was surprised to hear him that quick and that bold say that. But he might have retracted it. Oh, I'll guarantee. What's wrong there? No mounting block. There's the mounting block for LP. It shows it. This is what I was talking about. It says you shall paint and finish all edges. That's not finished. It's not completely sealed shut. Water will wick up in there. That's not sealed shut. You're supposed to be this house is not a year old yet. Went through one winter. The ground heaved a little bit, fractured it. That's the LP. This is under a covered porch. Hardy does make provision for lower clearance under a covered porch, but that ain't Hardy. That's LP, and they don't make a provision 1 inch from the concrete.
Hey, Mark.
Yes.
Is there a good way that you can tell us to tell the difference between Hardy and LP on site?
Yeah, if you take a 1/2 inch drill bit and drill through it, you'll have wood dust come out with the LP. It'll be kind of a woodish, and with the Hardy, you'll probably dull your bit, and it's a different sawdust. So that's one good way, but that doesn't quite meet what you were wanting, does it?
Non-invasive or non-invasive way?
What's a bad way? Well, I can tell the difference by looking at it, and it's a lot looks. If you can see an edge of it, you know, Hardy on their, okay, oh, by the way, you know you're not supposed to miter LP trim? If you ever come and it's all nicely mitered and 45, you're not supposed to do that. It's supposed to all be butt and overlaps. Hardy, when you look at the end of it, a lot of times you'll see those there's 3 little grooves in the back and they'll be cocked shut. So there's one way of identifying it. And the grain pattern is different in the Hardy than it is in the LP. And typically, well, they mix and match trims so much. I don't know that I've ever seen an LP job with Hardy trim, but I've seen a lot of Hardy jobs with LP trim or with Miratech or something. So yeah, you just gotta get familiar with it, you know. Drive a nail in it. That's not good advice. Yeah, there's a difference in the graining. But there's also some different materials that are fiber cement too. Allura makes some, so its grain pattern is a little bit different, you know. Okay, AMSV, AKA cultured stone. Have you ever heard it called cultured stone? Cultured stone is a brand name. It's not really called cultured stone. It's a brand name, but it's like Kleenex or Band-Aid, right? AMSV, adhered manufactured stone veneer. A stucco really code addresses it as such. The newer codes are getting more specific with it, but the older codes still fell under the lath and scratch, exterior lath and scratch. Needs to be installed in a drainable manner. You need a minimum of 2 weather-resistant barriers. And that's not the best drainable way, but it is a drainable way, okay? And then all your horizontals, your base and over your windows and doors, it should all be drainable. It should never be cocked shut. Weave screeds required at the roof line. You're supposed to be above the roof line and you're supposed to have a drainable member at the roof line. They say officially 2 inches above, you can get away. It says 2 inches above. I don't call it out if it's 1 inch above and you got a roof screed. I make a judgment call myself on it. Your flashings are accessible so that over the course of the ownership of the home, when you have to maintain the roof, you're able to get it. If it's ever, I see it grouted tight to the roof. Anybody ever seen it grouted to the shingles? What are you gonna do when you change your roof? A hailstorm comes through. Do you have hail out here?
Yeah.
Do you have snow?
Occasionally.
Everything's green out here. My area is, I just got cherry blossoms on my tree, but the rest of the trees don't have leaves on them yet. My cherry tree doesn't even have leaves on it. It's just got cherry blossoms. I sure hope there's gonna be cherries this year. It was cold, yeah. Casing beads recommended. Casing bead would be at a vertical transition, and it makes, when they put the casing bead in properly, it makes a nice detail for the backer rod and sealant that should go in. Now they have a newer product called, let's see, a couple of different companies make them. One that I know of it's called Easy Bead, and it's a plastic casing bead, and it's already got a backer rod on it. So you shove it in tight, and then you can just caulk it.
I see a lot of that stuff. Sorry, my legs are getting tired.
Yeah.
I see a lot of that stuff, just the casing bead, no backer rod, no sealant. It's like the punch out guy didn't come back and
yeah, they should
do it all.
They should be sealed. The scratch coat is supposed to be 1/2 inch thick. And they're using a lot of these rain screens with the paper facing on them, the scrim coat on it. The lath is self-furring lath, so it's got these little dimples in it that's supposed to hold it away from the wall so that when you put the scratch coat on, it scratches up behind and then trains and encapsulates everything. When you put it over this flexible rain screen, you no longer can get the lath self-furred, it's tight against there. So when you put the scratch coat on, it doesn't embed the back of the lath. And how many of you know that galvanization is water soluble? Did you know that? I'm just calling it different. But galvanized washes off. That's why the old metal barn roofs are rusting now. And that's why there's different levels of galvanization. So they put more on and it won't happen as quick. But the thinner the metal, the less galvanization they get on it. So this lath, if it's exposed to water, will wash the galvanization off. And then when the raw steel is there, it starts to corrode. And when steel corrodes, it expands. And you're not going to resist that expansion. I've got a bunch of buildings right now, 8 of them, that's got thin brick on it. And all the thin brick is coming off and being replaced because of a failure of the rain screen. A lot of water got behind it. Now it shouldn't have, but still the rain screen's there to manage the water. And it did fine managing the water, but the galvanization washed off. And there are places in this thin brick where it's bubbled away from the frame by 2 inches. It's moved out that far. And when the sun comes right over the edge of the building, this is on the west face, and you get it just right, boy, you can just see that. And I monitored it for the builder, and then it all turned into a big deal, and now it's being replaced. And the new stuff we're using is a rain screen by MTI, and it's already got it's got fiber lath, which is a fiberglass lath on it, and they're able to get a 1/2 inch scratch coat on it. It was hard to get them to put the 1/2 inch on because they're used to putting 5/16 inch on it, which isn't enough. Everything says 1/2 inch nominal thickness, and that's to, like I say, to encapsulate the lath completely and protect it from moisture. I think I have some pictures of some of the details. Double grade deep paper is a minimum. That's your, when you double the paper protection. Better an intentional drain membrane, because this brings forgiveness to the assembly. If I have a drain membrane there and it's applied right, so what if a little water gets in there? It drains out. MVMA, now the NCMA, has plenty of documentation available. Rope weeps are not an effective means of draining. I saw one time where this guy took a rope, stapled it to the wall like this, and then brought it out over here, and then put his lath and scratch over that. And somehow he thought the water's going to follow all that and then weep out. Very interesting. Clearance that roof lines are required and not grouted to the shingles. I just told you 2 inches and a weave screed. AMSV requires backer rod and sealant joints at transitions to other materials. Any dissimilar material, you have a backer rod and sealant. That would be windows, that would be doors, door trims, any trim, any siding, any other. If you're going against brick, you're supposed to have a backer rod and sealant joint there. AMSV can be installed over insulated foam wall sheathings. Foam greater than 1.5 inch in thickness generally requires an engineered fastening system. When you're applying that lath, if you're going over foam, let's say in extreme, your foam is 2 inches thick, and you put that lath on, well, those fasteners are cantilevered in that foam, and there's no resistance. So it requires an engineered fastening system. The roof-to-wall transition flashing is a must. That's the kick-out. A pre-molded kick-out flashing is the best way to address this transition, but not the only way. Pre-molded is my favorite kick-out flashing. Surface applied flashings at the roof line does not meet MVMA guidelines. Sometimes on a brick job, on a re-roof, they put the step flashings over the face of the brick, and then they put a surface applied counter flashing on to counter flash those. You don't do that to a stucco system. Especially if you have a rain screen behind it. It's supposed to be draining any water. Now you're draining it all underneath. Outer layer of weather-resistant barrier is to block capillary action. This layer is sacrificial. That's when you're using just 2 layers of paper. That outer layer actually becomes sacrificial. It rots away and then leaves a little gap. The weather-resistant barrier requirement predates the 2000 IBC IRC. I have it clear back to 82 UBC. It was required. EIF's documented problems. This just shows you the documented problems in EIFs, and based on thousands of history and industrial professionals. This would be the same with the AMSV too. The kick-out flashing. We're at, depending on which blue you want to go with, we got a windows in blue. We're either 33 or 40%, 43 or 30%. Sealants, 10%. Decks, 12%. And windows, we debate on whether that's a kick-out or a window. Those show where problems are because they're not detailed right into the EIFs or into the stone veneer. Here's one that I was called to look at. We got a question here. Yeah, back up.
Back to the manufactured stone.
Yep.
I've seen a bunch of new houses where they have that, and there's absolutely nothing in between the stone, no mortar joints. There's no mortar in there.
Oh, no, that's dry stack.
That's okay.
Yeah,
okay.
Is it okay? It's got its problems, but it's approved. It's
okay, because it looks like water can get right in there.
Yeah, oh yeah, it does. And I talk about it. If they don't have that bedding coat complete on the backside and there's voids in it, that water can get in there and sit down in the south. It's not going to be as big a problem unless it boiled and steam popped off the roll. I hadn't thought of that. But in the north, it freezes and then it's 9% water or expansion, and it just can jack that stone right off of the wall. This is one, they had this problem, a little bit of efflorescence. And then you go in under that porch, a little bit of efflorescence. And then there's the fascia, it's starting to deteriorate. And there's a kick out that somebody added. Does that look even remotely correct? No, but it's funny. Yeah, it's funny. It's supposed to be all the way behind, Now this is in the basement, okay? Right below where that kick out was. This is the floor trusses with OSB rim board on them, also known as vertical mulch. Now I'm in the room under the trim measuring into the wall plate, elevated, 75.8 on my meter. This is after a rain and after everything's dried off. And here's what I say. After everything else is dried off, that which is still wet is drying out, not drying off. It's very telltale. You can really learn a lot about a building after everything else is dry and something remains wet. Let the demo begin. This was cheap back then. This has been 10 years ago, 47,000. It'd be more expensive now. Always easier and cheaper to do it right from the start. There, it's all gone. And notice where all the damage is, right here. And a little bit of leakage around this window, but there's where it was. Now, they get all new because you can't just fix a little bit on this adhered stone.
I got a question for you.
Yeah.
Do you use a thermal camera to look at stuff like this? Or would it show up with a thermal camera?
It depends. I'm a level 1 thermographer. I've been doing it a long time. I have an expensive thermal camera. I play with my camera on these things. The conditions have to be right to get an accurate read, especially same with EIFs. You know, that's an insulated, it's hard to get it. And there's times that I never rely solely, definitely, on my thermal imager. I use it as a tool, as another diagnostic tool. But on this kind of thing, I don't rely on it heavy. Now, if I need to, I do relocation inspections for several relocation companies. If it has stone stucco reefs on it, it's a mandatory inspection. And most generally, I'm drilling and probing and moisture meter in stuff. This one I didn't need to, I already did it on the inside. But I use my thermal imager for something other than these exterior problems. It's not 100% reliable. I would never rely on it alone and say, oh, look. No, there'd be all kinds of drilling and probing and other tests. This was down there, that vertical mulch down on the floor truss. Now we have a good kick out in. The drain screen is on. Getting the scratch coat on with kickouts, and all metal lath is supposed to be encapsulated. You should not see any metal lath. So I had to call this out while they're doing this. Right there and up there, you should never see any metal lath. You can see the weep screen. Remember I told you the clearance above the roof? That's above, they can service those shingles. That's what it looks like when it's done. There's a good example of how to put a kick out in. That's a dry flex kick out. That's a good kick out. 6 inches out, 6 inches up. This was one of my calls, reviewed online and emailed photos. This lady calls me and says, Mark, I think she read my kick out article. And she says, I think I have a problem. I think there's a kick out missing. I want you to come out and look at it. So I said, send me pictures and let me look and see. And she did. She sent me a bunch of pictures, and I said, not only do you have this and this and this problem, but you got this and this and this. Go look at it and see. And so she said, I definitely want you to come out. 1,100 miles one way. Missing $15 kick out flashing. Ended up driving out once to assess. And then I produced the report for the builder, and he tried to fix it. She was not happy with it. So she said, can you bring your crew out and fix it? I said, now let me call the builder. So I called the builder, and I went out for a week and managed his subcontractors to fix the problem. It ended up costing a total of $36,000, by the time I was done with my fees. She put me in a suite for a week and paid my travel time. And I drove both times because I need my stuff, my tools. Oop. I think I said 36. I think we were at 38 because 23 and 15 is 38. Oops. Maybe I overcharged.
Where's your home base? Where are you out of?
Des Moines, Iowa. God's country. There are some of those. Yeah. This is the house, $2 million house, 2 years old. Pinehurst number 7 golf course. This is my first trip. There's her living room. I call that the weeping outlet. The trim, showing a little bit of disruption. Right there's the missing kick out. There's the house as I pulled in, and take a look. Remember what I told you? That is wet after it's all dry is drying out, not off. Here is quite the deal. This area right here handles 300 gallons of water per inch of rain. This one handles there's 0.62 gallons in 1 square 120 gallons off in 1 inch of rain. And if you have a little rain barrel there to collect, that's 50 gallons. But Al Gore will fly into town and hang a green medal around you and him will both sing in your Kermit voices. It ain't easy being green. A lot of water. Secondary kickouts, both of them missing. The primary kickout. My thermal image shows the water, shows the temperature difference, conducive with water. I double checked it with my moisture. I'm in scan mode there. I'm in pin mode on the dryer, and notice it says 3.3, and I said drywall is considered wet at 1. And you notice my little mulch. Oh, there it is. There's the mulch. Now, while I'm here, let me check out the crawl space. Notice look at that. Aren't crawl spaces supposed to be sealed? Well, this one wasn't. So after I was done with the report, the crawl space guy spent 3 days doing what he should have done in the first place. So I was and you can see all the rot where it was wet before, where it stayed wet. And this is 2 years old. There's a window leak as well. And vendors, and half of them don't wear a belt. And it's terrible to see them walking around the job site. You know, their pants down around their ankles, and they think they're a builder. So, and I left once that was done, because the only thing left to do was glue the rocks on, right? And apparently they got it right. It's not hard to glue the rocks on. Let's inspect one. There's one of my illustrations from the level of detail that you can get from the MVMA or NCMA that you can compare. This is a newer detail right here, and this is a multi-floor detail, so a 2-story. And do you guys do any EIFS inspections at all? Do you have a floor line expansion joint on a 2-story? You're supposed to be. Well, supposed to have it on a stone veneer job too. It's supposed to have a floor line expansion joint. And this shows that right there. That's a newer detail. This is, again, a drive-by. Here's the problems I found. 1, 2, 3, 4, and 5. Clearance from hard surface is to be 2-inch minimum. This can be reduced to 1/2 inch if frost protected. This is a hard surface, this is the driveway. We're not clear enough. It does have a weep screed, which I'll show you later on why, who cares? It's wrong. There's the weep screed, there's the nomenclature. It tells you 2 inches from paving, 4 inches from grade. Lap weather resistant barrier over the weep screed, right? Lap it over. Why? Because you want it to drain all the way down, and if this is over foundation, if that was a continuous foundation all the way down, and you didn't lap it down to the weep screed, it's not going to drain, right? There's what I'm speaking about. AMSV may overlap foundation wall with careful installation of flashing. They mandate a 6-inch flashing right here. I never see it. And when you're inspecting it, you don't know if it's there. You can pretty much be sure it's not, because I've never seen it go in that way. Most of these guys don't read these directions, and it's available in Spanish. No sealant joint at dissimilar materials. All joints at dissimilar materials are to be backer rod and sealant type configuration. So there's no sealant joint. Here again, at the window or at the trim. This is the nomenclature for it. It shows that backer rod and sealant next to the trim right there. It's supposed to be a 3/8 inch joint in there. Pella says 3/8. Other window manufacturers say 1/4, but the MVMA says a 3/8. I'd be happy just to see a joint. There's no cap flashing across the top of that trim. There's no flashing across the top of that stone. This is over the garage door header, so it's missing a flashing here, and it's missing a flashing here. And you saw that vinyl sided job where it was bad, and that other stone veneer job where it was bad. These guys can expect the same thing. Here. There you go. Got it? This shows where they want the flashing. Trim materials be clear, 1 inch clear of the pavement. That is LP. There's LP's nomenclature saying it. Now this is the interesting part here, over to the side. You see the weather resistant barrier? That's okay. You see the rain screen? Comes down and stops where? Right here? What would we call this scratch coat that's directly a dam? That's exactly right. Because the water can't make it down. As a matter of fact, all the water is focused down through the rain screen right to about the plate line or a little below. And yeah, it may come out this side here, but nowhere else. Drainable material about 2 inches over the foundation. Stone veneer adhered directly. Drain material and weather resistant barrier need to come all the way down. You see where it all stops, see where it's all colluded. There's a picture of one I went to look at. This is an example of what's happening. Does that look right? All of this material needs to come all the way down over here, right? So I show up and I'm looking at it and look at the scratch coat. It's already on, right? Oh, what's happening right there at the arrow? What's that guy doing? No, at the arrow with that hammer in his hand. What's he doing? He's pulling out. What's holding the lath on? Why? because I caught it in time. Now they're tearing it all up and tearing it off. And there's a guy that's pissed off at me. But I'm calling it out. There, now notice, it's back on and it's over it. It's all fixed. When you see something like that, it's wrong. It's going to cause problems. Need a mic?
Yeah, I was just curious if he. Use the mic. I was just curious if he knew what the problem was, or did you inform him what the problem was?
I informed the owner of the problem, and I had a diagram for him to fix it. Yeah.
Okay.
No, they had no clue.
They had no clue.
And you know what? They still have no clue, because he would go to the next job and do it exactly like that. Because he doesn't, they don't know. I got that job where 8 buildings are being torn off right now at a cost of $1.9 million and being redone. And the guys that I'm working with there, I'm finding stuff wrong all the time and telling them why. And they're starting to do it right. But I know I got to watch them on each and every building and remind them, which is pretty crazy because we're right here and here and here and here, and they're not doing the same details. And then as soon as they leave, they'll say, I'm glad that was done. We can get back to normal. And normal is way down. Scratch coat is to be 1/2 inch nominal in thickness and cover lath completely. Very rarely do I see it over 5/16 of an inch thick. And I don't remember a time that I've ever seen it completely cover the lath. And remember, that keeps the galvanization protected and keeps it on the wall for the long haul. This is down tight because that's frost protected concrete. That's the stoop. So that's okay. Kickouts. There's a view of it from the MVMA. Roof clearance. Notice 2-inch clearance and a weep screed. This was a relocation deal I did in the middle of Nebraska. The people had already moved out and moved on. And unless the inspection comes back clean, then the relocation company won't buy it until it's fixed. So I get there. No clearance, no weep screed. How do you service the shingles? You can't. 20% right there, it's elevated. Even more elevated down a little ways from the lack of the kick out, because water has a tendency to spread out at about a 45-degree angle. What? Oh, that didn't belong there. This is up and around the corner. These people never knew. The builder probably didn't know. This is how the house was finished. This is another one, no kick out. This is down the basement, looking at the cantilever. Turn the light off. Look underneath the cantilever. It's all the sheeting is mulching out. Okay, though, the mulch was a little bit thin in that bed, so a little bit of, they can replenish. And this right here is the eye joists, just cantilevered over with no bottom seal on them. That's the bottom eye. So they laid plywood down on top of the eyes in between the joists. Just all kinds of things you see that are wrong. There's the view. Sean, you asked me about the embedment. That's the figure 3 wall assembly, and it shows the bedding seal in the
Is there anything from BIA or specifically brick?
You know, I'd have to look at that. I'd have to look at it.
I didn't find anything.
Yeah, yeah. Make your own BIA 2.0. Missing the bedding sealant. It's not protected behind the vinyl. That's an incorrect shingle lap. The scratch coat is over the top. So any water that comes down there gets on the face of the scratch coat and down in behind. All fixtures are supposed to be mounted on their own little block and caulked in bed, exterior flange, and sealant at the plaster ring. Same with dryer vents. Any penetrations are supposed to be sealed. That's not sealed. That should be sealed. Now, the right way to seal it is put a sealant bead from here up and around over the top and leave the bottom open. And you can peel the sealant off if you have to change the fixture. But right now, there's nothing keeping water from going down there and following the wires into the wall. And it takes a while for this stuff to happen. But I see a lot of worst case scenarios. It didn't take as long as you'd think. That should be sealed right there. Leave the bottom open. It is on a mounting block. That's right. And the electrical outlet is on a mounting block, and those particular electrical outlets have a foam gasket around the outside, so it's okay. That's wrong. Should have a block, a mounting block. The deck needs to be flashed in properly. Not down tight to the deck. And when you look under the deck, notice all the efflorescence coming. Anytime you have efflorescence, it's telling your masonry structure is sick. It's like it's got a fever. Look at that. We got all kinds of water getting in that wall. This thing is 2 years old. Over the windows, up the door, up the side view, and at the sill. Completely cocked in, or grouted in, I'm sorry. No flashing, no sealant joint, no nothing at that window. It's not sealed at the bottom, water can get in. No head flashing and drainage detail, no backer rod. And a lot of times they're using these new self-jade windows where your vinyl siding, you don't have to put J around it, but they're using them for stuff like this, and you can't get it sealed, so it's a big water path. As a matter of fact, Hardy has a specific detail on flashing a self-jade window if you're using Hardy siding products. They have a special detail adding a special kick-out flashing at the bottom lap. And it's one of their tech bulletins, and you can look it up. That's that integrated J that I was talking about. They want you to caulk it at the soffits. That's not right. Grouting to anything dissimilar is wrong. Let's see. This is one of my videos. Let me go back. There. You can't hear that, but if you ever do moisture testing, you can feel the wire, and you go through it, and then you know you're through it, and then you can do your moisture testing. And we teach this stuff at EDI if anybody's wanting. You ought to get into it if you don't. And for you guys who don't want to get into it, one of you guys get into it, and you guys can all refer this guy to be the tester, and he can make the millions. Well, thousands. Well, hundreds. And you need to clean those holes out well, because when you fill them with sealant, if the dust is still in there, it doesn't take, and then next thing you know, somebody's blaming you for all the water. I just use air dust to do it, and you seal it. I want to show you something here. That little pinhole right there on the sealant didn't catch. So you got to check your sealant and make sure that it's right. Just a stain. This was 9 years old. This is the after it was done. This is the group. I stamped a picture of them as I went out. There's 3 engineers, 4 attorneys, their clients. I showed this one time at an engineers gathering, and somebody says, hey, no, it's not going to work. Hey, is that so-and-so? I said, well, yes, it is. He said, I'd recognize his butt anywhere. I said, oh, no. Now I got to start blurring butts. But this was one, and they all thought, those guys are waiting for me not to be able to produce anything that I'm going to produce to them. So they're waiting for me to fall flat on my face. That ain't happening. No kick out. Water staining, a telltale sign of a problem. We opened this up. I'd already tested it, so I knew it was vertical mulch behind it. And what does God bless me with? 2 earthworms, 7 foot above grade. And I made real loud mention of that when these guys were over there. I said, hey guys, look at this. Earthworm heaven. You want to see? And I didn't get much giggling that day, but that's what it looked like afterwards. I was hired afterwards to oversee the correction of this. It looks like a fire, doesn't it? That's what this looks like once it rots. This was the only thing on the garage right here. You couldn't see it from the inside. No visible damage. But I had done a couple moisture probes, and I knew that that's what I was going to see. There's the window, and take a look at this miter joint right there. Nothing in it. There's supposed to be a little foam gasket. This is a window company that's in Iowa, and we didn't bring them into it. We let the builder bring them in. So that was a strategy on our part, because they're big dogs in the fight. And they said, oh, we don't have any problems. And then they found this, and they were very, very interested. That's what caused all this damage at this window. It's that window company that starts with a P and ends with an A and has ELL in it somewhere. No, that was a manufacturing defect off of the line. Oh, they got interested. Yeah. Yep. Then I became the builder's consultant. He was a friend of mine already, a good friend. I'd framed for him, and all of a sudden I'm in this against him. And we had a great relationship. And my clients stiffed me on about 10 grand, but they got their house fixed really, really well. And they still tell you that it was the best experience they ever had. And I want to send them that $10,000 bill. Say, guys. Oh, no, no. Listen, I've got referrals from them like you can't believe. They just listened to the wrong person, tell them that I charge too much. And that was my builder friend. Of course he's going to tell them. No kick out, high moisture, rotting all the way down. Problematic detailing here at the fireplace chase. No kickouts. The stain, right? High elevated moisture. Let's go inside at that little box out and take a look. Let's remove some insulation. It's all mulched. There's the Tyvek, the paper. All I did was scrape the mulch with my bare hands out of the way to expose the Tyvek. It's here. These things are prevalent. This is how it looks once it's done. Clearance off of the roof, 2 inches. Flashing and counter flashing. Kickouts. They're big and they're bold, and a lot of people say they're ugly. These people say they're beautiful. Flashing detail and drainage above the window, above the trim. Drainage. A big sealant joint at the window. A good sealant joint, a proper sealant joint. And where the stone abuts to the eaves, backer rod and sealant joint. A lot of work done there for all those penetrations. That's all PVC. And it creates a place to seal around those holes really well. It's a lot of work. 612 slope, you can't have any flat spots on eaves. No flat spots. All of it's supposed to be a minimum of 612. They did not want to be 2 inches off of the pavement. So, yeah, that's PVC, but the stone. So we cut all that out of there, put backer rod in, and put self-leveling sealant. So now if the slab ever goes up, it can't touch the stone. So you get creative in some of it. Notice the clearance around the stoop. There is and this is all protected. A home show home that I was called to look at. 6 inches too high, wood earth clearance problems. There's a nice job. We side around our meter bracket. The contract states an iron handrail, right? Look at the metal. That has a component of iron in it.
Iron nail.
No, that metal screening up there.
Oh, yeah.
That passed as an iron handrail. Well, I think it was upgraded from chicken wire to cattle fence. Flashing needs to be embedded. It's not. It's got the proper clearance, but it's not painted under there. We got a lot of water coming off of that roof. We got same problems here. Just some nasty work on a $700,000 home show. You remember here, no backdamming. Supposed to caulk there, but then you can see the nomenclature. There's a barcode sticker right there, so I could have found out what brand it was. Got water intrusion into the breaker panel, into the meter box. Clearance is wrong. Kick out is poor. It's not 1 inch away. It's not painted on the cut surface. This acts as a gutter, and that will all dam up down there and flow behind. That's supposed to be 1 inch up. the builder said that we're gonna put knotty alder beams in here. He put another wood, poplar, and then stained it the same color as the knotty alder. And same there. And then this is it's a 2-level basement. So this would be the main level of the basement. And then this is the second level here. And do you have any idea what that looks like? The spotting? It is. It's the sump pump. And he put it down in this closed cabinet where all the vapors come up. And because it was the lowest spot. And that thing, and notice all the bleach. That's the homeowner trying to mask the smell. Yes.
That was a full bag of damp rid?
What's that?
That was a full bag of damp rid in
Yeah.
the picture?
Yeah. But look at this, bleach, 1, 2, 3, 4, 5 bottles of bleach. And I look at everything. The sliding door scrapes all the way across. Just doesn't put it in right. That one ended up in a lawsuit. She was an attorney. Her law firm handled it. I knew the day before they went to court when I was prepping with them that they were probably going to lose. They said a blue-collar jury that didn't have a $100,000 house amongst them. They made the trial take 9 days. The people get paid $25 a day for the first 3 or 4 days, and then $35 or $40 a day for the balance. They had to take vacation to listen to her talk about her $700,000 house that was in disarray. And they made her seem like a real whiner, which she couldn't let go of some of the smaller things and focus on the bigger things. And she lost, and she had to pay attorney's fees. The next case against this builder, we got him, and got him on consumer fraud and everything. And I wish we could have got him here, because it was a righteous judgment. This one wasn't. And it was a shame. Now she built a new house, and she called me out to look at all the problems there. And yeah. Got a call, had a flood. Can you help us? Oh, you know I can. I'll be right over. So I show up. Here's what it looks like. See those sandbags?
Very attractive.
Yeah, see all that flow toward the house? There is a little bit of a swale here. I used moat as a legal term on the report, because I want to, doesn't moat tell you something? If you hear moat, yeah, it said something to the attorney. The dam, that's the dam. The moat and the dam. This is looking around the house. Look at all the sinkage of the backfill, 10 inches. They had been after the builder to get back out there and correct all this stuff for quite a while. Oh, I'm now the builder's consultant. This is how I laid it out, all the water that comes in, directional water flow, 45 times 51 times 1.6 times 7.48 divided by 12. You don't need that fraction, but here's what you do need. 2,288 gallons of water in this measurement right here, flowing towards the house per inch of rain. Does not take into account the others. There's the moat and the dam. All the water in the moat flowed to the area and breached the dam. Inside the night of the breach in the dam, oh, there's that water, there's that window. right? See the water line on the window? My yellow water line? Here we go, guys.
Or a waterfall.
Far too generous. Please think of that.
Somebody smarter than me is gonna have to get this to work. Doggone it. There we go. There we go. Everybody wants a water feature. Yeah.
I'm suggesting that the septic system on the yard.
What's that?
Is there a septic system on the yard?
Oh, no. Oh, this was a rain.
No, I know, but if there's a septic system, then it's probably overwhelming that and causing it to mix.
Oh, no, 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 no. No, this was all the breach in the dam, the moat. Yeah. That was quite the, I'll let you see it one more time, just for effect. Builder responsibility. Oh, by the way, while I'm there, the builder did install a swale in the yard to help manage the runoff of the water. Owners had made the builder aware of sinking backfill on numerous occasions. Builder's warranty rip claims no responsibility whatsoever. The house is only 9 months old. Owner has been trying to get the builder to respond to this detail since month 5. So I'm outside looking again at other stuff. No clearance at the Hardy from the steps. It's all been fixed, by the way, right now. It's all been fixed. And no clearance to the Hardy at the stoop. There's the Hardy detail. There's the clearance under protected areas. They do have the 22.5-degree angle cut. I called it out and let them know they did well. What's wrong here? There's no drip loop. You need a drip loop because water surface tension's down and will come right in and corrupt that. There's a drip loop. There's a nice detail. And that's not a mounting block. Neither's that. And we don't have protection of the Hardy or sealant. What's wrong? What's correct? How much longer do we have? Okay. Oh, that's fine. Let's see. I'm good because I'm going to slow down here because I'll show you some others. Let's talk about things. Any questions on any of this? No? Either I'm doing awful good or you guys just want to get out of here. Oh, here's a question.
So on current EIFS installations, does there have to be a weep screed, some sort of drainage plane? Can they seal it all the way down to the foundation wall?
EIFS itself?
EIFS.
It's supposed to be it's supposed to be drainable. All EIFS is now supposed to be drainable. Now, it's not a weep screed, not for EIFS. They have different.
Just a drainage plane of some sort.
Yeah, it's supposed to be drainable. And that is at all your window heads, door heads, any horizontal transition. You're supposed to have 2-inch clearance off of the roof. You know what system is it? Is it Drive It Par-X or do you know?
It's probably a Drive It here.
Okay, yeah, well, Drive It has some great details. It shows.
When it transitions to the concrete foundation, there needs to be some sort of transition there, then, is what you're saying? Because right now, it just, well, this is the house I inspected, there is none. So any water vapor that's coming out.
No,
is
no, where
stuck.
it transits to, okay, so the wall sits on top of
And
the
they-
foundation.
And then they drive it the foundation
All the way down?
all the way down below grade.
No, it's got to drain.
Right.
It's supposed to drain. Yeah.
Thank you.
You can confidently say it's supposed to drain. By the way, EDI has good training. Did I make a plug for EDI yet? Okay. Yeah, that would be Exterior Design Institute. Yeah. Okay. Air sealing, importance. What is our final air barrier in a house? No, the drywall. And it needs to be sealed. And do people seal it? No. No. You got a plate that's built here, and you got a ceiling that's coming here and a wall that's coming here. That plate is to be sealed somehow to keep air from entraining down. And they don't do it. It's in the energy code that you seal things up. It's not real explicit, but it's implied. We had a cold winter in Iowa this year. We had a couple real below zero blowing events. I had 5 houses that had ice and frost on the inside of the drywall. And so what I did was, on the next cold day, go with my blower door and do a blower door test. These houses all passed the energy regulation of 4 changes per hour or less. But just because you pass that doesn't mean that you're air sealed correctly. And then I'm able, with my thermal imager, after this blower door runs for a little while, to go in and find these blue streaks, and that's the air where it's leaking. And I find air leaking under the plate lines of walls, air entraining in down through the attic and down the face of the wall. I even have some air coming all the way down that wall cavity and out underneath at the floor in the middle of the house. And 3 of the 5 are now in current litigation for this, amongst other reasons, but for that. Let me show you this. This is just a little graphic. Those baffles should be at every truss space, by the way. See, there's the air sealing, one method of the air sealing. And it needs to be good sealant, not 25-year siliconized acrylic. Do you guys know how much insulation you need here? How thick? R49. R49. And that's 17 to 20 inches. You show me 14 inches that gets an R49. I don't think, yeah. I mean, I'd like to see it because we don't have it where we are. And I've got 3 cases going right now on it. But this just shows you, and listen, if that air entrains into the insulation at all, it ruins the R value. This is the homeowner's picture. It says 37.7 degrees. Do you think that spot is 37.7? Absolutely not. That is 1 pixel. And it's got a spot that's 1 inch at 1 foot, 2 inches at 2 foot, 3 inches at 3 foot. It averages it all together And at 6 feet, he's taken a 6-inch. My thermal imager has 177,000 pixels in its field of view. So if I am right here and I can get that whole wall, that's 177,000 points of measurement. When I'm this close, I have 177, it's pretty accurate. That thing is averaging, I'll guarantee that that's a lot colder than 37.7 degrees right there, but it's still low. You see that? Frost. Frost on the wall there and there.
Is that a northern exposure? I can't.
On this particular wall it is, because it was blowing from, if it would have blown from the south, it would have had the same. But the house faces north and northwest.
Was that vinyl siding?
No, no. It's the house that I showed you with the LP on the deck. There's my thermal image, and all those deep blue spots are really cold. I'm at 50, 71 is my hot spot, and 51. Anytime there's a 20-degree delta, that's enough to be concerned about. And this is under the wall, and this is all air entrainment. That would have blown a match out. It was coming in that strong. His outlet. Now, to be fair, we get a lot of this anyway, but not to this extreme. Not to that cold temperature. I'll see barely anything coming out of a well-sealed house. This is coming in from the attic and going down the walls. Now, the 101, you can see where the hot spot is. It's a light. Yeah. So it's got a 50-degree delta, but you know what that is? It's a tiny smoke machine. It puts out smoke like you can't believe. So I'm outdoors on his lower patio, squirting the smoke up underneath the siding right there. You see, this is a video. Yeah. Sometimes I can't get those things to work. Can you see the smoke?
Yeah.
That's coming in from me being outside. And only the demand letter has been written on this one. See the wisps of smoke? The attic. Now that's the garage, to be fair. It was supposed to be insulated, but that's the garage. There's in the house. Yeah. Well, to be fair, there's probably 6 1/4. We need to be accurate. And there's our rating. For R49, we need 17 inches. Now I'm on the roof. I'm looking at this wonderful roof ventilation. There's a lot of guys who don't do roof ventilation correctly. The code says a couple things. It says it'll be 1 to 300 unless both of the following are true. And one of the both, the first one says it'll be in zone 6, 7, or 8. Okay, we're in zone 5, so that's not true. And the other one is at least 40% of the roof ventilators are up in the top within 3 foot of the ridge line. And so ideal for a ventilated attic is 50-50, but they allow 60-40. And I didn't do all the roof calculations here, but on most of them I find they're wrong. And if one of the big problems is people just don't calculate them. When you put hardy soffit in, that's 5 inches per lineal foot around the whole thing. So even no matter where you're at on 50-50 or what your minimum roof ventilation is, let's just say that I got 1,500 feet and I want it's 1 to 150, right? So that's 10, right? And 150 goes into 1,500 10 times. So that means 5 is intake and 5 is exhaust. Well, they may be over that, but what I got to do is go find out what they have for intake first, what actual intake is. So let's just say they need 5 and 5 and they got 10 down here. So they need 10 up here, or they could get away with 80 because, or 8 because of the 60-40 split. I think I did the math right. But you got to look at the intakes, and when you do that, it's amazing what you find. You find all kinds of miscalculations on. I'm on a commercial building, and that was my last phone call before I left Des Moines, was with the architect and explaining technicalities on ventilation, and they're refiguring. But there's a lot there. No. No. Tell me what's wrong there. That's the deck stairs. What's that? They're hung on that face right there with nails this way, and that's the only hanging. They're supposed to have a back strap or a back anchor, and they should have a board all the way across here, you know. So that's another call out on this job.
The air's not a structural member?
It depends on how dense the air is, and it changes with the season. So maybe in one season we're okay, the other seasons we're not. And then it depends which way the rain's coming from. What's wrong there? They used to allow you to lag into your posts, but not anymore. You got to notch your posts. And here we go. Remember where I talked to you about angles? There's 1.5 inches. There is the detail that's is grooved into the side of the joist hanger right there. And you can see this nail is long, a long nail. It doesn't tell you exactly what to do, but right up here, that right there is the web address to get the information. But this picture shows you they need to be long nails. 1.5 inches would stop there, right there. So it's pretty well spelled out. I don't know that they put that diagram on in Spanish though. Wow.
Mark, somebody's wanting to know the name of that fogger you were showing a few minutes ago.
The name of which?
The fogger.
Oh, it's a
smoke generator.
A tiny S.
Tiny
S. And I got that from Retrotech. Yeah. It's about $900. Yeah, I can buy a whole house fogger from them. It's the big S. I don't know what they call it, but it'll fog a whole house for like $1,500-$1,600. And I'm gonna get one so that I can fill the whole house and put my blower door in reverse and just go outside and find my leaks. And then I can do that in the summer, because it's hard to do that. You know, you need 20, 30, 40 degrees to get really good on that with a thermal imager in the, they tell you 20 works, but I don't, I like 40 better.
There's a real inexpensive portable smoke generator called a Wizard Stick that runs on like 4 AA batteries.
Oh, I have one. I do have one.
Yeah, they're great. They're cheap, which means I can drop it and not really get upset.
Yeah. I tell you, the guys from TEC, Minneapolis, came out with a little puffer, and I have one of those. They're about $60. And what they use a vaping device, and you fill it with your glycerin, and then you puff it, and you can watch that thing. And it really, that tiny S is not good for low volume, for looking at an outlet, because it puts out too much. But that little vaping deal, it's a turkey baster that they modified, and it just squirts it out really nice, and it'll put it where you need it. This is your Q&A, guys, because that was my last slide. 5 minutes? Okay, you got 5 minutes. Keep in mind, I put that up there, thebuildingconsultant.com. You guys can contact me. And like I say, if you send me an email, my email is mark@thebuildingconsultant.com. Send me an email. Really spell out what you want to talk about, and leave me your contact info, because I may call you. And if you have any pictures, send them. I'd be happy to dialogue with you on stuff. Yes.
So how would you gently place it to the buyer or the realtor that you're working with that the hardy backer is too close to the roof, all the issues that you went over?
Gently?
Gently, yes. Where you can get another referral from the realtor.
Kids?
Yes.
How do you gently tell them anything? No, because well, you already know this. When you're telling a realtor something's wrong, they're worried about you killing the sale. And so the odds are all against you anyway. I don't know that they're going to take you as harsh anyway. A lot of people take me as harsh until they get to know me, and even then they wonder. But I don't try to come off as hard. I try to just lay out the facts. Here, look at this, and
we don't kill sales. Houses commit suicide.
I would agree with you there. No. Let's see, wait a minute. I'm going to say something, and that builder's going to think I hate him again. The builders killed the house because they didn't pay attention to the details they were supposed to pay attention to. And I would tell that to my best friend if he was a builder, and to some of my guys that I consult for that I consider really good friends and allies. I'll tell them, because I'm watching out for their interest. Somebody else is going to come take them apart if you don't help them up front to start with. You're just telling them, quit playing in the middle of the freeway in rush hour. If you want to do it at midnight, have somebody watch, make sure nobody's coming.
They want it done fast, they want it done long enough that they don't get to you. That's all they care about.
And that's the problem, because most places have a statute of repose. Iowa is 10 years. So if you're a builder that does something wrong and it causes damage, your customer or the next buyer or the next, something shows up in 5 years and it's the 6th or 7th homeowner, they can still come after you, the builder, for up to 10 years. Now, we also have a clause that if you knew or should have known about it for 5 years and you didn't say anything, then they're off the hook. So quite technically, if I'm the original owner and I'm watching something and I see a stain and it's 5 years and a day after I saw the stain, technically I don't have a case, although I don't know how they'd prove that day. you know. Yes.
They come across problems where things are actually installed properly, still have stuff in them that go to the manufacturer of the product.
Okay, the question was, have I come across problems that were installed with things that were installed properly and following the guidelines, and who does that land upon? That's something that would have to be fleshed out. I have seen things that were installed properly that were poor. Sometimes there's a material manufacturer defect in it. So in the case of CertainTeed weatherboard siding, even if you installed it completely correct, it still had problems. So that went in a class action lawsuit. And that was the best thing for CertainTeed because nobody got any money, just the attorneys. I'm adjusting a little bit, but all you attorneys out there know what I'm talking about.
Okay.
Sorry.
Am I going? Is this on? Can you hear me? We had a couple questions about what I had said earlier about tail coverage. So what tail coverage is an extending reporting period after you go to retire. If you close the business or something like that and you want to cancel your policy, but you want to still have coverage for your previous inspections. If you're an ASHI member and you go to retire, you get 5 years of free tail coverage, which 3 years of tail coverage is roughly around 200% of a normal policy period. So 5 years is roughly around like $6,000 if you were to buy it off the market. So I think, getting 5 years of free tail coverage is good. One thing I didn't talk about as well is I've got state-specific inspection agreements, addendums. We talked about pre-listings and everything like that. Yeah. Ever? Okay.
Okay, thanks everybody for your attention. Does anything else we need to? Anything else? Everybody just wants to get out of here. The sign out token is THAW, THAW. If you're having trouble with the sign in, sign out, if something's not working right for you, hang around, talk to me over here. Unless anybody has anything else. Yes, JT.
Say something about OMG.
The OMG. So the online meeting group meets on the first Wednesday of each month at 8 o'clock. Go to cyberashi.org, CYBERASHI.org. And I think you'll be glad you did. So the first Wednesday of every month, cyberashi.org, 8 o'clock p.m. Check it out. You'll be glad you did. Anything else? THAW. It was spring was the sign in. Thaw is the sign out. THAW is the sign out token. And I think we want to let Mark and Mike know how much we appreciate them.
Thanks, guys. Thanks. Hey, on your way out, I had some more pictures. This is a brick job that I was looking at. And take a look at the steel. I told you about expansive corrosion. The steel beam started life out at a 1/2 inch bottom on the flange and a 1/2 inch top. It's now 1 inch on the bottom and about 1 inch on top. Brick cannot take the movement. It expands, it blows everything apart. Then I go into a brand new parking garage and here's what I see. Do we think we have problems here? This thing is less than 10 years old. Look at all the steel expansion and corrosion. That happens when the salt off the cars goes down in, finds the cracks, it expands. Steel theoretically can expand 10 times its original thickness. I've never seen 10 times, but I've seen double. So that's something to watch too when you guys are out there. Yep. Thank you, guys.
Thank you to Hollis and everybody else for putting on this fantastic presentation.